a little intro, Carl, and I'll kind of pass the ball over to you, if that's all right.
Of course.
All right. Okay, here we go, recording. All right, so good morning, everyone. My name is Rune Storson. I'm serving as the Executive Director at the Center for Catastrophic Risk Management at UC Berkeley. Professor Roberts was unable to make it this morning, so I'm filling in instead. My background is in civil engineering, sociotechnical systems, as well as forensics of critical infrastructures. And my research interest is focused on safe and reliable infrastructure. So thank you all for participating in our workshop today. This concept of distributed safety was discussed at a previous workshop back in 2019 in the pre-pandemic days. The topic was reinvigorated recently due in part to pandemic conditions easing a bit on us, as well as more information becoming publicly available related to the specific instance here of distributed safety related to the Boeing 737 Max incident. The nature of these aircraft is that they're shrouded in trade secrets and confidentiality, which makes it quite difficult for an outside party to confirm or refute the purported safety. They're forced to rely on trust. So before we begin, just some background on our center. The Center for Catastrophic Risk Management was founded in 2005 in the wake of Hurricane Katrina. We're a global group of applied researchers from academia, government, and industry who've come together to develop pragmatic solutions for the complex, multi-jurisdictional, messy problems of the 21st century. We conduct fundamental research on catastrophic risk through empirical data. By identifying and engaging targeted teams whose experience and expertise are uniquely tailored to each challenge, CCRM aims to make the mess manageable. And with that, I'll hand the baton over to my colleague, Carl, and we'll kick off the workshop for today.
That's great. Well, thanks, Rune, and thanks everyone for joining us. It's wonderful to see everyone. I think I'm expecting, as Rune mentioned earlier, we'll have a few more dial-ins as the session progresses, but likewise, we may also have a few people stepping out as the time zone shifts quite dramatically over here in the UK and Europe. So please feel free to participate in whichever way suits you throughout the course of the event. So I will just flash up these slides here to kick things off. Great. And hopefully you can all see those slides. It's always somewhat disconcerting when it removes my view of everyone else from the screen when I start. So yeah, as Rune said, this workshop emerged in part from discussions around the challenges of managing safety and reliability and risk in highly interconnected complex systems, and the Boeing 737 Max crisis has really provided I think quite a dramatic and very rich and tragic example of the sorts of challenges and issues that are faced by organizations, manufacturers, operators, regulators in really dealing with some of the more complex and sophisticated technologies that we currently use in our societies. So perhaps I'll just open by giving a brief minute or two to situate the session, and then it would be, given we're a small group, it would be helpful, I think, to go around and just take some very brief introductions as well. So just to start, as no doubt you'll all be aware, we have a situation. Actually, 3 years this week that the second 737 Max aircraft crashed, the ET 302, and the FAA grounded the global fleet after the two catastrophic accidents in which 346 lives were lost. Now, this event has generated enormous and really quite remarkable extent of scrutiny from a range of inquiries, investigations, and other reviews into the regulation of the aviation system, the certification of aircraft, the manufacture and design and operation of the MAX in particular, and more broadly the system as a whole. And I think what's striking is the complexity of the learning processes that are being attempted are as complex as the sociotechnical system itself. It's also entered the public imagination in quite a dramatic way. This was a grounding of a global feat of a kind that had never really been seen before in modern aviation, and a couple of recent public pieces of cultural contribution in the last few weeks and months of a major Netflix documentary and a major Penguin Random House book, which are both fascinating and I would highly recommend as interesting background items. But in terms of this event and what we're here for today, our intent really is to start a conversation around what can we learn from the 737 Max. Of course, there's enormous amounts being learnt around the aviation system in particular, but I think our intent really is what can we learn as this very rich source of inquiry around the management of risk, the understanding of reliability, the organisation of resilience. What does this event tell us more broadly around these sorts of challenges? And we've structured today as many of you know who we've been in touch with over the last couple of weeks. It's really very much an initial conversation. We've structured this around a number of topic areas and questions. We're interested in things like what are the challenges of learning, how does culture drift in organisations, how do regulators coordinate and communicate, particularly around early warnings and weak signals, what are the challenges of thinking about and governing highly automated systems, and we've invited you all, a number of key and esteemed speakers to engage in what we have put together as an initial set of conversation areas. So the issues around how do we investigate and learn from complex failures? What's the challenges of regulation and safety oversight? How do we engage with processes of trust and certification of complex technologies? What does it look like to govern and engage with complex systems with very challenging ergonomic issues, highly automated systems? And we're very lucky to have a leadership perspective from Christopher Hartless, former chair of the NTSB. What are the issues around public administration and what are the role of audits and fundamental assumptions in the management of risk? So these are the sorts of conversations that we're keen to start. We've got an outline schedule, but as I've indicated, this is really about having a series of conversations. So we've invited a number of people to provide thought-provoking, either short or longer presentations or discussions or provocations around each of these particular broad topic areas. And I'm delighted that we've got such a wonderful set of speakers and participants here with us today. I think what we'd like to think about is to use this really as a jumping off point for a number of conversations. Perhaps as the discussions evolve, maybe this will evolve into a broader program of work. I certainly feel that there's the opportunity to bring together, perhaps work towards over time an edited volume or perhaps a more international major event that brings together a range of different theoretical, conceptual disciplines, perspectives on these events, and really explore what we can learn from the Max, from the range of perspectives that we will bring to this inquiry. So that's the background and the introduction to what the session's about. We've got I think at the moment we have, so we've got 13 people in the room at the moment. We'll have a few more joining as we move along. As Rune said, they're speaking, giving presentations to others at the moment. But perhaps I'm mindful of the time, and I'm keen that we make the most of our discussions together. But perhaps we could just do a very, very brief introduction to people in the room. The intent is very much that this is a discursive forum for conversation. So perhaps if people are willing, they might be able to, if I go down my list and invite people just to offer an introduction, who they are, where they're from, and perhaps just one question or interest that you have in relation to this particular event, the 737 Max, the 737 Max crisis and the issues. And perhaps as I know, Professor Braithwaite, Graham will be launching off, so maybe more predisposed to offer a brief introduction rather than me picking on someone from the list. Perhaps I can start by, many of you, I think I know many or most of you, my background is in the organisation and management of safety, particularly in complex systems. So I'm based at the University of Nottingham. I'm particularly interested in how organisations interpret and make sense of disruptive and challenging events, and how they organise for reliability in line of that. So perhaps I could invite us to go around the room and just that level of introduction, so we get a sense of who's joined us today and where we're all coming from. And Graham, perhaps we could start with you.
Yeah, no problem. So I'm Graham Braithwaite. I'm the Professor of Safety and Accident Investigation at Cranfield University. I also run a bit of the university that covers transport, everything from autonomous vehicles across to being the accountable manager for our flying operation, which involves a 33-seat flying classroom.
Fantastic, thank you. And must surely be one of the few universities, or certainly in the country, if not the world, to run its own 737. Is it 737?
So we have a ground-based 737, but we're certainly probably the only one to own and operate an airport, air navigation service provider, maintenance, repair, overhaul, and aircraft operation. Fantastic.
Well, thanks very much. Perhaps if I go down my list here. Next up is Dr. John Downer. Perhaps you might just introduce yourself and offer a few words. Good to see you, John.
Hi, good to see you, Carl. Yeah, I'm John Downer. I teach at the University of Bristol. Yeah, and for a long time I've been interested in the sort of the epistemology of how you go about demonstrating and that a complex system will be extraordinarily reliable in the way that jetliners and reactors and stuff do. And I've written a lot in this regard about the certification process by the FAA and jetliners.
Brilliant. Thanks very much. We'll going around simply on my screen here. Perhaps Professor Watterson, Patrick, would you be kind enough to say a few words?
Yeah, sure, Carl. Thanks very much for the invite to take part in this. I'm really looking forward to it. I'll probably have to, shoot off around about our time at 8 o'clock or so, 9 o'clock, we'll see. My name's Patrick Watterson, and I'm Professor of Human Factors and Complex Systems at Loughborough University. Loughborough is not very far from Nottingham. We're just up the road in the UK. I guess what I'm really interested in is why do so many accidents have many common characteristics, and why do those characteristics just recur time and time again? And I think my presentation is going to focus a bit on sort of like what we can learn from other sectors, learn from aviation, but also what can we learn from, say, like healthcare, because there's some similar things going on there as well. So it's very nice to meet you all, and thank you very much. Thanks.
Thank you. Thanks, Patrick. Well, going around my screen, but Bob, sorry, I don't know your surname. But would you be happy to say a few words? I'm embarrassed not putting a name to a face now, but please.
I'm Bob Entien. I'm a recent affiliate of the Center for Catastrophic Risk Management, and my background is in health research. My chief interest currently is in pandemic preparedness, And I'm attending in part as an orientation to the work of the center. I should tell you too, by the way, I've already had 2 mishaps with my computer. So if I disappear, it's it's not a function of my reaction to what's being said, just technical difficulties, and I'll get back in as quickly as I can.
Thank you. Thank you. Well, we won't be offended in that case. Well, perhaps going further on, John Vincent, perhaps it's wonderful to see you. Thank you for joining us. Perhaps you'd be kind enough to say a few words.
Yeah, thanks, Carl. And thanks for the invitation. And sorry if my voice sounds a little bit rough at the moment, but I'm suffering. Well, we've got COVID in the house here, so, you know, it's not so good. I'm formerly of UK Civil Aviation Authority. I was an avionics specialist then. I was involved in the certification validation of the 737 next generation in the 1990s. So I kind of feel, you know, what happened with the Max is so sad in comparison with what I think we did a very good job with the certification of the next generation aircraft. I worked for EASA, European Aviation Safety Agency, for 11 years in Cologne as part of the setup of the organization. And there I was Deputy Director for Strategic Safety. So safety management, safety planning, occurrence reporting, accident investigation, all the safety related subjects at a corporate level. So that's me.
Wonderful, thanks very much. And it's great to have you here, and it'll be fascinating to get your perspective.
It's going to be fascinating.
Well, perhaps if I move around to others that are on the list. So perhaps Barbara Holder, I don't know if you're happy to say a few words and introduce yourself, or perhaps it's wonderful. Wonderful to see you, and thanks so much for joining us as well.
It's great to see you too. I just got a new camera, so I have to adjust it. Well, thank you so much for the invitation. It's very nice to meet you all. I recently joined Embry-Riddle Aeronautical University as a presidential fellow and associate professor in the College of Aviation. Before that, I was at Honeywell, where I did research on avionics and operations. And prior to that, I worked at Boeing. So I lived a lot of the issues that sort of are manifesting as part of the 737 Max crisis. And it was a very difficult time, and I left Boeing for a number of reasons related to that. And so it is tragic, and I'm hoping that we can make a real difference in turning the industry towards a better safety culture. My primary area of interest is in procedures in flight deck and training of flight crews.
That's great. Thank you, Barbara, and it'll be wonderful to get your perspective, both research and well, firsthand, of course, as well. Thanks for being here. Now, I have this situation where, of course, the list jumps around on the screen once people have spoken. So I will say, perhaps, Caroline Jones, would you be happy just to offer a few words? Very nice to meet you.
Yeah. Good morning, everyone. Really excited. I'm having to breathe a lot to be here. There's a lot of you folks on the line today are referenced throughout my master's, so this is really unexpectedly exciting. Even yesterday, I sent out Drop Your Tools by Dr. Wyke out to some of my colleagues. So my research is applied, and it is I focus on high reliability organizing, the principles, and incident command, and how to do sense-making crisis leadership during complex environments. I just worked with the Coast Guard for the last 12 years and have just moved to Parks Canada. So I'm Canadian, and I now work with wildland firefighters, folks who do, I've always done search and rescue marine. Now I'm working with search and rescue terrestrial, wildland, human interactions. I do incident reviews. I do after action reviews. I've been deputy incident commander on the first unified command in Canada on a very small amount of pollution in Vancouver Harbor, but a very, very big event that had a lot of folks involved. So that's me in a nutshell, and I'm just really, really thankful to be here. So thank you very much.
That's wonderful. Thank you. And is it Carolyn or Caroline? Just so that I'm pronouncing it correctly.
It's Carolyn, but
Oh, yeah.
Caroline works as well. Yeah.
Thank you. Yes, and I love your background as well. That's great. Perhaps so going around the screen. Professor Wyke, I'm absolutely delighted has joined us, and if you're willing to I think you perhaps need no introduction, as your reputation far precedes you. But if you would be willing to say a few words of introduction, that would be wonderful. But no pressure, of course. Perhaps it's just ducked out, or we will return back. It's always the risk of calling on people with just icons on the screen. Let's see. Perhaps I could just ask who have we not speaking to? Oh, so now I'm going to. So is it Singers Turkoglu? We've met many years ago, and I'm sorry I can't remember how to pronounce your name. That's very embarrassing. If you could educate me, I would appreciate it.
No, don't worry. Good morning, good afternoon, everyone. Cengiz Türkoğlu from Cranfield University. In fact, I work for two of your speakers today. Work for Graham as in the center, and I lead the MSc Awareness, hence my interest in the topic. I've been trying to follow the Max stories since the early days, in fact, going back to 787 groundings and all the way back even before. But I also work with John Vincent within IFA as the VP Technical of International Federation of Airworthiness. Clearly, we have an interest from that perspective as well. IFA is an international organization, which is actually a registered charity in the UK, and we particularly focus on continuing airworthiness issues. So I look forward to today, and my particular interest is also, I recently posted on LinkedIn, which I said, since the days of good old Professor James Reason's organizational accidents and failures, and they keep happening. And complexity is increasing, and they keep happening within aviation and outside of aviation. I gave examples of DuPont and others as well. So, yes, it's a phenomenon, but I hope we can learn something out of them. Thank you.
That's great. Brilliant. So I'll just go around. There's a few names on the list, I believe. So Esfandia Imani. I'm not sure if you're on the line or the phone, but if you're willing to, good to meet you. Hi.
Yeah, good morning. Thank you so much. Very well to say my name for the first time. Thank you again for this event. My name is Esfandia Imani. I have more than 25 years experience in energy industry, which is different than aviation and all that. But last 10 years, I've been involved in operational risk management, and currently, actually, I'm a colleague of Dr. Rune Stursen in Safer Tree Corporation, where we focus on risk reduction, reliability, and resilience of organizations. And my interest is, as an operational risk manager or in management. Of course, there are many contributing factors to any events, catastrophic events, and there's so many escalating factors. So I just want to gain more insight into what led to this catastrophe, basically. Yeah. Thank you.
Super. No, thank you very much. Thank you, and it's wonderful for you to join us, and we look forward to the discussion. So I think there's perhaps just what I've been doing this in random order, but I think perhaps just Howard Foster, if you're happy to just introduce yourself and offer a few words, but again, no obligation if you prefer not to. No, it looks like.
Okay.
Oh, hello.
Oh, I am. Okay, I'm simply a lurker. I'm actually a GIS researcher with the center. A friend of mine is an engineer at Boeing, and we've had many, many discussions on this topic. So that's why I want to hear what you all have to say today. Thank you.
Oh, that's great. Well, thanks. Good to hear from you. Please feel free to lurk as much as you wish. It's delighted to have such a diverse group of people here today, and I know that we have Paul Schulman and Ian Mitrov joining us later as well, and perhaps one or two other people who have registered and whose name I recognise. But we shall see how that evolves. And as I've said before, obviously we're juggling two very distant time zones here. So as things move on, feel free to duck out as the evening progresses. Well, thank you for the introductions, and perhaps without further ado now, I'm glad we've all had a chance to sort of step into the speaking space briefly, but I'm very keen to hand over to our first speaker, Graham Braithwaite. And as I've described before, we're thinking in very broad terms around thematic issues, and we've been inviting speakers to really frame the issue as they see fit. So I'll be fascinated to hear Graham's perspective, and been very much looking forward to this. So Graham, perhaps I'll hand the floor over to you. Thank you.
Thanks, Carl. Really appreciate that, and thank you very much for that invitation. When I heard there was a chance of going to California, I was really keen, but Teams seems to have done for that. But let me just put up a slide to talk to, if I may. So just check that works. Okay, brilliant. So I'm going to talk a bit about investigation and learning, and I have the privilege of going first, which hopefully sets the tone in the right possible way. This is me and my day job, and in fact the university is one of the few to actually have a 737, which was actually donated to us by British Airways some years ago, and which is looked after by Cengiz and one of his colleagues in particular, but actually features as part of a research centre that focuses on digital aviation. And digital aviation encompasses all sorts of opportunities around how we use the data that platforms like this collect, but also needs to consider some of the challenges that go along with it. So I will declare that one of the sponsors of this research centre is actually Boeing, but so are aircraft operators and people like Etihad. We've got airports like Heathrow involved and so on. And actually, if you just walk a little bit further on campus, you find Airbus, you find Saab, you find Rolls-Royce, all sorts of people involved. So I certainly don't wish to speak for or against. I'm speaking in an independent university capacity, but just so you get a broader perspective of what I do, I also have a role with British Airways as their independent safety advisor, and I think straight away we start to uncover what it is that's generally good about the culture within aviation when it comes to learning. And my brief as independent safety advisor is very simply described as go anywhere, talk to anyone, ask anything. I think there's a recognition that within any company, the longer you stay there, the more blind you become to some of its faults. You perhaps get better and better at figuring out a way around the problems, but you don't always get quite so much exposure to, well, what is everybody else doing? And I think my contribution is generally to sometimes ask really stupid questions where everybody else in the room knows the answer. And that's the downside to the fact that there will be other questions that I ask where nobody in the room knows the answer. And the reply is often, why, what does someone else do? And I play that role not just for BA, which of course is not a MAX operator, but for TUI, which is a big holiday airline, which has an operation out of the UK as well as across Europe. And they were a MAX launch customer, certainly for the UK. And I've sat on their safety review board for a number of years. And again, if we think of a culture, I can remember joining that board and thinking that the first thing I was going to be expected to do was sign a non-disclosure agreement. That's absolutely what I was expecting. And when I asked the CEO, an amazing lady called Chris Brown, about that, she just looked at me strange and said, but no, the point is, if you're here and you see something that's wrong, tell us. We're the board. We're empowered to fix that. But if you see something that's right, tell everybody, because we don't compete on safety. And look, that sounds like a really pithy phrase, but actually everything I've seen since then has been absolutely the embodiment of that this is an organisation that was also the UK launch customer for 787 and a whole bunch of problems that came with that. And the problem isn't just how you get it into service or indeed how you unground an aircraft, but they're layered on top of all the other crises that come along. So, you know, I can remember our biggest topic at Safety Review Board was at what point will the MAX be ungrounded, only to be eclipsed by what on earth is leaving EASA going to do for the UK and what problems does that bring, to the next conversation being there's a disease coming out of China. I wonder if that might affect us at some point. And what you realise is that, of course, the crises that many organisations are dealing with are layered upon many other crises or challenge or whatever. But if I come back to the topic of focus, which is around learning, I wanted to start really with where I got involved in developing interest around aviation safety. And look, I was 12 or 13 when this happened back in 1985. In fact, it was the day before my 13th birthday. And I was on holiday in Italy, and I can remember seeing newspaper headlines of all those imported newspapers of these horrific scenes of a 737-200, which had caught fire on takeoff out of Manchester Airport in the UK. And some of you know that 55 people died as a consequence of that. But they didn't die because it was a product that was being operated outside of what a regulatory environment required, or that had been in some way the consequence of deviant behaviour. You know, actually, here was the conspiracy of many factors that came together, including the wind blowing across in a particular direction as the aircraft turned off the runway. Now, this was an uncontained engine failure that led to a fire, which very rapidly led to the cabin producing poisonous fumes and gases and so on. I'd say 55 people died. And although the 80s feels a long time ago now, at the time it felt very modern. I couldn't believe that we would build something that so rapidly would become such a poisonous and hostile environment. You know, people died running over each other over the seats as they folded down, trying to find an exit. They were trapped in exits and they were asphyxiated by the smoke and fumes. And look, this had a really profound effect on me, because some years later, as a university student, I sat and found the report and I read it. And what I found fascinating was that the learning that went on in those formal investigation reports. Although in hindsight, of course, much of the focus was on a much more forensic examination of technical failures or the behaviour of frontline staff. And quite a lot has changed since then. But that story does remind me of a conversation I had with Professor Dave King, who's one of our visiting professors at Cranfield, and is in fact the only person who's taught on our accident investigation course since it started in 1977. And that makes him sound like he's 100, but he just started young. And it was going back about 10 years ago, and he just retired as the chief investigator of the UK's not for blame accident investigation branch, our air accident investigation branch, the equivalent of NTSB. And we were about to run a course in Sweden, and I'd purposefully booked us the exit row on our particular flight. And as we're sat chatting, Dave's reflection was how difficult it is as an accident investigator to look back on your career and know whether you've actually made a difference or not. Because, of course, if you do make a difference and you prevent something from happening, how on earth can you possibly claim that's because of your actions? And that's, of course, because of the way in which we report on safety, generally through negative performance. And I was quite shocked by this, because I said, Dave, you were the investigator in charge at Manchester. And as a consequence of that report, we're sat in an exit row that's wide enough for people to get through. Our seats won't fold down as people try to push for the exit. The overwing exit is light enough for somebody to lift. There are instructions that are understandable that are actually stuck to the seat in front, and we've just been sized up and briefed by the cabin crew as to whether we could be the able-bodied people to get people through that overwing exit. You know, all of that came about because of investigators. I still find it quite humbling to even tell that story, but it is a reminder. Actually, we've learned a huge amount, and we've learned a huge amount because of the approach we take to generally learn from serious incidents and accidents in aviation. Now, of course, if you flicked on the National Geographic channel or other available channels, you could be forgiven for thinking that the reason we investigated big incidents and accidents is because they make for great TV. And they certainly do. You know, there's 100-odd episodes of this particular series. But interestingly, the focus is often very much on the what happened and the why, and not nearly enough on the and this is what happened as a consequence. This is what we learned. This is how we made aviation safer, and how we've inspired other industries to do the same. You know, at Cranfield, although we teach aircraft accident investigators, for the last near 20 years, we've also worked with rail and marine. More recently, also people from healthcare and from construction are looking for, well, what's that transferable knowledge into our domain. And if we think about why we do this job of investigation, you know, the primary reason for an air safety investigation, and recognizing there are others, is absolutely about learning. It's about preventing future events. And although that might seem reactive in one sense, actually it's an incredibly effective way of doing it, because sadly, although major accidents tend to come with consequence of loss of property and more significantly loss of life, they then do give us the ability to actually go in and ask questions and learn to a depth that doesn't just come even from looking at normal operations. And I would absolutely argue that there's a place for both. But accident investigations do go places that others can't and get to certain levels of depth and are able to uncover things that perhaps we couldn't otherwise. And of course, we start with an obligation. You know, each member state of the International Civil Aviation Organization is obliged, if there is a serious or incident or accident, to go and investigate and to feed that back through that international organization. Most countries have occupational health and safety laws that would require the same sort of thing. And there's a bit that sits alongside that, which is this moral obligation to explain to people who may be survivors or maybe family members of people who've been affected by the accident, just what happened and indeed what we're going to do about it. But there are also some legitimate processes that sit alongside. They're different. They are concerned with blame or allocating liability, or in the case of a criminal act, obviously getting involved in prosecution. But I think it's really important that people understand which process they're involved in. And I do slightly worry that there was becoming an ever blurred landscape where we talk about wonderful concepts like just culture. And for me, if just culture drags you from focusing on the frontline individual, the last person to touch the controls and blaming them, then yeah, that's a really big step. But if just culture drags you back from saying, you know, sometimes we learn more by protecting people through a not for blame process, then I think that's a problem, because for me, just culture assumes you get it right every time, and that can be a really challenging thing. So most of what I will talk about is how, when a major event happens, or two major events, as is the case with the Max, we ensure that we get the maximum quality of learning out of those experiences, absolutely accepting that there's a legal process that could also take place. And look, some of you would know, I'm quite humbled by who else is in the room. And for those that are not from an aviation background, we often talk about annexes. And as somebody starts to explain it, they probably make even less sense, because these all relate to a conference that was held in 1944. And that was the start of kind of international standards and recommended practices. And somebody with a dark sense of humour decided Annex 13 would cover accident investigation, and what it does is set out a set of standards and recommended practices for states to follow in the event of an accident. And that's really important, because one of the things that it sets out is this objective that really the focus is not about apportioning blame or liability, it's absolutely about prevention. But to make sure that happens, what Annex 13 also does for us is establish which organisation leads and which others are able to participate. So actually what you can see on the right hand side is actually from the front of the Indonesian investigation report into the Lion Air accident, to explain that, and in leading that, because it was an accident that happened in their territory, there are others who are able to participate. So as a US manufactured aircraft, the National Transportation Safety Board would participate, and they can use Boeing as a technical advisor through its state investigation authority to participate. And look, that's important because although that possibly on face value doesn't sound like there's sufficient independence from Boeing, actually what you can't survive on is isolation. So Boeing arguably know things about Boeing products that the rest of us don't know, and usually the process should use the benefit of a manufacturer to assist, whether it's to interpret something under close scrutiny, or whether it's to provide information perhaps about fleet performance or about events that might have happened elsewhere in the world and so on. So there are methods to allow all sorts of participants, but also to protect the integrity of that investigation. And ultimately, it's the investigator in charge who is responsible for that. As I say, look, it's a process that's worked quite well. And although there are many, many accidents that we've learned from, actually some are quite significant in terms of here is where the whole industry learned about something. This is not about one manufacturer or indeed one product, that actually the learning is much deeper. And when Boeing have an accident, when Airbus have an accident, whomever it is, I think that there's an important culture that says, well, look, there, but for the grace of God, go I. What is it that we Airbus could extract from Boeing's experience and vice versa? And I think that's really important because often what we are starting to uncover, particularly as we get deeper into systemic causes, are things where if there's a deficiency in a regulatory process, then why would it just happen in the US or in France or in Beijing or wherever? We need to understand that whole international system of aviation. So, here are a few that were really about how an industry learned about, in this case, some technical challenges, the BAC 111 with a test flight program where because of the architecture of the aircraft, it resulted in deep stall and sadly the loss of all on board. The Douglas DC-10, if you go back far enough into your aviation safety history, you'll find all sorts of things written about the vulnerabilities of design around a cargo door and who knew what. And there's some quite sobering lessons from back in the 70s about at what point did that organization and its regulator really get its head around the size and scale of problem that it had. And sadly, it was this total loss in France of a Turkish aircraft that brought us to that point. But it certainly wasn't the first clue. There was previous events. Even with newer products, the A320 in 1988, actually what we saw there was a system that in some ways behaved exactly as it was programmed to, but being asked to fly some quite unconventional flying here at an air show, we got to the limits of its performance and it behaved in a way that wasn't what the crew had intended. I should include the fourth one because this one happened just down the road from where I went to university and involved the 737-400, so the second generation of aircraft. And again, there were some salutary lessons there about how just as you try and reap the benefits of standardization and commonality across aircraft types, actually, sometimes we have lost the opportunity to tell people what's changed. And in this case, some of the identified issues were around what the crew knew and understood about systems on the aircraft once they moved across to this newer series of 737, and there's some interesting echoes of that in what we later saw with the Max. Now, I did want to throw a caveat in at this point, which is to say, of course, that one of the biggest challenges that anybody faces in investigating or in trying to understand from accidents is all the biases that can be thrown in our way. And this quote comes from Lord Anthony Hidden, who held the inquiry into the Clapham Junction rail disaster, a very significant railway accident in the UK in the late 80s. And I think as you pick apart a sequence, and often we see that because people are looking in slow time with more information than the individuals ever had in front of them at the time of the event, it's very easy to lose track of what was known or how rapidly we expected somebody to make sense of the thing that they were experiencing. So I think Sid Decker's always a great quote here to say, our job is to try and understand why it made sense to them at the time. And recognise that hindsight can be an incredibly biasing thing, but actually so can good performance. And actually, I was digging through old presentations not so long ago and found, here's the stats from 2017, and at the beginning of 2018, we were at risk of patting ourselves on the back as a aviation industry and saying, well, look at that. We have, the International Air Transport Association members managed a jet aircraft hull loss rate of 0, and unfortunately, the only way from there is down. And sadly, of course, 2018 reminded us that we were absolutely not there in terms of achieving ultimate safety, because, of course, the first 737 Max event was really not long after the first aircraft had flown. And I think what was fascinating about it was just how people responded to it, and potentially even a little bit of potentially racist behaviour here to say, oh, it's Lion Air, they've had a bad accident record, they've had accidents in the past, what is it about them not operating this this new hardware properly that's behind this? And I do wonder whether we actually missed the opportunity there because of who it was that was involved. And I say that partly because I remember journalists phoning up about the Ethiopian accident. And again, you could almost feel that they're saying, oh, is it just a developing nation not operating the aeroplane properly, as opposed to, well, Ethiopian is arguably one of the best, if not one of the safest operators in Africa. No, this is something rather more than that. But I do think it's important to remember, when you have an event like this occurring, the investigator's job is to get in there and properly understand what happened. And look, the journalists might claim the same, but they try and work to a timescale which is almost instantaneous. And as a consequence, most of us forgive the media for getting it wrong. But actually, if you're going to modify a design, I want you to properly get this right. If you're going to explain to me as a family member what's happened, I absolutely want the truth. But there's a different pressure that says, and if I'm an operator, I kind of need to know if the next flight is safe. So straight away, the investigators got a real challenge here about how do you answer these questions? And the what is this forensic and painstaking examination of the physical evidence, the documentary evidence, interviews, eyewitness reports, and so on, understanding a timeline to then really get to the heart of what happened and why. But then the real magic comes from, well, but what do we learn from that? Nobody wants yet more error spotters that just say, oh, humans can make mistakes. We know that. What we want to understand is what can the system learn from this that doesn't prevent this accident, but prevents whatever's coming next. So where does the learning really sit? And I think that's the challenge, because there are many, many stakeholders. Lots of people who want to learn. So maybe the technical audience, as you see on this slide, the people who might make changes. It's worth remembering all of these national investigation agencies don't have the power to make anybody change anything. They have the power to stop everything that's involved in the accident, keep hold of the evidence, interview people, compel them to participate in interviews, all sorts of stuff like that. But they don't have the power to make anybody change anything other than to present a very clear analysis of the evidence, and then for a regulator to choose to turn that into something, or indeed in a voluntary sense for an operator or a manufacturer to accept a change. At the end of the day, the regulators play an incredibly important role here. But that's not to say that the story the investigators tell through a report isn't something that then can be used by operators, manufacturers, through those international bodies, the people providing training, all sorts of people like that. These are really important stakeholders, but so are these people. The people who are involved, survivors of accidents, even the people who are perhaps sat in the factory or in the design bureau, in the regulatory office thinking, have I done the right thing? Did I contribute the way I should have contributed? What have I done? They need some explanation, but perhaps most importantly of all, so do the family members, the loved ones left behind and so on. They need somebody to tell them the truth at the most hideous time. And bear in mind, investigators do this as a multidisciplinary, multinational team formed at zero notice to go and investigate something quite horrific. And they are the people who are the trusted agents to be able to explain, sometimes in the most difficult of terms, to family members what happened. And bear in mind, the question they may really want answering in the first instance is, did my loved one suffer? And of course, in both of the MAX accidents, of course they did. And that's interesting because then if we think of this in terms of litigation, then litigation for somebody who experienced pain or suffering prior to their death often brings a much higher payout than somebody who is perhaps killed instantaneously. So you know, there are these other stakeholders, some of whom will want to use the output of a safety investigation, and where actually we've tried to resist it being used in that way, because we wouldn't necessarily collect evidence to the same burden of proof that we might if we were involved, for example, in a criminal case or in litigation. So there's a balance here, and as I say, there's lots of really important stakeholders, and some of their interpretation or understanding of events is actually being driven or manipulated by the media, not necessarily with bad intent. But again, you know, went back to the story that was published in this case by the BBC back in 2018 after the Lion Air MAX accident. And you don't have to read very far until they start referring to other Lion Air accidents, and you can just tell from that, you know, that they're directing you towards, you know, it had issues of safety and poor management in the past and was banned from flying in Europe until 2016. And in 2011, 2012, a number of pilots found in possession of methamphetamines and so on. You know, straight away there's this temptation to jump to distrust certain people, and I suppose as a consequence there's also the downside that sometimes there's a mistaken trust of other parties as well. You know, by the time you have a second accident involving, in this case, the same aircraft type, the complexity here is you have an Indonesian investigation with participants from the US and possibly other countries where they've got affected parties. So, for example, if there were lots of people from a particular country on the aeroplane, they could get involved. If there was a major component manufacturer, they might get involved and so on. But now here we've got another investigation happening in parallel in a different jurisdiction of the world, in this case, led by Ethiopia. And look, this adds complexity as well in how people can share information, and certainly up until the point that an investigation is concluded. And I think it must have been a brave person who first mooted grounding an entire fleet. I mean, if you think about the 737 as an aircraft, I don't know how up to date the stat is, but certainly in 2017, I think the stat was that every 1.5 seconds a 737 took off or landed, and that on average there were about 2,900 737s in the sky at any one moment. You know, it is the most populous aircraft out there, and economies are built around short and medium haul travel on 737 as the main competitor to the Airbus A320 family. So actually, I again look back at an old presentation and thought, you know, at what point would somebody be brave enough to ground an entire fleet like this? Well, we saw that, and it was a very significant move when it happened. And of course, it wasn't the first time it had happened. 787s had suffered problems with lithium-ion batteries that had meant that much of the early fleet was grounded, but perhaps not when there were so many numbers out there. And at the point you ground an aircraft type, it's worth reflecting on what are all the things that make a product like this safe. And the answer is not simply that the manufacturer follows the guidance produced by the regulators. There's much more to that. And actually, I don't know that we always know all of the factors that make a sector safe like this. You know, some of them are historical and cultural and much softer. You know, they come from how we've responded to accidents in the past. Some even come from where that accident happened to have occurred in the world, and therefore how much the learning was able to be drawn from that. And I say that because in certain cultures, we've arguably been able to go further to ask the question beyond who was the first or who was the last person to touch it or the last engineer, but to say, well, what was the role of the organization, what was the role of the regulatory environment, and so on. And there's lots of tools out there. We've mentioned James Reason, who absolutely helped many of us to just understand in better detail what causation could look like. And look, I know there's plenty of people saying we've moved on further from this in terms of thinking systemically, but actually, when you go back and investigate an accident, you do freeze it in time. You do look at a linear sequence in that sense. And as investigators have tried to use his underlying logic, that they've sort of modified his model. And look, some of you will have seen this before. It's from a great document that the Australian Transport Safety Bureau developed back in 2008, as they tried to explain their investigation process. And look, you see the reason model neatly filled in the middle, but with these risk controls added, so preventative and recovery controls, and this acknowledgement that most of the time a system with all its defects and holes, whatever way you want to describe it, still manages to achieve its production goals. And it's a much rarer circumstance that something else contributes to either an incident or an accident. And the big advantage of this has been that we go beyond the front line and start to look much deeper, particularly into where the safety issues often lie, which sit there as organizational risk controls, the process we take in understanding what risk is associated with not just an engineered system, but something that goes beyond that. You know, you take most of our major airliner products now and recognize that one of the things that is driving us is that the consumer, or at least the airline customer, wants as much commonality as it possibly can. And on the one hand, that's really advantageous because we want pilots to know that everything is standardized. Standardization has got us a really long way. But at the point we say, well, we want the A320 to A330 to A380 transition to be really easy, so let's go for a sort of common flight deck philosophy. Actually, what it can start to do is inhibit some of the potential advance around technology, because we want the whole fleet to be the same. So I think it's interesting that some of those economic factors can start to affect us, and that transition training between different types can start to affect us. So look, some of you have seen that before. I always think this is quite a useful slide, because also it starts to add where these things start to sit. And I didn't adapt this for Max, but it might be quite an interesting one to look at. You know, what things really sat there up at risk controls and organizational levels, but recognizing that at the end of the day, this was a product that wasn't just approved by the FAA, that there's an international regulatory process, whether it's leaders like EASA, or whether it's the Chinese equivalent, and so on. That there are processes here where the level of trust is built to the point of perhaps becoming dangerous. I know that one of our former students in China was given the task soon after the Ethiopian crash of establishing whether the aircraft should continue to fly. And in talking to him subsequently, you know, the comment he made was, look, we didn't ground it out of any attempt to try and cause our US competitors harm. It was not that at all. It was that we had even less information or evidence available to us to justify why the aircraft was continuing to fly, and that also led to at the point they finally ungrounded it, was just being able to put forward the evidence in such a way as to convince people that this product was now trustable. Now, just one or two quick things to finish. I dug out this set of quotes from Kathy Fox. Some of you may know she's the chair of the Transportation Safety Board of Canada, and the Canadians have done some really great work around understanding how accidents involving complex systems like transport and so on find their roots deep in the much harder to evidence facts, and some of those around organizational behavior and so on. And I think this is where most investigators understand the argument about looking to that depth and are somewhat constrained to go there, because it is much harder to evidence some of these things, and much harder to really prove that evidence has not now been tainted by hindsight or by the fear that comes from people after an event starting to talk about what had occurred. But as I say, the Canadians have managed to do some good stuff here, and I think supported perhaps a bit by the culture, where when they start to look at organisation failings, these are the classic things that they do start to see. You know, that classic goal conflict between production versus protection, where risk analyses have not really been done in the way that they should. Either they're absent or they've kind of misunderstood what risk analysis is all about. And I think there are some who try and use it to manage to green. In other words, to just try and show that we really shouldn't worry here. And there are others that say, look, this is the tool that absolutely ensures that our decision making is based on as much evidence as we can find, and where there is an absence of evidence, that we must be rather more conservative in how we deal with risk. But then the other two things there, again, classics you'd expect to see around employee adaptations over time, the drift to failure that no doubt Patrick will speak about in a much more eloquent way than me. Last thing again is that failure to heed weak signals. And look, the challenge here again is the danger of hindsight, where suddenly a weak signal seems much more obvious because now there's a bad outcome, and really understanding the ones that actually somebody could have properly, truly recognised and done something with. Or at least collated in such a way that at a meaningful level we could see trends. And look, that has been so important, particularly during the pandemic, where flying levels have gone down to such a low level that actually many of the systems that airline operators would be depending on in terms of safety management depend on volume. You know, they depend upon people reporting, and you'll be able to look back at last year's data or the last 3 years' data and seeing trends. And actually that's been largely absent. And some of the threats that we've faced are novel. You know, if you'd asked me 3 years ago, what do I do with a pilot who loses their currency or recency? Well, the answer is you send them flying with somebody who's got very good currency or recency. I can't really answer the question, well, what about if they've all lost currency and recency because nobody's really flown for 2 years? Or to use a different example, what do you do when the pollution levels around an airport like Heathrow drop to the point that things like masonry bees come back to live there and decide that one of the things they really like to live in is a pitot tube in an aircraft, and they crawl into the pitot tube, they make a nice little home out of something that's akin to concrete, and the first thing you know about it is as two pilots who are low on currency and recency rotate and discover they have an unreliable airspeed indicator at that point. You know, there are some things that really do require us to look at small numbers and single events in very great detail to understand where the failure occurs. So I'll end with that, really, to say that, you know, what Max reminds us of is look, some of the constraints around the investigation process. It should also remind us of the very great benefits that have come from there being a not for blame process as well, and that there's the right balance to strike here to make sure we can keep learning, so that we build that safety mentality right in from the start, and with that becomes an openness of sharing. And for that, I just wanted to use this quote from Tom Palmer when he was Director of Services at Rolls-Royce, that if you look back on 100+ years of investigating aircraft accidents, actually most of the benefit has come from creating a culture where people can be open and share. And I would be slightly concerned that unless we protect that, there is a risk that an increasingly litigious society will actually drive some of our insight deeper underground, that people just won't feel confident enough to actually share where the real learning is. So I'm going to stop there. I hope that is what Carl was hoping and dreaming of when he invited me. And I'm of course happy to take any challenge or feedback from anyone. But thank you.
That's great. Thank you, Graham. That was fantastic and a real broad. I'm not sure why my webcam hasn't turned back on. Video stopped working. I'm getting plug it out and in again. But anyway, there we go. I'll ignore that for the moment. Yeah, thank you, Graham. That was fantastic. A really broad sweep across the whole landscape of investigation. I guess I've got a number of sort of comments or questions, but perhaps I'll open it to the group first. I mean, what are people's responses or thoughts to start with?
Hey, Carl, it may be beneficial if folks have questions to put it into the chat, and that way we can kind of manage the virtual crowd here. Since I turned my camera feed on and started speaking up, I'm going to start off with a couple questions. I'm going to ask you two questions. I'll put them in the chat as well. But the first one, you ended your slide on the weak signals, and signals is one of the things that we've been looking at across different systems. And I guess what I'm getting at here is the difference between a weak signal and a dismissed signal. I think Ian's going to talk about fundamental assumptions later, but in a lot of these systems, there are assumptions made that become forgotten or buried or ignored. And I think those have a very impactful measure on how these systems actually perform. And so it's not an issue of not detecting a weak signal, but just dismissing signals that should be listened to. And the other thing that I wanted to ask you about was at the beginning of your presentation, when you were chatting with the TUI board, they were saying, hey, if you see a problem, tell us. If you see something good, tell everyone. And I'm wondering if perhaps this notion of positive role models isn't something we can leverage more as a tool to help people, help identify for people opportunities out there, so that we can kind of follow a lead by example type of approach with these positive role models. So with that, I will go on mute and off camera.
Look, I think two really great points, and I'm mindful I don't want to steal too much time from John Vincent, but just a quick response to the second one. I remember years ago sitting through a presentation by an airline to one of its biggest corporate customers, which was a big mining company, and it was about an event that they'd had and how it had happened and how they'd learned from it and so on. And at the end of it, the mining client said, look, this is just fabulous that you've come and shared this. They're only a new client, very, very big. And he said, I feel so reassured that you will openly share this, because this is exactly the kind of stuff that happens to us. And I trust you so much more that you come to tell me about this. And it was a very proud moment. We all felt very emotional and so on about it. It was great. At the coffee, the guy from the airline said to me, I so hope he doesn't write to the CEO to say thank you, because I briefed the board at the airline yesterday about this same event. And the comment I got was, I hope nobody else finds out about this. This would be really embarrassing for us. But what a difference. It wasn't embarrassing. It was, we recognize that you face the problems that we face and that we can learn something from it. Yeah. John's put a comment in about there, too much trust is dangerous. You're right, system does depend on trust, but I think trust without challenge becomes the issue, doesn't it? And that it piles the pressure on the trusted institutions, and of course the regulators will recognise that they don't know everything, but if they're then carrying the expectations of society that they know everything, then that puts them in a really difficult place, because how do they learn? How do they acknowledge? And as you probably know, the UK CAA a few years ago actually got Cranfield involved in a bit of a safety assurance review, partly because they wanted to know, how well are we doing as a regulator? Whoever tells the regulator how are they doing, particularly if they feel that they're leading on regulatory practice, and how do we acknowledge that we make mistakes without that being a legal acknowledgement that says, please sue the British government for squillions of dollars. That there has to be a continuous improvement culture. And I think the regulators have got a tough job there.
No, that's really interesting. Thanks. And I can see John Vincent. I can see John Downer's got his hand up. John Vincent, did you want to comment or come back on that?
No, I agree with what Graham said. I think that yeah, we have to trust, because not everybody can look at everything all the time. So you have to trust your colleagues, you know, in other authorities to a great extent. But how many pairs of eyes make a difference? You know, another pair of eyes does make a difference. But it's getting that right, isn't it? The balance, you know, too many pairs of eyes, you're in trouble because you've got too many views. Too few pairs of eyes, and you're right. You know, you can have these breakdowns in trust. So it's a difficult balance, that one. But it's an interesting expression. I thought when you said that, I thought, oh yeah, okay.
Yeah. No, thanks. And John Downer, did you want to comment on this point?
No, but if I've got a question, if that's all right. This could take me too long to type into the box.
Of course. Yeah, that's fine.
Yeah, so great talk, Graham. Really enjoyed it. You mentioned sort of in the middle somewhere this phenomenon where people are very quick to sort of lay the blame for accidents on specific cultures like Ethiopia, and I totally get why that's problematic, and it's a really common trope in disaster, you know, investigations across the board, right? In Bhopal and Chernobyl and so on. But I totally see where it's a bit racist and problematic. At the same time, it occurs to me that there are sort of, it seems to me there must be sort of meaningful differences in the abilities of certain parties to manage incredibly complex organizations and infrastructures and bureaucracies, which aviation safety definitely is one, right? So as someone that's worked in this field for a long time, do you think there are meaningful differences in the sort of safety operations of different countries?
Definitely, but for a variety of reasons. I many years ago, my PhD was all about why Australia had somehow managed to deliver this amazing safety statistic of no passengers ever killed in a commercial jet aeroplane accident, and it's phenomenal. And there's elements of culture there that some of it is to do with a very flat, low hierarchy, and some of it's to do with the little known fact that actually it's quite a compliant culture. So you combine two things, which is a very strict adherence to standard operating procedures. But if you think the procedures are lousy, you'll go and flipping well tell whoever it was, regardless of rank, that it's rubbish. And actually those two things combine quite well. But then you could look at somewhere like Japan, which is quite different culturally, where actually the standard operating practice culture is much stronger. So as long as you've got good operating procedures, you can still deliver a similar level of safety, but perhaps within different ingredients in the cake mix. So I think there's a lot of variety there. And if you look at a product that may find itself crashing in different jurisdictions around the world, one of the dangers is that you learn different lessons depending on who it is that's actually going in there to do the investigation. Because we know from one of the studies one of our Taiwanese colleagues did, is if you use the same accident and the same tools, you find a national cultural bias in how far people are prepared to go in handing responsibility to individuals or putting it further back in the system. So yeah, I think, you know, there's almost this randomness that's come from where accidents have happened and who the operator was as to how deep we've managed to get with the investigations, and therefore what the data is that people use when they look at a global system, if that makes sense. Thank you.
Thank you. Well, that's great. I'm sort of mindful of the time, but I guess I'll just be interested just as one final comment, whether, I mean, something that's particularly striking from my perspective around the MAX is just the sheer volume of inquiries and investigations that have gone on from, you know, congressional committees through to sort of specially commissioned reviews and the FAA special committee and a whole, you know, it's a remarkable array of different investigations. I mean, what's your sense of the challenge or the utility or the, you know, perhaps actually the difficulty of having so many sort of chefs in the kitchen, as it were, in that sense?
Yeah, look, it's a great question. And of course, the thing that we say to any investigator is, from the first question you ask, you are now probably altering the testimony or as you record it. So in other words, if you ask a bad question in an interview, you've probably already given the interviewee or the witness the clue as to where this is going to head. And so evidence can just change over time. And if you're talking about culture or decisions that were made that are not documented in the way that ones and noughts might be documented on a data recorder, then over the process things change. You know, you take an accident like the Kegworth crash back in 1989. That story's been told thousands of times since, and probably bears little accurate reflection of what actually happened at the time and what was known by the players. And I think we have to be really careful of that. You know, I've listened to some wonderful presentations about heroic compensation. Sullenberger is a great example of that. But then you have to be reminded that the whole decision took place like that, and over time some of the stories have perhaps got a little bit improved for television. And we, yeah, I think where there's multiple inquiries, getting back to what the single source of truth is can actually be really quite difficult.
Yeah, no, it'll be fascinating to see it play out. I think with the Max, which is obviously still unfolding. Well, thanks very much, Graham. Really appreciate that. That was a fantastic sort of scene setting for where we're coming from around learning from these sorts of events. Really appreciate your taking the time and your input, and I hope you're able to stay for a little longer through the event. But you know, as I say, we're aware about how the time difference will shift. But thank you very much. John Vincent, delighted you could be here as well, and I'm sort of mindful of the time, but we'll make sure that, you know, take as much time as we need. We can be flexible with the timings. I think the aim is to make sure we just have the conversation and, you know, fit the discussion to the ideas and the conversation, rather than curtailing things with particular timings. So please feel free to you know, use the time as you wish, and we have the group ready for discussion as well after your contribution.
See if I can get some slides up, you know, see if this works in the way that I hope it will. There we go. Well, thank you very much, Carl, for inviting me to come along and talk on the subject. It is something I feel quite deeply about. As I say earlier, I was involved in the validate the JA as a JA team member, that's Joint Aviation Authorities team member, on the certification of the 737 next generation back in the 90s. So to see what's happened with the Max has been quite shocking, really. First off, IFA, International Federation of Airworthiness, as Cengiz mentioned earlier, it's a UK-based charity looking at airworthiness issues, you know, promoting airworthiness as a subject matter, really. But it's fortunate, it's run by volunteers, so it can take an independent view. But most of what I'm going to talk about today probably comes from more, you know, from me as more personal side of things. Now my career sort of splits into three, really. Sort of design, manufacturing to begin with, and then moving to the certification authority, the UKCA at that time, and working as a JA team member on many certifications, and then moving to EASA and really doing strategic safety. I was the interface really with the air accident investigators at EASA. So it's sort of covered the whole gamut in a way. What I've tried to do with this presentation is, you know, this has been mentioned, so much has been said about the Max, and there's so much material out there that I don't really want to repeat things too much. I want to try and highlight the things that perhaps I see in the information, and maybe make a couple of points that other people may not have made. So that's me, and that's IFA. Here's the Max and the history of the Max. It's always good to look at a picture of, you know, what it is. 737 started its life in the 1960s. It's what I might call a strings and wire type airplane. You know, it's very mechanical. You know, it was designed before the digital world became so ubiquitous. You know, it's everywhere. It's an aircraft which, as I say, has achieved a tremendous safety record over its entire fleet life. It is the most successful single-aisle civil aircraft there has been. So, you know, we might have a downer now and then on the Max, but look at the whole aircraft history, and it is a very good one. That doesn't mean to say it hasn't had, like Kegworth, you know, some very significant accidents and some very important learning has come from those accidents. You know, even with the classic aircraft, the original aircraft is called the Classic. There was a rudder problem with that aircraft and 3 serious fatal accidents that we had to deal with when we were addressing the certification of the NG, and the NG is the next generation, which was certified in the 1990s. Now, if you want to think of that as sort of common analogy, it's like Windows 95. You know, it's making the aircraft a modern aircraft. It's not a fly-by-wire aircraft, so it is very different from the A320 in that respect. But the digital systems are introduced really from Boeing wanted to take what they had learned from the 777 and implant that in the 737 to make it a more competitive aircraft. And then, of course, we move on to the Max, and you see again a very different aircraft in terms of its internal systems, but externally, although you know there are new component parts to the structure, it's still essentially the same aircraft, and the wing sits in the same place, and that's part of the problem. The original 737 has a low wing because, of course, engine diameters were quite small at that time. They didn't have the high bypass ratios. So that's where the problem started, perhaps. So there we go. Some of the things I've already said. The customers, the sales of the NG were going strong. The customers really wanted a new 737. Boeing looked at the development costs, you know, of an entirely new single aisle aircraft, but it was about 10 billion. And now that looks cheap. You know, if you think of what's happened with the Max, maybe they should have started with a clean sheet of paper. Knowledge with hindsight, I know. And these issues of economics that Graham actually mentioned, pilot type rating. The idea was to be able to take a 737 pilot from anywhere, and that they could sit in the Max cockpit and fly the aircraft as if with all the knowledge and skills they already had. But the big change was the fuel efficiency change and the new engine. And they were in competition with Airbus, as still are obviously, because Airbus were going to take the same engine and fit that to the A320 type. It's called the Neo. And you know, this very highly, you know, this duopoly, this highly competitive environment, Airbus were already ahead of Boeing. And so there was a great deal of pressure to get the Max into service. Right. Why the MCAS? Now, the MCAS is the system that caused all the problems. Had there been no need for an MCAS, then maybe we wouldn't be sitting here talking about the Max. Early predictions in the design office showed, you know, that this higher bypass engine with a large diameter fan sitting on that particular wing meant that there was going to be a problem with the non-compliance. The aircraft would pitch up at high speed. So something had to be done about that. Boeing looked at aerodynamic solutions to the problem, but they couldn't find a solution. And then they thought, well, hang about, we did something with a previous aircraft, and this is a military tanker, where they had an augmentation system which had essentially dealt with this high-speed problem. But it was a very simple system. So they borrowed that and incorporated into the 737 Max design. But in flight testing, again, you know, this is what comes up when you start to design and build. It was found that there was also a problem with low speed stall on the aircraft. So now the MCAS had to be adapted to deal with both problems. And this is where the mistake started to be made, because Boeing changed the MCAS, they changed the system safety assessment, they didn't show it to the FAA, and they didn't even document it in the flight operations manual, and there are no emergency procedures and no abnormal procedures in the flight manual and no training that relates to the MCAS at all. And because it was a simple system borrowed from a previous aircraft, it's activated from a single source. And that is one of the problems. the findings. What did the investigation, what did the saga unfold? Well, as I said, one of the key objectives of the program was sell more aircraft, reduce costs. This is a popular aircraft. Maintain the type rating. You know, these were incredibly powerful drivers on the whole organization. And of course, the FAA were aware of this too. Engineers started to raise concerns about the idea that a single angle of attack vane should activate the MCAS in 2015. And also in 2016, engineers raised concerns about the pilot's inability to overcome the repetitive activation of the MCAS. And that's what actually caused the accident, the first accident, the repetitive activation of the MCAS. But these concerns were shut down. Inadequate investigation within Boeing, and concerns were dismissed really by the management. So then there was some in-service experience of AOA failure in you know, the angle of attack vane failure, and Boeing concealed that information from the FAA. The first accident occurred in 2018, a high-speed impact up to 12 minutes. Crew had very little time to understand the problem. They had no training. They didn't even know there was an MCAS on the aircraft. You know, so they had to try and react to the events as they occurred with very little to help them. Boeing issued after that accident a bulletin in the flight crew operations manual, with emphasizing, not even changing the procedure, just emphasizing the existing procedure. The assumption that they made, blaming the pilots essentially, that if they'd done it properly, then the aircraft wouldn't have crashed. But there was no mention of MCAS whatsoever. And then immediately after that, the second accident happened, similar set of causes. Although the Ethiopian crew did slightly better because there was a greater awareness at that point of the issues associated with the aircraft. But clearly these events, in hindsight, of course, you know, yes, preventable accidents. Now I'm going to talk about the framework, the international framework within which aircraft certification works. And Graham already mentioned ICAO, the International Civil Aviation Organization. And every member state of ICAO, and there's about 190 of them now, abide by the Chicago Convention. The original Chicago Convention goes back to the 1940s. And it has a number of annexes. And of course, Graham was talking about Annex 18. Sorry, talking about Annex 13, which is accident investigation. And what I'm talking about here is Annex 8, which is airworthiness of aircraft. Within ICAO, there's an Air Navigation Bureau that updates these standards and recommended practices for certification. But what you see at the international level in Annex 8 is really the basic principles about airworthiness of aircraft, saying every aircraft, if it's going to fly over someone else's airspace, must have a C of A, a certificate of airworthiness. But before you can have a certificate of airworthiness, the whole type must have a type certificate. So the first stage in the process is to assess the design against airworthiness codes to see if you can grant a type certificate. And the airworthiness codes are at a national level, or in Europe at a supranational level because of the EASA and all the states working together. Of course, there are other manufacturing states, Canada, Brazil, of course, Japan, and you know, Russia and China. But the predominant airworthiness regulations are the FARs and what used to be the JARS, which is now the CSs, or the certification specifications. There's a group that manages this, and there are bilateral agreements between states. So there's a certification management team, the idea being to try and harmonize the international requirements. There are differences still between FAR 25 and CS 25, but there's an effort to try and manage this, to harmonize the requirements internationally. Now I've talked about the certification, the need for certification. Now there's only certain types of organizations, design organizations, that are able to apply for a type certificate. This is really where we get into oversight of organizations. So we have two different processes or approaches to this. In the US, there's the ODA program. So Boeing, for example, has an ODA, has an authorization. So Boeing can then therefore apply for a type certificate to the FAA. In Europe, we have a thing called the DOA, or the Design Organization Approval. So an organization will have that approval, and they'll be therefore eligible to go to EASA and say, you know, can I have a type certificate? It is only the agency or administration or authority in a given state in a different country that can issue a type certificate. So we do not have self-certification. At the end of the day, the type certificate is issued because the state has been satisfied that the requirements have been complied with. But in order to do that, because you can see from the iceberg and from the triangle, I know this is often used in accident investigation, the Heisenberg sort of principle, but I'm using it differently here. The authorities can't look at everything all the time. So we have to have eyes and ears within the organization. And within the Boeing, there are designated engineering representatives. Now, this is a really hard job, and I've worked with a lot of these people. You have to wear two hats. You know, you're working for Boeing, maybe as a design engineer, a senior design engineer, but you're also wearing an FAA hat when you sign a document. So if, you know, as an authorities person, I see a declaration of compliance coming from a DER or from an approved signatory in a European organization, that should be trustworthy. I should be able to say, I don't need to look any further because these people know what they're doing. And the organization therefore is expected to maintain the competence of these people. The certification is really, you know, this is why I mentioned trust, built upon trust. It demands competent people with integrity, and it demands that they be supported by their organization and supported by the authorities. And that's the way it has to work. The certification process, yeah, you might say we've always done it that way. This process now has been working for many decades, and I think others will tell you it isn't necessarily the process that's at fault. In this case, I think it's the implementation of that process where the errors occurred. This process has proven to be quite robust because it's been used on every aircraft type that has a civil type certificate. Initially as an application, then there's technical familiarization. What is it you want to do? One of the first questions that's asked is this a new product or is this a derivative? Is it a variant of something you've done before? And then if it's a variant of something you've done before, what's new? What's modified? What's affected by change? You've got to ask those questions. Then you move on to setting the certification basis. Now, what are the applicable requirements? Do we go back to an early amendment of the FARs, or do we apply the latest requirements because this is a new system? And so you have a lot of argument and disagreement and negotiation over the applicable requirements. Are there any significant differences between the different authorities? And what are the means of compliance? What are you going to do to demonstrate that you've met that requirement? What tests are you going to conduct? What analysis are you going to provide? Are you going to allow people to witness the tests? And of course, flight tests, you know, you'll have company flight test pilots and the authorities flight test pilots flying the aircraft and reporting back on whether compliance has been achieved. And at the end, you have this huge volume of data that is provided to the authorities. And each discipline will review, the avionics team will review their bit, the structures team will review that, hydromechanical review, the engines people review, every single technical flight department will review their findings. And when everybody puts a tick in the box and they are satisfied that compliance has been found, big type board meeting and the decision to grant a type certificate is made. And then there are the big formalities of the presentation in public. And it's usually a very grand occasion, the actual issue of the TC, because it means now that aircraft can enter into service. So for the company, it is a huge bonus, you know, to achieve and be seen to be achieving certification, because that really means they enter into the marketplace. When things go wrong, what went wrong here? Yeah, and this is how I felt, you know, the scream basically when this saga started to unfold. Engineering concerns were swept under the carpet. Now that shows a bad safety culture. And when I dealt with Boeing in the 1990s, I cannot understand the engineers I dealt with, the people I dealt with as a certification authority specialist in avionics. These were high integrity. I had a lot of respect for them. We worked together well as a team to determine compliance. So how this happened and how their concerns were swept under the carpet and why it was allowed to happen, you know, this I feel is very difficult to understand. Changes were made, but they were hidden from the authorities. So really the company, those acting on behalf of the FAA and the FAA, because they did become aware of some of the issues, were all complicit in what finally happened. And the validating authorities like EASA, the Chinese authority, every authority who was a customer for the aircraft trusted the FAA because they saw the FAA type certificate as a gold standard. And that trust, you know, has been damaged significantly by the Max event. There's a bigger picture thing here as well, because up until the Max, every new aircraft type that had been introduced into service was an improvement in aviation safety, achieved a better safety record. If you look at the safety record for the 777, it's much better than previous aircraft types. And you know, we're hoping very much, you know, and so far the evidence is good, you know, that the 787 and the A350 will be better than previous types. So the Max was a great shock in the fact that it is not, or has not so far, been better than previous types or variants, because it is a derivative of type. So was there insufficient challenge? Was there insufficient questioning? Were the people, those engineering, those DERs finding compliance, were they given the support they needed? Were their voices listened to? So the lesson from the Max is really safety leadership is something that is not just a matter of words in a procedure. It's the way people behave, the way they act. You need to listen to those who have concerns, particularly if they are technically capable and competent people with genuine concerns. Now, a lot of this centers around 1309 or system safety assessment, which is a requirement called Part 25 1309. This is where it gets complicated in the 737. It's the original type certificate back to 1967. When the NG was certificated in the 1980s, we insisted that every system that was new, significantly modified, or significantly affected by change had to meet the very latest version, the very latest amendment of 1309. But all the other systems, you know, classic system of the aircraft could revert back, you know, so they could submit the old certification data. Looking at the Max, which is a derivative of a derivative, so it's a change on top of a change, there's a big matrix of how different requirements are applicable to different systems. And the problem I have with that is it's very difficult at an aircraft system safety assessment level to take an aircraft level view if you have a very complex combination of applicable requirements. So was a derivative of a derivative a change too far? Well, only time will tell. The other phenomena that I spot in all of this is this, and it reoccurs in time and time again in major catastrophic events, is this press-on-itis, this pressing on when you know you really should stop and rethink. This inability to accept the fact, oh, we're going to have to make one more change. We're going to have to stop here and rethink and do something different because this isn't going to work. This kind of organization gets a goal fixation. Now, maybe this is because of commercial pressure. We have to have the TC on this date. We can't rethink. We can't go back. So you need to think, what is it that breaks the chain in this particular case? Was it technical ignorance of some of the senior management within Boeing? They were so commercially driven, they didn't really understand the technical arguments anyway. This aggressive competition in this duopoly, you know, was the aggressive competition one of the things that created the problem? Resistance to change, maybe, you know, when you get your heart set on, I think this will work, you know, it's difficult to fight against that. Was the risk appetite too great? You know, we had a system, a simple system that we took from a previous type, and it worked. We can take the risk, we can accept the risk. Or was there a genuine lack of integrity? You know, we don't really care, we'll just get it out there. And then the question is still open to some extent, although, you know, obviously there's been a settlement. Was there willful criminality? Did people know that they were doing the wrong thing and did it anyway? So my takeaways, you know, from the saga, as I've called it, is it is difficult to take an aircraft level view, and you have to. If you look at what happened to this particular accident, you know, it's an interaction between, you know, the crew and a system. So you have to understand how it's going to be used in service. The need for training. Of course, there was no training for any of the crews when this was first introduced, so they had no idea there was actually an MCAS on the aircraft. So was it a change too far? Safety leadership must be more than words in a procedure or a manual. You know, Boeing, FAA, everybody will say we're the safest in the world, or safety is our #1 priority. How many times have I heard safety is our #1 priority? Then you must look at what people actually do. SMS, Safety Management Systems. It is Annex 19 ICAO. I was doing presentations on SMS for design and production organizations back in the early 90s. Why has it taken so long to implement SMS for design and production organizations? It is happening now, and because of some of the recommendations that have come from the Max saga. There needs to be a high level of commitment, a good safety culture, and it's evident that there's a good safety culture, and that's part of the implementation of SMS. Certification is built on trust, but we must support those within the system. So, as I say, proof signatories, DERs, people in critical roles have to be supported. They have to be listened to. This is perhaps the weak signals that we were talking about earlier. And leaders, whether they're commercial leaders, you know, accountants need to know something about airworthiness. Whoever they are in the organization, they need to recognize when to stop, when to rethink, and when to break the chain, even if the costs are huge, because the costs of the accident and the cost of Boeing of these events far exceed anything that even a redesign of a new aircraft type would have been. It's an immense cost. So those are my takeaways, really. There are a few more slides in the pack, but I didn't want to take, you know, I didn't want to go on for too long, but these are things I wanted to highlight. So happy to take any questions. There's the website to IFA. So please, you know, keep in contact. Let us know what you think. And Carl, back to you. I don't know if there are any questions. I'm quite happy to take them. I'll figure out now how to get rid of the slides. Let's see if that works.
Thank you. That was great. It's fantastic to have such an in-depth view of the regulatory mechanics of the process as well. That was excellent. I think it was, as Rune said, you're welcome to add questions in the comment box if that's easiest, or, you know, we're a small group, so feel free to either raise your hand or just put the camera on, and if there are any questions or comments, I have one or two, but I'll perhaps open it to the group first. Yeah, Chingiz. Sorry, am I saying your name correctly? Chingiz. Yeah, perfect. Great.
Thank you, Carl. Cengiz is good. Can you hear me?
Yes.
Yeah, excellent. Hi, John.
Hi, Cengiz. I can hear you.
Perhaps I could ask so many different questions, but probably would expose us to lots of litigations, which Graham already highlighted as a big issue. Sometimes it hinders discussion, debate. But one thing that I'm wondering your views on how we respond to such high-profile accidents and events. And I guess you mentioned the historical context about 73 rudder accidents, goes all the way back to 90s. And my question is that if instead of between these two fatal accidents, tragic events, no doubt, instead of 8 months, if there were 8 years, even though the causation were almost the same, would we have grounded the fleet? Because the reason I'm asking this question is that similar events happened, not necessarily within months, but certainly rudder accidents, dare I say, US tragic events, fatal events, killing US citizens on US soil. And it was 7.3, the early versions, the classics, if I remember correctly, and we didn't ground. So the ultimate question, I guess, is how does the regulator respond to such kind of complex events? Because there's pressure from society, pressure from media, pressure from politicians.
Well, with this particular event, as you may well know, the FAA was very reluctant to ground. And most authorities are reluctant to ground an aircraft type. It's not the grounding is the easy thing. Establishing the criteria for returning the aircraft to service is incredibly difficult. I could talk about something slightly different here. Volcanic ash, for example, in 2010. It's easy to close airspace. It was a domino effect. Oh, we've got a problem. Let's close the airspace. But then trying to define the criteria for reopening the airspace was an immense difficult problem. Technical, social, economic, everything came into play. Lots of people wanted to be involved in the decision-making process. And I think that's what happened here, because of this wasn't just an aviation event. It went a little bit beyond that, particularly because it's the introduction to service of a new type. And of course, the expectation there is that the new type will be safer than all previous types. And so when it turns out that you have 2 accidents almost immediately, you introduce this new type, confidence is shattered. And so that's why you could probably get the reaction that we did, and the type was grounded for more than 20 months, which was the right thing to do, I think, because it gave people time to rethink, to redesign, to actually uncover some of these misdemeanors that have occurred. And, in the longer term, there may be some good learning that comes from this. As I say, implementation of safety management to design and production organizations, long overdue. It may actually happen now. I don't know if that was an answer.
No, thank you, John. Thank you.
Thank you. Well, any other comments or questions? I mean, I'm particularly interested, John, around the idea of sort of aircraft level analysis and the more systems perspective, which clearly was missing or fell over in the case of the Max. And I think the special committee that reviewed the FAA certification, one of their recommendations was around it strengthening the sort of systems level analysis that's required for particular changes. What's your I guess I wonder if I'll just be interested to hear what's your take in terms of what might be needed, or what are the challenges in actually implementing that sort of aircraft level or higher level view on derivatives, which necessarily are I suppose looking to make as few regulatory demands as possible in terms of the changes that a manufacturer is seeking to make.
This isn't a stationary subject, it's a highly dynamic subject, because the next level of challenges, for aircraft, certainly for avionics systems, are artificial intelligence, learning systems, maybe single pilot operation one day, so essentially you have, a pilot and a system which is like a pilot's assistant. So the level of complexity associated with new systems is going to mean that the methods that we apply for certification are going to have to grow and develop, which is what they are. This is where a lot of the expert effort is at the moment. One of the big transitions I see is this move from what you might call deterministic systems to non-deterministic systems. The systems we have on the 737, on all the types of aircraft flying at the moment, are essentially deterministic systems. In other words, when I get a compliance report, a test has been conducted, and it'll say something, the test result was passed, and that's true today, tomorrow, and the next day. But if you have a learning system, how do you test that? Because it's constantly changing. It's constantly changing. So the challenges ahead are somewhat greater than the challenges behind, which is interesting. But complexity per se is not the danger in my mind. We should not be afraid of complexity. You can dissect complexity, I think, and approach it, as long as you approach it rigorously with the appropriate tools, and that you give the people who need to, as I say, approach it rigorously, the time and the space to be able to do it. You know, it's no good thinking that an iPhone is going to solve this problem. There's a lot of work going on at the moment in terms of you know, drones and you know, these urban mobility, small electric aircraft, and some of these are going to be autonomous flight. And the systems behind that, it's going to be very interesting to see how they crack some of the really challenging problems, safety problems they're going to be associated with failure conditions in those systems. So in some ways, you know, the 737 is old hat. What went wrong here is not the method. The method was good. 1309 system safety assessment is good. It works, but it was very poorly applied, and the problems were really in the management system. You know, people did highlight things they were concerned about. They did identify the problems, but they were just not listened to.
Yeah, that's fascinating. Yeah, the process, the culture, the practice, the management is essential for implementing this in a reliable way. No, well. Thank you. Are there any? Oh, sorry, John. Do we?
One of the things I often found is that time spent up front is often time saved at the end of a project. You know, it's a project management thing. But of course, for commercial managers, they want you to get to the end date as quickly as possible. Time spent up front, making sure you do the verification and validation correctly, that you really do investigate every failure condition, you know, with the thoroughness that it deserves, and you classify the failure conditions correctly. That is never time wasted. But it's very difficult sometimes to convince people, you know, particularly when they're waiting for a report. Sorry, Carl, that's just another one I wanted to get in.
No, that's great. Well, thank you very much, and that was fantastic. Just before we take a break, any final comments or thoughts from the group? We're broadly to time, so there's no pressure on us time wise, but in which case I'll just say thank you very much again, John. That was fantastic and really appreciate it. And
it was a pleasure. Absolute pleasure. Thank you.
Let's take we're broadly running to time. Let's just take a 10-minute break, and we'll return at 5 past the hour, just to give us a brief moment to stretch legs and move away from the screen for a bit. And I look forward to seeing everyone back at 5 past the hour, wherever you happen to be in the world. Thanks very much. Right, I think we're around time. I'm assuming people are back on the call, taking a few moments to stretch. I can see Rune and John. That's a good start.
Hey, Carl.
Hi, Rune. Hi.
Perhaps at the end of this next session, we could have everyone turn on their video feeds and do like a group photo, a virtual group photo.
Yeah, great idea, Rune. That's super. Would you do make sure to remind me, perhaps at the end of after John Downer, maybe?
Yeah, I mean, I think we're as we have a lunch break. Let's maybe pull up the schedule here. What do we have going on next? We've got three more speakers. So I think if we can wait until after session 5, we may get some of the folks that are presenting to the CPUC this morning on as well.
Sure. Yeah, let's do that. No problem. And great to see everyone, and wonderful to see actually Professor Wyke as well. Delighted to see you there. Thank you so much for joining. And John Downer, really pleased to introduce Dr. Downer, who has done a huge amount of work around aviation safety in particular, and certification and regulation. And I'll be really fascinated to see your thoughts in this space, John, particularly as I know you have a new book coming out as well, which we should certainly encourage a bit of light marketing activity too. So perhaps I'll hand over to you, and thanks very much for being here, and really look forward to your session.
Great. Yeah, thanks, Carl. Thanks for the invite. Yeah, great to be here in virtual California. Yeah, I would plug the book, but if there's one thing that all the reviewers agreed on is that it needs a new title, so that's going to have to wait, I'm afraid. But yeah, there's a book going. Yeah, I'm more an academic than a practitioner, in the big sort of spectrum from practitioner to scholar. So I'm going to talk at a slightly different level of abstraction than people that preceded me. And yeah, I mean, broadly speaking, let me start with this. I'm a strong believer in the idea that not all technological accidents are avoidable or necessarily blameworthy, right? Even those caused by design flaws, and especially in civil aviation, which I think is astonishing domain for its safety practices. I mean, it does an amazing job. Yeah, I think that even the most ideal organizations and organizational practices just can't hope to avoid every design weaknesses in a complex system, right? Even the best laid designs sometimes go wrong, right? And I've spent a lot of time sort of articulating why I think that's the case, and thinking through the implications of that. But that said, I don't think there's any sort of getting away from the fact that, yeah, the Max crashes represent a real, meaningful organizational failure. Yeah, I think the Max accidents are an incredibly rare event in civil aviation. They are multiple accidents from the same design flaw, which sometimes described as the cardinal sin in aviation. And that design flaw represents a sort of breach of a kind of core, long established design sort of rubric, right? They introduced a safety critical system with MCAS, and it just didn't have redundant information feeds, like the AOA indicates, right? This isn't a thing that should have happened, right? I think Boeing design deserves to be called out for this, right? And it's incredibly rare to if you look through the history of civil aviation, to find accidents with one or especially both of these properties, right? Just thinking about it, I think I point to the sort of de Havilland Comet crashes in 1954, right? That both accidents caused by the same cause, stress fractures at the window corners. And then I think a better comparison is the sort of McDonnell Douglas two crashes of the DC-10 in 1972, and then again in 1974, right? The two accidents caused by the same underlying design flaw, which in itself was a sort of a departure from established design principles, right? The cargo door mechanism opening outwards instead of inwards, right? Yeah. And so I think, you know, in this context where there is clear sort of organizational failure, I think, on Boeing's part, it's intuitive to sort of look to the regulators, right? You know, the type certification process is supposed to police the designs of new airframes, right? That's kind of what it's for. You know, the FAA, yeah, carries some blame for this, and you see, you know, a lot of discourse around the you know, has gone in that direction, right? There's a lot of headlines about, you know, a lot of sort of soul searching and reflecting on certification practices and reform and so on. Yeah, but and I think there's a lot of merit to that on some level, but at the same time, I think that it's probably the wrong level of abstraction. You know, it's missing the bigger picture, I think. And I think the bigger picture is a much more interesting and much more sort of profitable sort of level to look at this, right? And I think understanding this biggest picture, I think that begins with sort of understanding that ultimately it's sort of unrealistic to think that regulators of complex safety critical systems can really police the designs of those systems in the way that we sort of imagine kind of bureaucratically, right? Insofar as the interests of the organizations building these systems diverge from those of their regulators or diverge from safety, then regulators struggle to sort of lead, right? Regulators struggle to sort of enforce safety. And I think there's a few principal reasons to imagine why this is the case, right? You know, there's an enormous resource imbalance with regulating the designs of systems, right? It takes thousands of engineers to design a system, and then you've got a sort of a few hundred regulators that then have to sort of oversee its, you know, you know, there's always a huge resource imbalance. More importantly, I think there's a big knowledge gap, right? So it's, as you know, you could see it in listening to John talk before me, you know, applying these rules, you know, certification standards, it requires myriad complex, incredibly nuanced judgments and interpretations, right, about the relevance of tests and all these kinds of things, right, that are much better made by those with the sort of technical intimacy to sort of, you know, that really know the systems, and that tends to be the people that build them and design them. And then there's this problem of sort of conflicting interests, right? So the FAA and other regulators and other domains sort of manage the two problems of resource imbalance and the kind of knowledge gap by delegating, right? They delegate to the engineers that actually build the things, right? But everything that sociologists know about, you know, power and so on, yeah, suggests that of course this is never going to be a perfectly objective system, right? Yeah, Boeing ultimately are paying the salaries of its DERs, right? You know, there's a whole sort of, yeah, even with the best will in the world, right? I think it's unrealistic to imagine that you know, those delegates will be completely objective, right? Even if, yeah, and so on, right? So and as well as sort of principal reasons to imagine that it must be the case, right? There's loads of evidence that it is the case, right? You see this dynamic between kind of regulator and regulatee, there's power imbalance in a huge number of domains that deal with these kind of complex systems with, you know, safety critical properties, right? So if you read the report into Deepwater Horizon, right, the strong theme of that is, you know, the inability of regulators to police you know, designs, right? Anyone that writes about nuclear energy, right, it's practically a leitmotif of that whole discourse, right? There's the regulatory capture. You see it in high finance, right? Financial regulators were unable to sort of really rein in the banks and prevent the sort of 2008 financial crisis and so on, right? And so on and so forth, in all sorts of different domains. And in the FAA specifically, if you look at deep dives into the regulation process by, the NTSB or the National Academy of Sciences or the GAO and these kinds of things, right? They come to sort of similar, they'll make this point, right? That ultimately the FAA, can't police things in quite the objective and formal way that we imagine, right? So, take this quote from a senior FAA official speaking to the Flight Safety Foundation. Says, the FAA does not and cannot serve as guarantor of aviation safety. The responsibility for safe design, operation and maintenance rests primarily and ultimately with each manufacturer and each airline, right? And this is, I don't think this is super controversial. Which gets me to the next point, I think, of the kind of bigger picture. And that is, I think the astonishing success of civil aviation ultimately has its foundations not in the good work, although of course it is very good work of regulators and manufacturers. On a deeper level, it's grounded in the fact that there's long been a sort of alignment of interests between airframers and regulators regarding safety, right? Which is just to say that it isn't profitable, even medium to short term, for airframers to compromise on reliability, right? And I think this is actually quite uncommon in this space, right? If you think about safety critical systems, right? The ultra extreme levels of reliability is incredibly expensive, right? And especially if you're not building many of these systems, which in most cases you're not. There's 400 reactors in the world, not that many drilling platforms and so on. The accidents are fairly rare, and the losses you incur from those accidents and the fines and they're very rarely sort of commensurate with the costs, right, or that you would spend on extreme reliability, right, or even commensurate with the costs that arise from the accidents, right? Partly because of insurance, partly because of bailouts, right? The financial system wasn't allowed to fail, partly because of the small operating volume. BP never had to pay the full cost of Deepwater Horizon. The nuclear industry never had to pay the full cost of Fukushima and Chernobyl, so on and so forth, right? They don't bear those costs, right? So if you actually sort of look really closely at, is it worthwhile? They actually, the financial industry did really well out of derivatives, if you think of derivatives as a technology or so on, right? But the aviation is different and unique, I think. It's the same in most respects, right? I think the industry doesn't suffer a huge amount from fines or legal liabilities and so on, just like every other. But I think it suffers incredibly vulnerable to sort of indirect costs arising from sort of reputational damage. It's historically, if an airframer got a bad reputation amongst passengers because of if it committed the cardinal sins that I spoke about at the top, right? If you have multiple failures from the same, especially avoidable design flaw, it got a bad reputation, and if it got a bad reputation, then its sales suffered catastrophically, right? After the Comet crashes, de Havilland never recovered, right? And the same again with McDonnell Douglas, right? After the DC-10 got a bad reputation, people didn't want to fly on the DC-10, right? The airlines started advertising that they didn't fly any, right? TWA said, oh, we fly exclusively with Boeing, and other airlines, Americans, started advertising that it only flew certain routes. So, some routes it flew exclusively with Boeings and so on and so forth, right? And then, people stopped buying DC-10s. And when the successor to the DC-10 came out, the MD-11, airlines didn't buy that either, right? And it killed McDonnell Douglas. McDonnell Douglas went under. And I think this had, this dynamic had, several sort of effects that were kind of beneficial to safety, right? Firstly, it culled errant airframers, right? McDonnell Douglas's culture sort of drifted, and and then it was no longer, right? It was a sort of Darwinian effect. It was removed from the pool of airframers. But yeah, more importantly, I think it served as a sort of lesson to the other airframers, right? Encouraging les autres, right? Everyone looked at McDonnell Douglas and thought, well, okay, well, let's not let that happen to us, right? I'm sure that's happening with Airbus right now. And yeah, it's also worth noting in this context, I think that jetliners are different in they operate in much higher numbers than most complex safety critical systems, right? So if you do have a design flaw, it tends to manifest in a much shorter time frame, right? As we saw with the Max. Yeah, and I think this has complex ramifications as well. Yeah, I think it's important to note that this dynamic, this pressure that wherever you mess up or for avoidable reasons, you die, is incredibly dependent on there being strong competition in the industry, right? So Douglas and de Havilland died in part because airlines had real choices, right? There were highly competitive alternatives in the same market segments for other airframers, right? And there used to be quite a lot of airframers, Airbus and Boeing, and then Lockheed and Douglas, and as you go back further, Convair and de Havilland, Vickers and Avro and Dassault and BAC, and that's just the West, and there are others. But I think if you look at the industry now, I think that yeah, that's kind of changed, right? I think this competition has declined. I think there's only two major players in this space now, Airbus and Boeing, right? And there's increasingly high barriers to entry into this market. You can't just start a jetliner company, right? And both airframers, right? Airbus and Boeing are considered sort of strategic assets, right? The States isn't going to let Boeing, just go bankrupt, right? It's in some ways it's too important to fail, right? It's a major defense contractor and so on. And then, more importantly, I think in this regard is that most airlines now are locked into long-term exclusive relationships with a specific airframer, right? So they buy all their airframes from one manufacturer, and then that has cost savings regarding sort of maintenance and training of pilots and so on, right? They tend to be locked in. So I think that yeah, Boeing will survive the Max failures in a way that McDonnell Douglas didn't survive its own sort of analogous error, right? For these reasons, I think the people that it's likely to weather this storm. The airlines that stopped buying the Max, most of them placed orders for different Boeing aircraft, right? So the Boeing didn't necessarily lose out too much, right? I think yeah, I don't think the extremely expensive and salutary for Boeing, don't get me wrong, but I don't think not in the same way as it could have been had there been a much more sort of a competitive market for airframes. And I think this has ominous implications. And I think this is the lens through which we should sort of think about the Max, right? I think when you look at the Max teaches us that even the best organizational cultures have a tendency to drift over time, right? There you go. Boeing had a sterling management culture and an amazing record for decades of safety, and then you can lose sight of what's underpinning that, and the kind of management sort of takes over. There's especially as they absorbed quite a lot of the management from McDonnell Douglas, and there's this whole story. Without the sort of uncompromising consequences of failure that characterized the industry's past, I think there's little to keep this in check, right? I think when we look at the Max, we should worry about these broader sort of structural forces, and we should think, well, actually, yes, it's costing Boeing a lot, but maybe not enough. It's not, beyond impossible that companies will look at you know, what happened with Boeing and what happened with the Max, and saying, you know what, actually Boeing's now, it's fine, you know, its stock price hasn't gone down that much, and it's, you know, it more important maybe to compete with Airbus than it is to, you know, the sum of the sort of organizational imperative behind safety is starting to sort of wane. That's what I see when I see the Max, and that's what I worry about most. So I'm gonna end there. Sorry, that was probably shorter than the others.
That was, yeah, fascinating. Thanks, John. That was really interesting and very, very thought provoking. I mean, I have some thoughts around, so I'll open it to the immediate comments. So I think John Vincent has put something in the comment box. John, would you like to, or John Vincent, I should say, would you like to elaborate on the sort of the unforgiving nature of aviation, or sorry, I was skimming through your comments as I was talking, but if you're interested to elaborate.
Yeah, I mean, I suppose, yeah, I agree with John. I mean, drift is one of the problems, isn't it? Even Graham alluded to that a bit by saying that, you know, we had an ever improving aviation safety record, and then something happens, you know, and it has a bigger effect, of course, if you're used to a high safety achievement. You know, where every time now you have an aviation, you know, a hull loss, a fatal hull loss, the newspaper column inches it swallows up are far out of proportion to the number of fatalities involved. You know, that's why I mentioned, you know, one of the purposes perhaps of aviation safety regulation is to maintain public confidence. Because however you put it to anyone, you know, sitting in a high-speed metal tube or plastic tube now, you know, buzzing through the air at 30,000 feet is a pretty scary thing. And maybe aviation does have a need for strong regulation in the fact that when things go wrong, aviation can be very unforgiving, you know, and that's not true in every type of industry or even in every form of transport. But I've had this discussion about fear of flying with people before, you know, and they have no fear about driving down the M25 at an unreasonable speed, you know, the motorway at an unreasonable speed. And then I say, well, this is the risk, your risk here, but your risk on going on holiday on this 737 is tiny by comparison. And, you know, that in the public mind, perception of risk is the important thing. So drift sometimes, you have perception of an immensely safe, well, the reality of an immensely safe industry, a perception of an immensely safe industry, and then something happens. You know, and that's where I sort of talked about shattering confidence. You know, something dramatic happens. So there has to be a dramatic response because of that momentary shattering of confidence. But you're right, within 5-10 years, we'll be talking about other accidents. We'll be talking about something entirely different. That's just my thoughts, John. I don't know if you agree.
Thanks a lot. No, I do agree. I think that if you look at what the FAA actually does, it does as much, I think, to testify and make safety visible as it does to sort of police it directly. And I think that although, you know, again, I would say that I think the unforgiving nature of certain kinds of failures in the industry has kind of underpinned its reliability in some way, and I do worry that it's becoming more forgiving in a sense, right? Even if we still get the same level of, sort of commonly column inches and so on, the costs of that aren't quite so high because airlines have fewer options to go shop elsewhere these days, I think, and I worry that that's creating a bit of a cushion that's allowing for a bit more sort of leeway with safety prices.
I kind of disagree in some respects, because the investment that's required to get it right, you know, billions of dollars, you know, to get a new safe type introduced to service. you know, there is only going to be a few organizations that are going to be capable of making that investment, and having the expertise and knowledge to be able to do so. So like your reference to nuclear power, you know, there are always going to be just a few, maybe a duopoly, or well, it's not really a duopoly. You've got, you know, Embraer and Bombardier and other organizations. Well, the Chinese, you know, there's the theory that eventually COMAC will become a leading player in the world. So there's the competitive element has a positive aspect to it as well as a negative one. On the whole, you know, the organizations and the authorities, nobody competes on safety. At least that's, you know, that's what will be said and is often said. And it's right and proper, because we all learn, as Graham said, from accidents, events. You know, it's by the grace of God, accidents are rare, and it didn't happen to me, it happened to someone else. I'm going to learn from that, and not, you know, it's not going to happen from me. So the overall culture in the business is good, but there are these little, you know, moments when things break down, and that's clearly what seems to have happened here. Whether, you know, it's still quite difficult to distill exactly the point at which things went wrong. You know, some say it's when, you know, the corporate headquarters, Boeing was fundamentally an engineering organization. And then in 2005, the corporate headquarters moved to Chicago, and it became a different kind of organization. Now, was that a cultural shift that had implications throughout the whole system? There's something for someone to study.
So, yeah, I mean, I definitely buy the culture shift argument. I think that there's a lot of merit to that. People don't compete on safety. I agree to a degree, but then when, you know, people stopped buying McDonnell Douglas's planes because they had a bad reputation and passengers didn't want to fly them, then, you know, in practice, you know, they were kind of, you know, there's competition playing out through the lens of safety there, and yeah, I mean, yeah, they definitely were on some level. And I think that made all the difference. I think, you know, structurally, that one of the things that really separates civil aviation from a whole bunch of other sort of safety critical spheres like nuclear and I think it's that dynamic that has kept civil aviation, has allowed it to be so successful relative to other organizations, I think.
Yeah, thank you. I mean, it's interesting that this, you know, the premise that airlines don't actively compete or denigrate one another around safety, but as you say, there's the, you know, the public perception that doesn't change how necessarily the ticket buying decisions of the public, as you say, John. It's I wonder. I just noticed that Cheng has his hand up as well. Would you like to come in on this, Cheng, or do you have another question?
I think it's just follow-on question, really, because thank you very much, John. Interesting presentation. And so you talked a little bit about sort of the balance between in terms of both capacity and capability within the regulator and within the industry, because at the end of the day, the regulator needs both. It's not only the sort of capability, but it's also sometimes the numbers as well to be able to have an effective oversight. You talked a little bit about also, you used the word too important, but I said that too big to fail is always used in, particularly in financial world after the 2007-8 crash. You know, it's not in the aviation that sort of we've got examples, and I referred to DuPont, but we've got the RBS that which became twice the bigger size of UK GDP. And but when things go that big, and of course there's no appetite from anyone, particularly the political masters, that to be able to break companies, intervene or whatever, unless RBS did, but it was aftermath. So I know it's $1 million question, but I guess my ultimate point is about preventing organizational failures, particularly about the cultural and this and the other. When companies become too big, and of course the sort of trust issues were discussed, it becomes really challenging from external, particularly from regulatory perspective, to really identify when to intervene, particularly when you consider some of the paradigm shifts happening in our industry, certain Western world countries moving towards more of a sort of risk-based oversight approach. So do you have a view that what would be kind of the best way to try to prevent, particularly those countries which became too big to fail?
Yeah, I mean, as a sociologist, I'm more into diagnosing problems than fixing them. One's much easier. But I agree completely that when organizations become, as a social theorist, when organizations become too big to fail, there's all sorts of externalities that flow from that. And then you see it, this is talked about most directly in finance, of course, with banks and so on. But I also think it's true of Boeing and Airbus. Right? Maybe I'm wrong, but I don't think anyone's gonna let Boeing fail. And I think that again, mitigates the sort of consequences of failure and indirectly in all sorts of, the all sorts of very subtle ways that are very difficult to sort of put your finger on. This has far-reaching consequences. Yeah.
Because sorry to interrupt, if I may just also look at maybe from your discipline point of view, organizations, cultures within organizations. And if you look at any of these organizations, they have tons and tons of means and methods and measures in place that even up to the point of from tiny little raising a report all the way up to the whistleblowing. and if you look at the sort of some of the well-known kind of cases, even go back 15, 20 years, that there has been those cases in relation to this manufacturer, but in others, to others as well. But I guess the the big question is, despite all of these things do exist, which should prevent these things happening, and it's not only one, it's multiple barriers, we keep happening the same organizational failures. That's an ongoing trend. Not too many, but still maybe one every 10 years.
Yeah, no, I agree. I think one of the reasons why these underlying cultures and incentive structures are so important is because rules and regulations and calculations and so on are inherently imperfect, or they never quite get you all the way, right? Whenever you apply a rule or perform a calculation, you're making all sorts of judgments about what matters and what doesn't, and how to categorize different things, right? Are these two elements properly isolated from each other? Millions and millions of kind of judgments that fall between the rules and become invisible in some ways, right? Partly because of the rules, where the rules create a sort of false sense of objectivity often, I think, that allow some of these pressures to operate invisibly, kind of behind the scenes.
Thank you.
Thanks a lot. I noticed in the chat that someone pointed out that McDonnell Douglas didn't die but were bought by Boeing, and I understand, sorry, I was shorthand. I think the industry sort of talks about McDonnell Douglas going under, and technically it was a merger, but really the Boeing kind of they couldn't sell their plane, and they got bought by Boeing, even if the management team ended up being quite influential.
Right, yeah, and as some describe, almost a reverse takeover of Boeing from the management, the McDonnell Douglas leadership. Yeah, there's a few more comments in the chat box as well. I don't know if anyone wants to speak to any of those issues, Graham or John again. But it's but if not, I mean, while you're thinking, I mean, something that just occurred to me is that there's the what you're describing. It almost feels like there's this tension between sort of competition and the penalties that can accrue at a sort of structural or institutional level across an industry, with the disappearance of airframers who have committed cardinal sins of sort of repeated design errors or whatever that might be, and then the sort of challenges of competition at a more organizational or cultural level, even which potentially is one perspective on what was playing out at Boeing around cutting costs and trying not to overly modify you know, an airframe and you know, not creating a whole new type and just trying to create a new sort of revision of an existing airframe. So there's almost my sort of, you know, just I think it's a really fascinating set of ideas, and I'm just trying to sort of reconcile those, you know, those two sort of arenas of competitive behavior, if you like. And I just wondered if that, you know, does that resonate, or what's your sense around that? I mean, that's for John Downer or John Vincent or anyone who wants to.
I was going to say something different, actually, reacting to something John had previously said.
Yeah, sure.
What is it? The minutiae of these things is actually sometimes very, very important. Yeah, you're right. There's no such thing as 100% safety. There's no such thing as a perfect certification system. But the minutiae and the detail is actually very important. I think there's a saying of Gandhi, isn't there? Something, anything you do is irrelevant, but it's very important that you do it. It's the composite, it's the aggregate of the thing that makes it work. You know, everybody performing their part to bring back together a very complex set of interactions. And yeah, you know, there are assumptions that are made low down. There's a vast myriad of assumptions. Certainly when I started certification work, you know, you didn't get a CD disc or you didn't get a memory stick. You got a wad of computer paper. You know, a system safety assessment could be that high, and being able to review and check and you could sample things, but there's only so much you can ever do. So it's a risk exposure. You're trying to manage the risk exposure, knowing that the system you're applying is imperfect. And that's the best you can do, I think.
Yeah, I agree with that. Yeah, I mean, I think, you know, any airliner that gets off the ground is an astonishing engineering achievement when there's so many things have gone right. I just think, well, when you're dealing with systems that have to be reliable to, you know, 1 to the 9, right? With, yeah, no more than one failure every billion.
10 to the minus 9, 1 in a billion. Yeah.
Yeah,
my favorite number.
Yeah, the 9 nines. Yeah, you even the most marginal things start to become important, right?
No, they don't. No, they don't. That's what safety assessment's all about, really. It's about actually identifying those things that matter, and maybe you classify minor some of those things that don't matter. So you can then put your proportionate effort into the things that really matter. You've got to classify. You've got to deconstruct the systems so that you put the effort that you have available into the things that really matter. And that's a principle behind safety management as much as a principle behind system safety assessment. But it's an art. It's more than a science. It is an art, you know, in being able to make those judgments. And you need a volume of experience to be able to make those judgments. And again, that's why you probably need large corporations who can, you know, have the economies of scale to accommodate the kind of experience that you need to be able to do that kind of work.
But then everything hinges on this question of what matters, right?
Yeah.
Which is not a straightforward question at all. I mean, there have been plane crashes because the pin holding the pilot's seat in place is broken, right?
Well, there's that lovely story, isn't there, about the Voyager, which is the refueling aircraft of the RAF, where the pilot put his camera down and the camera got jammed between the side stick control. And I think they flipped or something. The aircraft flipped. There's no designer anywhere in a design office who would ever have considered that failure or that possibility. You know, the camera that the pilot was being used to take nice pictures of things, he put it down. So there's always an element of unforeseeability, you know, in any kind of human process. But imaginative and creative assessment should try and expand the mind as much as possible in terms of the combination and permutation of different cases that can exist. But often you're using historical evidence. You're saying, well, these are the kind of cases that can exist. These are the ones where we're going to do the analysis. yeah, there's always the black swan, out there, the new thing, the 737 accident at Heathrow, where they turned into a large glider. Basically, the 777 came in to land. The pilot tried to command some additional thrust. The engines didn't respond. The aircraft turned into a large glider. It was a fuel icing problem where a chunk of ice had gone down the fuel pipe and blocked an oil fuel heat exchanger. Nobody could see that coming. And the only reason it happened was because the aircraft had extended range operations, had been taken over Siberia into extremely cold environment, and a new problem, fuel icing, occurred. So there will always be things that happen where the imagination or the volume of data that the designers had was insufficient to be able to, anticipate that particular case. So yeah, it's risk management, and on the whole, I think we do a pretty damn good job.
Yeah, I mean, I agree with all that, and I certainly not my intention to denigrate the regulators and people that build, the airframes. It's an amazing achievement that fascinates me. But yeah, I mean, I do think Boeing dropped the ball with the Max a bit, but in the bigger scheme of things, I think, yeah.
There's I'm sort of mindful there's some interesting conversation in the chat and Graham and Runa, particularly. Graham, I don't know if you want to offer any comment around, possibly the reputational issues of, the new mobility systems, the sort of electronic, the vertical takeoff, tiny little things buzzing around. If you put a Boeing sticker on the back, what that implies.
Yeah, I mean, I think we're heading into a revolution in what aviation is about. There's a lot of excitement. There's a huge amount of capital going into exciting startups who are promising to deliver these kind of 4 to 6 seater vertical takeoff and landing aircraft, and they look fab. I mean, interesting enough, there's only ever a picture of one of them over a cityscape, not many of them. But for them to be able to separate, air traffic control is going to have to be completely different. So it's going to be an unmanned autonomous air traffic management system. And we need to decide what is the level of acceptable safety for those aircraft. Are they the same as they are for a Cessna 152, which is a much lower level of safety than you would expect if you're getting onto a 737? And what you don't see is a major airline brand on the back of a Cessna 152. And yet what you've seen, and people like Virgin announce, and I suppose United as well, with the new generation supersonic designs, that they've already said we will acquire these, and it'll be interesting to see what customers expect. There's been a number of accidents happen in the States. An ATR at Roselawn going back some years ago, flying as American Eagle, which of course is a subsidiary brand of American Airlines, but red, white and blue and silver like American was, but operating to a different level of regulation by a subcontracted airline, I think called Simmons Airlines. And there were a whole bunch of anxieties came forward when people realized that when they were buying into the brand, that brand that they were trusting, it wasn't just Boeing or Airbus, the brand was American Airlines, or it was Qantas or whomever. So I think there's something really interesting to come in terms of what level of reliability people will expect.
Yeah, I mean, it's a really interesting question, what we can expect from new technologies. I mean, but for the reason that John was kind of talking about, all the kind of these corner cases, icing under very obscure conditions and so on. I think that's the way that we've made jetliners so reliable, I think, is by hoarding all those lessons and really making sure we they weren't going to happen again. And then every time we build a jetliner, we don't change them very much, right? The jetliners from the dawn of the jet age look recognizably modern, right? I think there's a reason for that. We've been honing and whittling this design, this common design paradigm that is astonishingly reliable at this point, right? Everything to belt buckles, and we don't change a thing unless it needs changing. And to think that you can then build a radically new architecture and have it have anything like the reliability of the modern jetliner, I think is just logically implausible, epistemologically implausible, right? Because you don't have this history. I think that although the long and painful, the history of civil aviation, all those crashes were a necessary condition of the kind of safe air travel that we enjoy today, and not a thing that we can avoid because now we've mastered regulation, or if that makes sense.
Yeah, no, that's fascinating. Thank you all, and thank you, John, for a really challenging and thought-provoking conversation too. That was brilliant. We're pretty much keeping to time, so I'm keen to move on to Patrick Waterson if Patrick is on the screen and you're able to share your slides. It's
hi Carl, I think Rune's going to put for me. That'd be great because I've got a technical issue.
Sure, no problem. Rune, are you able to get Patrick's slides up and going?
Yep. Give me just 1 second here.
Brilliant. And while we're just doing that, I'm just delighted to have Patrick here with us today as I think one of the sort of leading figures really in system safety and ergonomics, certainly in my part of the world, and no doubt internationally as well. So I'm really excited to hear how you can present this challenge around culture, learning from elsewhere, and perhaps even one of my own interests at healthcare as well, what you might be saying around that too. So look forward to it. So Patrick, perhaps if I can hand over to you, and thanks very much. Thanks very much, Carl. Very kind words. I guess I've got quite a short presentation, but there's quite a lot jammed into it. I mentioned at the beginning of today that I'm interested in a couple of things, very much so, and that's one of the things I'm interested in is the patterns which exist across accidents when we have large-scale accidents, whether it's the Boeing or whether it's another type of accident. It seems that there be regular features which recur, and I guess that sort of question is so deep that it's probably going to keep me going for the rest of my days in some respects. It reminds me of something that happened I'm also interested in learning from accidents. You can probably notice behind me there are a set of it's a very messy bookcase. There's a number of books in there which are called Learning from Accidents or Organizational Learning Following Disaster. So it's not a new area. It's obviously been around since a long time. Some of you also may remember an accident or a disaster that took place in October 2017. That was the tower fire that happened in London, the Grenfell Tower. I remember watching that and in absolute horror. It was unfolding on live TV, and coincidentally, I was reading Barry Turner's book. Barry Turner wrote a book in 1978 called Man-Made Disasters, and in part of that book, he talks about fire safety and fires. And actually what he was doing, I think partly was tracing lessons from successive fires going way back to the late 1960s and 1970s. And it made me think about Grenfell Tower because many of those fires had the similar characteristics. Obviously things like the cladding, for example, which was on the building materials, the regulations, all these sorts of things were going through that. And you'll probably see in my presentation I'm very influenced by Barry Turner. He talks a lot about patterns. And he used the metaphor of the kaleidoscope of safety and how these patterns emerge and coalesce, if you like. So if I could have my next slide, that'd be great, thanks. Okay, I think I've probably done some of this already. So I'm at heart a psychologist, but I work in human factors and complex systems. My first sort of encounter with psychology was probably in the laboratory. So I was studying memory and decision making for my PhD. And then I got a first job, a postdoc, where I was working on job design and team working with a group of people at Sheffield University. And it was a bit of a wake up call for me because I was out in the field
And it never occurred to me that you could actually talk to people, you know, that sort of thing. They were more like subjects in an experiment. So there's a bit of a revelation. I've been at Loughborough since 2007, and I've run various courses on human factors and complex systems. Those courses and my research interests cut across a range of different domains. So Carl mentioned I do work in healthcare, so I work with the healthcare safety investigation branch. I've worked in rail, nuclear, all of those different industries. I've even worked in the food industry at one stage as well. Some of the topics I've worked on are safety culture, which I think is a very problematic construct. It's difficult to pin down, and probably to some extent it's a bit overthought. That's my view anyway, but that's another talk. But I also am very conscious of doing something practical, and that's trying to support investigators. And in the moment I'm working with maternity investigators at HSIB. I don't know much about the Boeing 737 accident, so that's great that some people have informed me a bit more about it. I managed to get some time to watch the Netflix documentary about a week or two ago, but that's not exactly a Diane Vaughan type Challenger analysis, you know, it's just based on a documentary. But I got a sense of what went wrong, and that's been backed up by the other two presentations, or through all the presentations so far today. Can I have the next slide? So these are my sort of initial impressions, if you like, while I was watching this documentary. Well, it reminded me of one major inquiry, a review which took place and was culminated in the Haddon Cave review in 2009. This was about an accident that took place, I think, 2006 or so, involving the Royal Air Force Nimrod MR2 aircraft. Whilst it was being refueled in mid-air over Afghanistan, a major fire broke out and resulted in the deaths of all of the people on board that plane. And this triggered a huge review by the government of safety within the Royal Air Force. If you ever get the chance to download it, I put the link in there. One of the reasons I put the link in there is not to read because you're going to read through it. It's massive. It's a huge, big report. But at the back of it, actually, it sounds like Charles Haddon Cave and his team. They seem to they discovered human factors and safety science. And the appendices are something I regularly give to my students to look through when I'm asking them to look from Swiss cheese to whatever it might be, stamp, or any of these other different systemic accident analysis techniques. Charles Haddon Cave is also quite a character. There's a few videos of him on there, and you know, he's a brilliant speaker. It's very entertaining. I won't go through a whole Haddon Cave review because that would take, you know, hours or so. But like, if you highlight some of the things which came out of that, and this chimed a bit when I was thinking about the 737 Max a bit. Lots of previous incidents, warning signs, early signals, whatever, early things going wrong, weak signals, which occurred relative to the Nimrod. There were design flaws, and obviously there were big design flaws going on at Boeing as well. On that, I forgot what the system's called now, but the system was right at the front of the aircraft, which couldn't be overridden. The safety case which was carried out was described by Haddon Cave as a lamentable job from start to finish, and there's a large chunk of the report which goes into detail about how that was done very quickly, paper safety, tick box mentality. In general, there was very much the look and feel of the organisation. The Royal Air Force at the time was going through what you characterise as organisational trauma. There was huge cuts to the organisation. Lots of people were made redundant or finished their careers early. Lack of recruitment, all those sorts of things. There was quite a bad atmosphere going on across the RAF, the RAF. Haddon Cave also points to heavyweight management structures which were in place at the time. When I watched the documentary, you could see that there were early warnings and people knew something was wrong. And I think this is fairly common when I look at these types of accidents, these big, large-scale accidents. It's almost like, I think Barry Turner talks about this, is that actually, you know, it's quite common for someone to shout out about this and it to dissipate and go away. And there are also things like conflict between ever-reducing resources, increasing demands. We always know that, you know, you don't need a psychologist to tell you that when you've got those things you've got in place, then you've got something toxic that's probably going to happen at some stage or other. And to make things worse, and this wasn't the case with the Boeing 737, the aircraft was pretty out of date by the time it was still in service after a number of different years. So having cave, I think it is, there are bits there. Again, let's use this metaphor of chiming with something or other. It chimes with Boeing 737. Can I have the next slide, please? So this is Matthew Whitehead, PhD. Matt came to me quite a long time ago, and he stayed for quite some time as well. He was probably about 10 years or so, 12 years. At one stage I thought he was living with me, but didn't get to that stage, so it's lucky enough. But and he was a sort of like mature student. He'd come out of the Royal Air Force, he'd been injured, and as a result was on pension, quite a good pension, and he was based at RAF Waddington. And he managed to get the RAF to finance his PhD, which was quite a task in itself. Matt knew some of the Nimrod crew and their families, and was very much the sort of like someone who's a learner, a lifelong learner, always wants to keep up with things and to learn more. So he collected so many qualifications over the years. He did his PhD, and I think Graham was the actual external examiner. I know Graham was the external examiner for this. And his PhD was called Cultural Readjustment in the RAF, the RAF, following the Nimrod disaster, the Nimrod crash. And in particular, he was focusing on a thing called, it was a really great thesis, thank you, Graham. It's a shame he hasn't published it. It's just one of these things, that life happens, that sort of stuff. But this was, he was focusing on stage 6, which is, if you know Barry Turner's model of organisational failure or man-made disasters, one of the stages is about incubation. So how the actual accident almost like bakes itself or incubates. And stage 6 was cultural readjustment. Unfortunately, in man-made disasters, I don't know whether he ran out of time or he didn't want to focus on that necessarily. There isn't so much about cultural readjustment, how an organisation rights itself after falling, a major fall, if you like. So this was a longitudinal study, 12 years. He did it part-time, full-time, and he had various issues, life issues throughout the time. But he did it over 3 time points. Now, obviously, I'm not doing justice to a PhD. This is my skimming the findings, I guess. First time, the time 1 when he gathered his data, his interview data as well, it wasn't survey data. He also was privileged that he had quite a lot of access to existing personnel. Many of them were his friends, many of them were colleagues. He had a number of documents which were still being discussed. He had, to some extent, he had 1 foot still in the Royal Air Force. But the initial phase was a bit of denial, panic, shock when this report came out. There was also a degree of organisational grief, if you like, following the disaster, because Waddington is where Nimrod was based, I think. There was also some problems with leadership within the NHS there, the Royal Air Force, and that because of the nature of this disaster, that they were really under the spotlight, enhanced scrutiny, the whole thing. When he did his data collection a couple of years later, things seemed to be settling down. A whole raft of new safety measures, safety management systems had been put in place, and the roles were more defined. And it generally seemed like that, and again, it's a $1 million question. How can you tell if safety has improved? But when he talked to people, it seemed like the new ways of doing safety management were settling down also, after an initial set of skepticism and problems. When he went back towards the end of his data gathering phase in time 3, he characterised this as, I think, quite critical, but lots of safety bureaucracy was in place, and described many people in the RAF as a cottage industry. Thanks for putting that out, Graham. And there was but the emotional impact of the Nimrod crash had lessened. Many of the people had retired, and maybe we'd argue that there's a danger that the organisational memory had gone as well a bit. I think the conclusion from Matt's thesis was that it really wasn't full cultural readjustment. The RAF had settled into what he calls, and I think this is a bit of a clunky phrase, I'm not quite sure I like it that much, but quasi-stationary equilibrium. Safety had got better, but still volatile. So if some of you know the Rasmussen characterization of the Brownian motion model, where safety is a movement towards a gradient, and if you might move beyond that gradient, then you're entering this space of unsafe activities. It was more, rather than it being something that was well established, it was moving between those 2 points, I think, as most organisations are as well. Could I have the next slide? So this is something we used in his thesis. On the right-hand side, you've got a model which is sometimes used to characterise behaviour change. So if someone's trying to reduce weight, give up smoking, drink less or whatever, there's obviously a stage of pre-contemplation. There's a stage where they actually take it seriously, there's preparation. There may earlier on be a stage of denial and someone thinking it isn't a problem when it is actually a problem. And there may also be a relapse where someone actually falls off the wagon or so, or starts smoking again or whatever it might be. But hopefully eventually, if things go right, they maintain that behaviour, and let's say they give up smoking, for example. And I thought that was not a bad way of characterising, say, some of the things which we were going across these 3 time phases. There were periods of waves of relapse and periods of denial, and it seemed to fit the data quite well. Yeah. And if you read Massey, he makes a lot more of it than I'm doing today. That's in contrast to, I think, sometimes when we look at safety, we think of safety as an arrow, where it's got continuous improvement. And that phrase, continuous improvement, is often used by managers, for example. Whereas in fact, it's probably more like a spiral or something like that. So here you've got a safety maturity model, where organizations are supposed to jump up each of those steps and eventually get to this, what's known as a generative phase, where they're actually continually improving. They take safety quite seriously, and they don't just pay lip service to it or do paper safety and those types of things. I worked with a Brazilian colleague in 2018, and we wrote a critical review of maturity models. But don't get me wrong, I think they're very useful as a way of, in the same way that Swiss cheese is very useful, of actually getting over a complex idea. But I think the trouble is sometimes when organisations use them, and one of the artifacts of using them as well is it can lead to some complacency. Yeah, we've got to level 5. We're generative. Everything's perfect, and that we don't need to do that much more or so. Whereas in fact, it's a continual moving target, safety. Yeah, and sometimes I read a lot of accident investigation reports, and often the term complacency or locked-in mindset comes to mind, those sorts of things. So there are issues, but I think the idea of safety as an arrow doesn't strike me as particularly useful. Okay, so the next slide, please. So this is where we get a bit wild, I guess, in the sense that, healthcare, why would healthcare have anything to say to aviation or speak to aviation? Well, I think it's a lot, really. Again, this is based on an investigation. This is Morecambe Bay, where there were a number of maternal deaths of at least 16 babies, and this was completely abnormal. It was an unacceptable rate of death amongst children, and many children harmed. When you think about maternity, a lot of things can go wrong, which don't result in death, but if a baby suffers loss of oxygen during the birth, that can have later consequences for learning or whatever, for disabilities, etc. So there's a lot of harm going on, and it's fair to say within the UK that's very much on the radar of most people here. And there's a whole part of the Healthcare Safety Investigation Branch which is set up to look at maternity investigations to improve them. Now you can see there that Morecambe Bay, about 2004 to 2013 was a period which was examined in the Kirkup report, which you can see on the right. This was drift to failure. We talked a bit about drift or so, but it was also characterised by repeated failures to investigate properly. Very poor learning across the whole piece over the years. Again, similar to Nimrod, probably similar to Boeing. There were warning signs which were shouted out. Baby death due to a mismanagement of care. There was even a whistleblower in 2008 which was ignored. I'm not using these phrases myself, but Bill Kirkup described it musketeer midwives. What he meant by that was that these midwives were very, very reluctant, and part of their subculture, if you like, was not to refer or to escalate problems or involve other types of specialisms like obstetricians or gynecologists. And Bill Kirkup described it as tribalism. There was a lot of tribalism going on there. I remember not that long ago, I was at a medical conference and I used something similar to this slide, and I said, medicine is very tribal. And afterwards, someone came up to me and said, I don't live in the jungle or anything like that. And that's not my phrase. It's not what I meant. I think it's dominated very much by particular subcultures, especially so. And that's what makes safety culture very difficult. There's also things like distracted by other things which were going on. So Barry Turner refers to this as the decoy effect, where an organisation is preoccupied with something else, and then it takes its eye off the ball when it's looking at safety. And they were driving towards foundation status, which I don't quite really understand, but I think you get financial rewards from the government if you reach foundation status. And as the previous John was talking about a minute ago, the regulation and oversight of care was confusing, and there was evidence of denial and cover-up. And that again explicitly comes from the report. So you can see, hopefully, even though it's maternity and it's not a flying plane or whatever, there are parallels in there between. There seem to be sort of like, to use the metaphor of the kaleidoscope, there are some aspects of that patterns which come out of that kaleidoscope are there in the background as well. So could I have the next slide? Thank you. So this is, sorry if this is a bit busy, but this goes back to what Barry was talking about a lot as well in his book. I'm not Barry Turner's agent, by the way, but I do think it's one of the best books I've ever read. It's one of those things where you go back to it and you see something new every time. Also, obviously it's dated as well, but in parts, but most of it is still very relevant today. And Barry talked about ideal types, and he borrowed this term from a sociologist called Carl Weber, I think. William Weber, could be William Weber, I can't remember what his name was, but anyway, Weber. And he defined that as individual phenomena which are organised into a unified analytical construct. So it's bits and pieces, to use the metaphor of the kaleidoscope, little bits of the bits in the kaleidoscope coalescing together. Yeah, rather like analysing data and extracting themes from that data. An ideal type probably doesn't exist, but it can be said to have some status as well. And the diagram, the figure you've got in front of you there, some of it's in green, and that's taken from Barry Turner's original work. So we've got things like, for example, individuals are preoccupied with major issues related to the task at hand, and there are overlaps with Morecambe Bay. I found some of those things in there. Some of the things are actually just taken from Kirkup, so protectionism and denial. I don't think they were necessarily, denial I think was mentioned in Barry Turner's book. But you've also got other things going on as well. Regulations not strictly enforced, complaints from the public treated in a cursory manner. That was in the original book, and that certainly was the case at Morecambe Bay, where experts were dismissed as not knowing maternity. And other different things, like, for example, fear of blame culture. Probably a sweeping statement, but healthcare is full of blame culture. And I don't think you can actually ever get rid of it, but you certainly can improve on things. And there was a lot of blame being exchanged within Morecambe Bay over the years or so. So that sort of gives you some idea of some of the things which, and again, I think they might resonate with other bits and pieces which we've got from the Boeing things. Obviously, some of them are quite different as well. I know Carl's on the Carl, I think is on the call, and I just wanted to Carl Bike. I wanted to say, I was also partly influenced by the work he did at Bristol Royal Infirmary, and phrases he used, like or constructs he used, things like cultures of entrapment. This was a system that had got into this pattern of behaviour and couldn't really get out of it. So if we're going back to our behaviour change circle, which I showed in another slide, it's very, very difficult to get to break out of that set of denial or stage that you're at. And there was no real awakening. So hopefully things have improved, but what's happening in the UK at the moment is we're finding that more and more of these things are coming out. So we've got some other investigations going on, and my fear is we're probably just scratching the surface a bit with some of the maternity investigators. There's a lot more going on behind the scenes. I think that might be my last slide. Can you flip it over for me? I think it might be.
Yep, I think that's your last slide.
Great, that was quick, but it's just it's quite a lot in there if you, in many respects as well.
No, thank you, Patrick. That was a very rich and thoughtful presentation, and it's really interesting to start thinking about these, as you say, the patterns that we can explore across different events and different sectors as well as you say, these sort of repeated similarities in process and structure and how events become organized and these sort of factors coalesce around issues. Well, I guess, you know, again, I have some thoughts, but I'm keen to open up to the group perhaps. Would anybody like to pose a question, offer a comment, perhaps a reflection or a thought? I'm just checking the chat. So we've got, oh, Graham, yeah, thanks for posting the thesis. That's certainly on my list from now. I guess I'd be interested in terms of thinking across different sectors and aviation and healthcare and the Nimrod. Oh, actually, sorry, I will let me hand over to. I can see other people have got hands up, so I will hand over the floor first before I launch into anything. Chingas, did you have was your hand up or is it gone down? Oh no, it is up. Yes. Okay.
I'm reluctant to keep asking the questions, but Patrick, thank you ever so much. I've listened to you before in London and other places, and as before, it's fascinating, really interesting stuff.
I've probably just got one talk, you know what I mean? I've probably got one talk, really, that's all. So.
No, not at all, not at all. But you know, the two key words that obviously the title sort of the culture and learning. And I guess I agree. I try to do the search on safety culture, but also look at the risk perspective. Very challenging at times. So sometimes I think we talked about sort of it's not easy to change. Leadership is extremely important, and all the rest of it. But particularly, I don't know much about NHS apart from what I read on media, and when I listen to you. But then. Some really interesting and sort of things happening that you just said, how can this happen? So when it comes down to the culture element, how much is this actually driven by internal factors? And also, I'm interested in your views. I'm sorry, a little bit political element, perhaps. How much of it's also driven and influenced by the very top level government policies, whether it's about targets, whether it's about all kinds of other things that actually inevitably influencing that culture within every institution in NHS?
I think it's both, isn't it? I mean, you know, Carl knows, but you know, I always use one of Carl's paper to show the regulation of safety, and so I think he came up with like 170 different regulators or factors or influences, and yeah, targets. You know, I used to spend a lot of time trying to look for hard evidence about targets, but you know, I personally think they probably do have an impact on safety. I think it starts very early. You know, it's like, I mean, I remember talking to a colleague who's an anaesthetist, Bryn Maxendale, about some characterizations that first year medical students had for different professions. So everything from a brain surgeon to an anaesthetist to an obstetrician. And some of the things that they were coming out and saying were just appalling, you know, like things like, well, a brain surgeon's a genius, you know, and it's like it's, you know, all these different characteristics, and anaesthetists are lazy, failed doctors because they didn't become surgeons, you know, that sort of thing. And I remember talking to Bryn about this, and he wasn't really surprised because he said that they probably thought like that when they were about 10 or 12, you know, because they were set on this course. And and it's reinforced by the socialization process as well, I think. So, but that's not to say that I don't think the influence of a really bad CEO that has no influence on the way the hospital operates or functions as well. I think it's just that you need to see all of these different things in action, and I'm probably going on a bit too much, but like I'm a big fan of Jim Reason as well, and I think Jim Reason used to say, when you got to the organizational factors, you can't do so much about them, but you probably can do something about the sharp end stuff, but the blunt end stuff is a bit more difficult. So that's a dilemma. That's another talk.
But I mean, if I may just follow on, because I've written recently something on a LinkedIn post quite critical about how come we award failure, and just like the banks, and actually a CEO walks away with lots of money, and then I never thought that I would say this, but unless we really understand what these people think, because it's in many cases it's their legal responsibility to look after shareholders' interest, as well as ensuring safety within their organization and within the products their organization produce. So I guess, yes, there's a lot of internal things happening and we need to focus on, but also if we're really going to try to prevent some of these organizational failures, there's a lot to be thought about very high level, even at government level policies, and that was what sort of where I was coming from, I guess.
Yeah, absolutely. But that's really, that's a big one, isn't it? There's a lot of politics in there, and I don't think I'm quite qualified to answer that one, but yeah. Thanks.
Thank you.
Thank you. Thanks. And just checking if we have any other hands up or any other comments in the chat. While people are thinking, I suppose it'd be interesting, Patrick, just to get your sense of. I'm like you. I'm a big fan of Barry Turner, and I think the quote that, or the aphorism that always seems most relevant to his book is sort of the smarter you get, the smarter it gets, and as you say, there's sort of layers of insight in there. But I guess it's interesting to think about this sort of moment of cultural readjustment that we appear to be in around the Max in particular, and the sheer volume of formalized inquiry and investigations that have either reported or are still sort of waiting for the final report into the Ethiopian crash. And I guess what was your sense in the? I wonder if you had just some observations around, particularly perhaps the Nimrod event and around Morecambe Bay, and what are the sort of things that disrupt or prevent these sorts of cultural readjustment processes, because I think, as you say, particularly around maternity, we have multiple ongoing national inquiries as we speak into East Kent and various other places in the NHS, and which clearly shows that there's more, there is a lot more to do since the Morecambe Bay inquiry reported. And I wonder if we've sort of got a live case around the Max event here. What things might we expect to see that prevent this?
I guess when I think about, I've just read recently 100 maternity investigation reports, and one of the reasons for doing that is I didn't know the identity of any of the women, or there's none of that information's in there, and I just started a project of applying artificial intelligence to mine information from information reports. It's a bit wild and wacky, but let's see how we go. And the motivation for doing that is to compare black ethnic minority populations against white. And I read quite a few of those, and if we know in the UK, black women are 4 times likely to suffer maternal death. There's all sorts of horrible statistics. And when I read those reports, you got a sense, even though I didn't know whether this woman was from that minority, that there was actually some sort of form of racism going on. There was some sort of this woman was ignored, was not treated with respect or so. And again, I don't know that, but it's my guess that there were language difficulties with the woman, and other things led me to believe it was an ethnic minority person. So, and And I remember when we first got the project, I got asked by a journalist, "Is the NHS systemically racist?" You know, and I thought, oh God, you know, I'm not don't open your mouth, Patrick. You know what I mean? Because that, you know, that's the sort of thing that journalists, you know, they can run you in circles about. But I did get talking to someone who's quite senior at one of the branches, and she said to me it was probably a societal factor. You know what I mean? It's like, you know, this society is probably racist. You know, and I think that's true. You know, it's a police force. It's not just a police force. It's other different things. I don't know what with Boeing Max. It's going to be very hard, isn't it? Because those people are still, well, some of those people are still there, aren't they? A large percentage of those safety engineers are still there. I think the CEO may have gone or so, but when we looked at Nimrod, there was that first initial phase. There was a huge amount of upheaval and very, very stressful. And at the time, Matt was working for them as well, so he knew what was going on. And you know, he even personally had a lot of time off because of sickness, because of what was going on. So I think, I don't know whether you experienced that or not. It'd be interesting to know. Probably doesn't answer your question.
No, it's great. It's interesting. It's it'll be, I think it'll be fascinating to watch, you know, what the translation looks like from the, you know, all of these recommendations, and, you know, the enormous amount of analysis and inquiry that's gone on, and what that will actually look like in terms of regulatory change and the you know, the actual implementation of new systems and processes. Yeah, sure. Well, that's great. Thank you. I don't know if any sort of further comments or thoughts from the group. We're sort of making good time. In fact, we're perfectly on time, as it were. So, in which case, to keep up with our schedule, I say thanks very much, Patrick. Thanks, that was great. Really appreciate your thoughts and the comparison. I think there's a lot more to be done there. So really appreciate it.
Brilliant. Thank you.
Thanks. And so delighted to move on to Professor Barbara Holder. Really pleased that she could join us this afternoon. And Barbara, I don't know if your slides are okay to share, or if you're from your machine, but let us know if we can do that on our side. But yep. Otherwise, perhaps I'll just hand over, and really look forward to your thoughts from, you know, both research practice and, you know, and sort of the sharp end, sort of as an insider as well, in fact. So thanks very much for being here.
Yeah, thank you for having me. Let me see if I can get this to present. Can you see, is it presenting?
Not yet. Not yet, no.
Okay. Huh. Well, maybe Rune, if you could bring up the slides, that would be better.
Yeah, that's great. Yeah, Rune, do you have the backup copy? No, there's no single point failure.
Yep, I'm loading it right now. Give me just 1 second here.
Oh, that was great.
Thank you.
It's interesting to note that in all of these web meeting things, the sharing of the screen is probably the most challenging part, and it's the one I think gets the least amount of attention. But anyway, that's commentary for the side. So here we go. We are now sharing the presentation.
Oh, good. And do I have control?
You do not, no, but you can tell me when to go to the next slide, and I will push the next button.
Okay, great. Well, Carl asked me to share some thoughts with you on human automation interaction. And like I said before, I worked at Boeing for 14 years in the flight deck research group there. I did quite a bit of flight deck work, design work, on the 787. I was not involved in the 737 Max, but I also did a lot of work on procedures and training, and so I was there when this stuff was happening. Next slide. So when we think about the design of automated systems, you know, especially now with the focus on AI, we think, oh, this is new and this is really advanced. But the reality is automated systems have been around for a long time. And over the years, there's been a lot of research done on the design of automated systems and how humans interact with them, and there's a lot of guidance out there for how to develop them and how to train the operation of them. And it still amazes me that despite, you know, decades of research and, you know, a plethora of publications, that a lot of these lessons don't get incorporated into new designs, and they really need to be. And I think that's a challenge for the human factors and safety professions to really make sure that those lessons are communicated so that they can be incorporated into new designs. So next slide. So we know that the MCAS system was an automated system that was new to the 737, and it was introduced primarily because of the change in the engines on the Max, and the system took data from an angle of attack sensor, and then that was fed into a computer, and a lot of flight deck sensors and information were connected to that one angle of attack sensor. And the way it worked is it would regulate pitch. So if the sensor detects that the angle of attack is trending towards a stall, it would automatically correct by placing control inputs to the horizontal tail. And this whole system, as you all know, was not made known to the public and to the airlines and to the pilots, and so nobody knew that it was there and that it would function in any kind of surprising way. When we think about the design of new systems, I like to review Earl Wiener's laws. And Earl Wiener was a psychologist who focused on the design of automation, and he had a list of laws that he kept. And this one I think is very pertinent because it really speaks to the consequences of automation that we really can anticipate, and that when you do try to address one problem, such as the engine change, it can create lots of other problems. And you just hope that the problem that you do create is not as significant as the one that you eliminated. And unfortunately, that was not really the case for the Max. Next slide. The other thing is, when we're designing systems, there are a whole host of assumptions that are made about the users, about how the system will function across a variety of situations, the people that will be using it. So the manufacturer here, Boeing, made a series of assumptions about this system that ended up being faulty and were probably never even made explicit. There's explicit assumptions, and then there's also implicit assumptions, largely driven by practices and belief systems. And In this case, there were assumptions that the MCAS system would only activate outside of the normal flight envelope, which for an air transport category jet, that's, you know, basically never. and that if it ever did activate abnormally, that the pilots would recognize it as a runaway stabilizer problem, and they would respond promptly and correctly using the correct procedure. And part of that assumption is based on the fact that that procedure and possible failure or situation of a runaway stabilizer was also present on the 737NG. So if you can bring yourself to see those as the same thing, then you would assume further that nobody needed to know, because it's the same and we don't need to describe it in the flight manuals and we don't need to train it. In the NTSB analysis of the accidents, Boeing, they found Boeing made additional faulty assumptions about the aircraft capability, and also the human performance response as the failure began to progress. Next slide. And so if you're the pilot, you're sitting there in the flight deck and you're getting indications that are telling you how the aircraft is flying, its state, and one of the problems was this faulty angle of attack probe. And it created a number of very confusing indications to the crew. As I mentioned, the angle of attack probe is connected to other systems and sensors. And so if it fails, then these other indications start appearing in the flight deck. There was an airspeed and altitude disagreement. The stick shaker was activated. There was stall warning indications on the pilot flying side. The master caution alert, which is this big yellow alert in front of both pilots, illuminated, as well as the ANI, and the flight director disappeared on the pilot flying side, which is usually a pretty scary thing. It's a big deal because it's giving you guidance, especially as in the early stage of the flight when you're trying to maintain a path. And then the stabilizer trim runs down and then it stops, and then it runs again and it stops. And so all of these indications are big deals. You know, the flight path is in jeopardy here, and there isn't a lot of time to figure out what's going on. And so it's reasonable that this would be very confusing set of indications to the flight crews. Next slide. Flight deck interactions between the pilots and the systems are governed by standard operating procedures. When there's a failure, there's another set of procedures that are called non-normal or emergency procedures. And these specify actions, steps for pilots to take to correct the issue or to, you know, put the airplane in a safe state. These procedures do have direct impact on safety and are very important that they're designed well. Some of those have to be remembered by the pilots because there are certain situations that require immediate action or some kind of maneuver, and the pilots have to know that. And usually this is developed in training, it's practiced, and it's practiced regularly. And so generally it is assumed that it's not a problem. It shouldn't be problematic to do that. Next slide. The 737, has been around for a while. It's an airplane that Boeing thought about updating and making an entire new type to be more compatible with the 787. But the demands of the market and the competition with Airbus sort of resulted in this change to just modify it a little, make it more efficient with the engines and update some of the flight deck. But it didn't provide an electronic checklist. Part of that is because that would require sim training. And one of the goals was to not have any training, or at least, not to a level that would require pilots to go into a simulator. And so the 737 still has a little book. It's called a quick reference handbook. It's made out of paper. It can also reside on an iPad as a PDF. But it is where all the non-normal procedures are collected and presented to the pilots. This is the front cover of the book. It's under a sheet of plastic, so if you are handling it, it stays intact. But basically, the very first page of the book is the cover, and this cover is called the Quick Action Index. And the reason why all of these non-normal procedures are listed here is because they're all bad. They're the things that can damage the airplane or potentially result in the loss of life. And so they get prioritized to the front cover so that the pilots can quickly access them. And so in this case, the 737 MAX emergencies initially presented as unreliable airspeed and altitude. And so if you're, a pilot and you're trying to figure out what's going on and you cue in on that alert, you're going to do the wrong checklist. The actual failure was a runway stabilizer, but these emergencies didn't present the way a classic runaway stabilizer would on the NG. And so in either case, the QRH wasn't very helpful to the flight crew in managing the systems and in managing the situation. So next slide. So this is the procedure for the runway stabilizer. In the emergency, both of the emergencies, the trim movement was intermittent. In fact, it stopped when the pilots put their fingers on the trim. It would stop the movement, and so this certainly would make this more confusing and potentially make the flight crew think that it's not a runway stabilizer and therefore not do the steps that would stop it. The condition statement is what pilots use to verify that the condition that they're seeing is actually what's happening, so that the checklist will work for the situation. The one thing about this is, the importance of the flight deck indications being sort of distributed, and there's not a centralized alerting system in the 737 that connects the failure to a checklist in an electronic checklist. The pilots have to put these pieces together real time while they're flying and identify this as the problem. The other thing is that if you're holding the column or yoke, normally that will interrupt the stabilizer nose down trim, but it didn't do that in the MCAS activation. The pilots were able to counter that, and so this was very confusing potentially. Next slide. The other thing is everything that is above the dashed line is considered a memory step. So even if you could get to the checklist, technically the pilots are supposed to have done these steps before they get to the checklist. And then once they've done the steps, they call for the checklist and review that they got them right. The FAA expects that these steps would be done within 3 seconds of the failure indication. And that's because this is potentially a catastrophic failure if it's not addressed immediately. Next slide. Further, it's hard enough to do stuff from memory when you're stressed and confused and overloaded, task saturated. Even just remembering the steps can be a challenge. But to do reasoning about if this, then that, and if not that, then this is difficult. And so there were steps to be performed for memory, and then there were also conditional steps embedded in the memory steps that required the pilots to reason about it, about the situation and about what they should do. Step 5 there is actually the step that would have stopped the continuous pitching by cutting out the step trim switches. But if you don't get there, you don't stop it. Next slide. So the FAA has an advisory circular for flight crew procedures. And in that advisory circular, it states that memory items should be avoided for this reason. You know, from a human performance standpoint, it's very difficult to perform these reliably. But in some cases, you just don't have time to open the checklist. And so there are a few cases where you need some memory items, like in the case of a smoke or fumes or fire event. One of them is to put on your oxygen mask. If you're going to have these, you don't want 5, and you don't want embedded conditional steps. The guidance says that, you know, there should be less than 3, and they should not contain conditional decision steps. And so this checklist, you know, I guess the point here is the design of it was not following the guidance, the very simple guidance that even the FAA provided, let alone an analysis of, you know, is it understandable from a language standpoint, and from, you know, an interaction standpoint with an MCAS system. Next slide. So I guess, you know, we're talking about learning, and the question is, have we learned from these accidents? I mean, a lot of the accidents spark research that investigates human automation interaction, and then that goes into guidance. But we still have automation related accidents and incidents. And it's almost as though, you know, yeah, maybe we've learned, but we don't do anything with it, you know, and the design of these systems really does matter. The design of the interaction with the systems matter, as does the way that the flight crew organizes their activity, so the procedures and the operating practices. And I don't think that we as a human factors and safety profession have really been able to infiltrate fully to make the designs usable and understandable, and certainly not on a global scale. We don't build airplanes all that often, and so when we do, we need to make sure that we really get it right. And the pilots are you know, they're at the sharp end of the operation. They're the last line of defense, and they need help. And we can help them with better design. Next slide. Because they're essentially where all these system elements that participate in the activity come together. So the design of procedures and the flight deck and operational practices are all very important, but so is training. Pilots weren't trained on MCAS, and depending on how their training is structured, they may not have even seen a runaway stabilizer for a year or more. So, you know, training is super important, especially for establishing the fundamentals of being confident and capable to fly the plane manually. I forget which one of the accidents, it was either the Lion Air or the Ethiopian, but the pilot flying tried to re-engage the autopilot multiple times. And, you know, if you understand what is happening, you wouldn't do that. You would just keep the autopilot off and fly. And so returning to those fundamentals of being able to manually fly the airplane under any circumstance, basically, and feeling confident about that is a really important contribution to the safety of the system. The way that we design operations and the culture of operations all have to be managed by the pilot, and decisions are made that trade off various elements. And then there's policies and procedures and regulations that also govern how things are conducted. And that all occurs within the context of the operation. So the pilots have a lot of responsibility, and they have to bring a lot together to manage it in real time. And I think we just seem to have taken them for granted. And I know there's a lot of there's been a lot of stuff in the press where, you know, Boeing is like, well, those pilots, you know, they weren't U.S. pilots. It doesn't matter, you know, pilots are all doing the same thing, and they all need to be brought up to a standard that we can accept globally. Next slide. So just some thoughts on future work in terms of design goals. Like we have done a lot of work in human automation interaction, and there's been some work in flight deck procedure design. Not so much. There could be more, but just some things that might advance understanding and usability and prevent some accidents and apply some of the lessons we've learned going forward, especially as we start designing and approving these new entrants. So we have the whole eVTOL community, the advanced air mobility community. We've got commercial space. We've also got supersonic aircraft that are all coming into the system in the future. And we need to really advocate that those systems and flight decks are designed better. And so designing systems that really provide feedback and good communication about their behavior and present dynamic integrated representations of the current situation and how that situation will unfold and how the system will function in that situation. The conditions and dependencies for system functions to either activate or deactivate is important to represent. And also promoting reasonably paced interactions. I mean, people need time to process information and understand information. The system needs to accommodate them and enable intervention when it's appropriate. some of these eVTOL aircraft are proposing no pilot intervention other than hitting a land now button that deploys a ballistic parachute. And I think, you know, we need to ask, is that the right kind of intervention? Flight deck procedures should also really help organize the workflow and structure team activities so that it's predictable. Everybody knows what they're supposed to do, and that this is understood to be part of the design. And that procedures can also be designed to structure the allocation of attention to flight deck interfaces, so that there isn't this, you know, overwhelming set of things to be monitoring, but that the work is designed to structure the allocation of attention so that the information can be processed, because currently the flight decks are there's too much visually to process everything, and important cues are missed, and that is part of the understanding issue. And then lastly, the flight deck procedures just need to be written in a way that's understandable and usable across all situations. And so those are just some thoughts for the future and for future design research that I think are important to meet the coming needs, not only for air transport, but also for other kinds of automated systems, be them ground systems that support unmanned vehicles, or these new entrants that are coming in that are highly automated. And that's my last slide. Well, this is my last slide. Thank you very much for your attention.
Fantastic. Thank you, Barbara. Really fascinating. And I mean, great insight into the, you know, the specifics, particularly around the sort of runaway stabilizer, the checklist and the challenges just in itself there. And I mean, it's thinking about your sort of principles or directions for the future as well. It's just so striking looking at the Max events that, you know, that there was just such a, I mean, not even thinking about sort of human-centered operations, but just literally the flight crews not even being aware that this system existed and was on the aircraft. It really is quite remarkable in that sense. I'm just looking. I know there's a few comments in the chat, and Patrick's got his hand up. Patrick, would you like to come in?
Yeah, I think I really enjoyed your presentation. It's like something I don't really know much about, but I just wanted to get some background information. When these checklists and all these other documentation, which is in the cockpit, when they're developed, how much are pilots involved in actually, you know, good old-fashioned user-centered design? You know, how much of that goes on?
Well, there's a technical pilot that is in charge of each model. And the 737 technical pilot, you guys may have heard of him, Mark Faulkner, who is now being charged in the US. He was in charge of the QRH for the 737 Max. And so there's generally for each fleet, there's a chief technical pilot and a deputy. And so they are responsible for writing the checklist, and they're also responsible for testing them. There's other pilots that are responsible for the systems analysis of the procedures to make sure that the procedures will actually change the system behavior. But the actual presentation of the checklist is written by different pilots. And so there isn't human factors review of them typically, which I think there needs to be.
I mean, you also would have thought that this would have been tested in a simulator, wouldn't you? You know that.
They do get validated in a simulator, but again, you know, it depends on what you're validating and the assumptions you're making, and that varies by model. So some standardization would be very useful in terms of those processes, I think. But, you know, it's like everybody's got their own baby, you know, it's like I've got the 777, I've got the 87, I've got the 37, and they own that.
Thanks, that's good, thank you.
Thank you. And I was seeing a few items in the chat actually. Ruben or John Vincent, do either of you want to come in and just pick up your questions, either perhaps around simulation or any of the other issues?
I'll let John go first.
No, I very much enjoyed your presentation. Thanks very much, Barbara. And I, you know, I sense, you know, the reality of everything you do, because, you know, eyes on these things, the scrutiny that's necessary, the questions that need to be asked, the reviews that need to be conducted. You know, this is how we identify where the problems are before they become problems.
Right.
As I understand it, one of the objectives with the Max was the type rating consistency. So they really didn't want to tell anybody about anything new.
Right.
So how much do you think that drove the decision making to effectively stick with existing procedures?
Oh, it drove it 100%.
That's an easy answer, isn't it?
Yeah. So Southwest was the launch customer for the Max, and they required no training, and so that ended up driving other requirements down the road, and there was a penalty to be paid by Boeing to them if they required a simulator, and Boeing wanted to avoid that additional expense, and so it just, you know, sort of cascaded as a series of issues.
Yeah, it's breaking that cycle, isn't it? Because once you get trapped in that kind of cycle of events, it's so difficult to turn around. Yeah. Do you have a recipe though? I mean, if you had to change those procedures, how would you persuade somebody to do it if no accident had happened and you saw the deficiency?
Oh, well, I think, I mean, I tried very hard to get the procedures to be better, and we made some inroads. We did do some good things and had some successes, but you know, it's almost like, you know, you have to have somebody who's got the history and is there all the time, because there's changeover in you know, the people who are responsible for making these decisions, and so you need continuity, or at least you need some pretty stringent validation metrics to say, you know, we need to make sure that anybody can understand this under any circumstance. And usually the people who are doing the testing of the procedures are other flight test pilots at Boeing. So that's not the best sample for a global pilot community. But
they do involve line pilots to some extent, don't they? But I suppose, again, they would be nervous about introducing changes if, you know, they decided that they didn't need to know.
Right.
Yeah. Interesting. Thank you.
Difficult, but important.
Yeah, oh, absolutely vital. Absolutely vital. Back to you, Carl.
Yeah, thank you. And Rune, did you want to come in?
Yeah, I wonder what the role of simulation, not necessarily, you know, pilot training simulation, but just simulation in general, to look at these systems from a holistic, integrated standpoint, is an opportunity to develop some synthetic data, if you will, on performance characteristics, to test assumptions, to look at variability and response rates. That's something that can be done virtually, and I think there's a lot of opportunity out there. What's your kind of perspective on how that approach has been leveraged as a risk reduction strategy by these entities that are venturing off into the new and innovative?
Well, I certainly agree that simulation is a very useful tool and could be leveraged significantly more. There are simulators, there's fixed-base simulators and full motion simulators that are used to validate the procedures, but it's not necessarily about their usability. It's about, you know, does the step do what it's supposed to do? And so I think there could be another kind of simulation where you're looking at the user and the system interaction with the procedure as the mediator of that action to assess that part of it, the interaction part. But the way the procedures are currently validated is just to make sure that the you know, if you hit the switch, it actually stops something or starts something. So some creativity in simulation and modeling would probably be really interesting to look at.
Interesting. Yeah, very interesting. And it also brings to mind some of the parallels with other industries and healthcare as well, where, you know, a lot of the design and certification is around, you know, does the button do what it's meant to do, as opposed to thinking about the device in its actual operational setting, where you've got 5 similar looking devices with completely different, you know, user interface designs and all the rest. So yeah, really interesting around that, almost the, you know, that sort of deeply situated, embedded sort of operational simulation, if you like, which potentially has some opportunities there.
Carl, can I do a follow on?
Yeah, oh, of course, yeah.
So I wonder what the role is for something like artificial intelligence to go through and do a review of the rules, if you will. You mentioned, for example, the FAA had a limit of, you know, 3 steps for the memory items and no conditional assessments. It seems like that's something that we could kind of put over to the AI side of the world to do another kind of review on these things. It'd be difficult, I think, for someone to sit down and have the attention span to look through, you know, 85,000 pages of documents to see if they followed all the rules.
Mm-hmm. Yeah, certainly. That would be a good approach, I think, because the QRH itself is not that not that big, but they link to much larger, detailed procedures. So that would certainly be a way to at least flag some of the issues in a short period of time. Yeah, good.
No, that's great. That's great. Well, thank you very much, Barbara. That was fascinating. I'm just looking down at the chat to see if we had any more comments. So just an appreciation of your presentation and the comments. That's great. No, thank you very much. That was really fascinating, and look forward to sort of carrying on those conversations too. Just really interesting work. Rune, I know you're keen to sort of have perhaps a screenshot photo of everyone involved. Should we organise that now and then take the break?
Yeah, that would be great. And I was going to ask the group, since there's a smaller group of us, perhaps we take just a short break. And I know Ian is here, so maybe he would be willing to present, so we don't fully break the little momentum that we have. Or I'll leave that up to the group, but that's a potential option. I know Chris and Paul will be joining us shortly. But anyway, I'll throw that out there.
Sure. I mean, that's fine by me, but I'm sort of happy to take a collective view on that. Yeah, great. Well, I guess so. Rune, how do you want to work this? Just everyone turn on their, if everyone's happy to turn on their cameras and be sort of present in the screenshot in the room, as it were.
Yeah, and I don't know if you guys can see, or I have it on together mode. You see together mode?
Oh no, I think that's just you. I think it's user by user. So
okay, all right. Yep. So we need everyone who's got a camera to turn them on. I see a number of blank chairs, so that means I'll do a preview picture here. Let me share my screen so you can see the preview picture. You see the preview picture?
Oh,
That's together mode. So we need all the cameras on. I got a bunch of empty chairs. All right, Gianpaolo's on there, Esfandier's on there, Howard's on there. We need Ian to click on his camera. I don't know, Carl, if you have your camera. Who else is on my list here? All right, well, I'm gonna take a couple screenshots. So smile. There we go. All right, that's exciting. This virtual world. I'll do one more, and then I'll Photoshop in everybody else who's not here. All right. Okay, so let's see. Did you guys have an interest in kind of taking maybe a short break and then carrying forward, or do we want to take a 1 hour break and lose a bunch of people? Short. Great. All right. So I don't know if Ian knows it yet or not, but he's on next. I'm going to move him up in the queue because he's here and Chris and Paul aren't. So maybe like a 10-minute break or 5-minute break, 10-minute. So we'll come back in 10 minutes. Great. Thank you.
Sure. See you then.
So fun fact for those of you who are still with us, and I don't know if you felt it, but at about 2.5 hours ago, we had a magnitude 2.8 earthquake centered right about below my house.
Wow.
So it was an interesting morning.
Yeah. Yeah. So where are we? Everybody back?
Not quite yet, I don't think. We'll give folks another minute or two.
Okay.
And I did hear from Chris Hart, so he should be joining shortly. And then Paul, I don't know what time his presentation was with the Public Utility Commission, but he's scheduled to go last. So I think that's all going to work out great.
Okay. But you still want me to go next, right?
You are going next, yeah. So if there's anybody out there that hasn't rejoined, speak up now. Okay, hearing no objections. Carl, should we jump back into it?
Yeah, sure. Let's make a start. That's great.
All right, so I will share my screen and do the slides.
Okay, good.
And
Okay, let me begin. And then I want to talk about the key role of assumptions in crises. I've been listening this morning, and assumptions are key, obviously. But I want to give a brief overview of crisis management. Next slide. You hit the next slide, Rune. Okay. There should be one before that. If not, okay. I'm going to talk about the socially responsible organization. We've been hinting at all morning, and it has a number of attributes. One is continue to demonstrate a real concern with the most vulnerable users and members, direct and well as indirect stakeholders. Active monitoring, prevention, particularly focused on unintended consequences of one's products, services, technology, putting the health and safety of consumers first, and most of all, thinking and acting systemically. Next one, please. Okay, overall plan. First, I want to talk about what proactive crisis management, and most critical, how do we ensure that it's practiced, which a number of people have been talking about. Next, please. Okay, let's talk about the common definition of a crisis. Next. Some unexpected event has the potential to cause serious and lead to deaths, attract serious media attention. You want to go back? Okay. The last thing is very early on, the media crystallize and put people in one of three roles: a victim, a villain, or a rescuer. Once you get cast as a villain, it's hard to get out, but not impossible. But you have to learn to do the right thing. Next thing, the common definition is not entirely wrong. It's seriously incomplete. Okay, what's a crisis? Next one. Primarily, without exception, all crises result in the collapse of nearly all, of the major assumption that we've been making, why we won't get into a crisis, why it won't happen. Next. Since assumptions at the core of a person, an organization, belief system, in one fell swoop, crises destroy our entire belief system. We're left adrift in a disorderly and meaningless world. Next. It's thereby an existential crisis of the first order. Next, please.
what are the general types of assumptions? Very, very general. We adhere to the higher standards. We're ethical. We accept responsibility, readily admit our mistakes. We value and practice safety. We're a safety culture. We won't be blamed for a crisis. It will be believed that we say it's not our fault. We can trust our employees implicitly, and the media will treat us fairly. Next one. Okay, a deeper set of assumptions comes out from when you do interviews with organizations. And here are the kind of things you get, that organizations that are particularly vulnerable and experience that our size will protect us. We're so big and powerful, nothing bad can happen. Excellent company, talk about idealization, don't have crises. Next, our location, somehow we're secluded or protected. Certain crises only happen to others. Therefore, only a limited type of range of crises can happen. Next, if a crisis, someone will rescue us, bail us out. Next, it's somebody else's responsibility, not ours. Again, all of these are shown to be false and collapse. Next one. Each crisis is so unique, it's pointless to prepare. You can't, there's no general strategy. All of these are false. Next one. Okay, let me talk about the classic defense mechanisms are on the left, as discovered by Sigmund Freud. And what my colleagues and I felt as we did crisis audits of organizations, we found that every one of these took on a particular form. So denial became, we're invulnerable. Disavow, the impacts of a crisis are negligible. Idealization, don't have problems. Grandiosity, projection. Internalization, compartmentalization. So every one of these that were individual had a direct organizational counterpart. Next one, please. Okay, this slide was done by one of my students, a PhD student, that if you look at the level of crisis preparation, crisis prepared organizations use these rationalization seven times fewer than crisis-prone organizations. Next slide. So proactive organizations are on the left and reactive organizations on the right, and they're full of these rationalizations, denial assumptions. Next one, please. Okay, let me give you the general structure of proactive crisis management. Wish we had more time to go through it in detail, but there's a before, during, and after phase of crisis management, and we're constantly cycling through them. Before takes every one of the variables in the right, crisis type, phases, systems, and stakeholders, looking at worst case scenarios and preparing as much as one can, picking up early warning signals, so forth, and so on, exposing weaknesses and building capability. During, enact the capabilities, and after, treat PTSD and do hardcore lessons, what you did well, didn't do well, and redesign. Next one. Let me give you a laundry list of the general types of crisis. And the reason why this is important, even though we can talk about Boeing is primarily technical, that's not the case. Virtually no crisis ever happens by itself. It may start in one of these categories, but it quickly sets off a chain reaction. COVID is the premier case, unfortunately. When you look at COVID, I could give you a direct counterpart in every one of these categories. I won't go through them, but they're pretty self-explanatory. And what we've had to learn is that no organization should take them literally and say, well, we're not in the consumer products business directly, so we don't have to take product recalls or product service logo tampering. Years ago, I was working with an oil company, and only when the light went on of their convenience stores at their gas station they realized that they were vulnerable to consumer product tampering. Next one, please. Okay, one of the key phases of crisis management, I won't go through all of them, but one of the premier is signal detection. And one of the questions we ask, do the SDMs exist for any crisis, build on existing databases? Are they integrated? So if somebody picks up one, they'll be shunted to the right person. Are the signals strong enough to overcome noise? Who are the blockers? And do we know who to transmit them, the signal to? Next one, please. Okay. I had a student do her PhD dissertation on this about organizational signal detection. And here's what she identified. First of all, again, do the detectors exist? Is the signal received? Is it loud enough, clear enough? Is it transmitted to the right person? Is it correctly interpreted? Is it related to an organizational problem, excuse me, that the organization recognizes as such? Is it lead to actions that the organization knows to take, or the actions taken, and then the whole cycle gets repeated? The point is, it can break down at any point there. And it's not automatic that if it's done in one box correctly, it'll be done in the next one. Next one. Okay, let's look at technology crises in particular. And here are just a brief list of the many kinds of things can result in a crisis. First of all, idealizing users as though they are competent and will follow instruction. So we have to look at the abuses and misuses, intended, unintended, of a technology, unintended consequences. Often when people develop technology, they hype it. They only think of the ideal circumstances and the benefits. They don't think of the disbenefit. What about the latent defects and fatal flaws? What about unanticipated nefarious actors who will deliberately misuse vulnerable stakeholders, like children, who can be harmed by technology? Idealized false assumptions. Next one, please. Okay, one of the next key phases, and all of this has to be done by an organization, is probing preparation for particular specific, is it mandatory? Do you do formal fault analysis via simulations? Are the messengers of bad news rewarded? Or do you kill the messenger of bad news? What's the organizational status of somebody who deliberately looks for bad news? All of these are factors which affect whether one will be proactive or not. Next one, please. Okay. Okay, this is key, going back. Assumptions are all of the key proposition that stakeholders, excuse me, posit about themselves, other stakeholders, technology, such that if the assumptions are true, then a crisis will not result. The problem with assumptions, most of the time they're invisible. They're taken for granted. So they exist below the plane of consciousness, and only when there's a crisis do we become aware of them. So assumptions are the presumed characteristic properties, people, institutions, so forth. Next one. Okay, go back to that one. Unfortunately, most organizations merely react, as we've seen, to major safety failures and crises. They become more concerned momentarily about safety and reliability, invest more money for the time being, but vigilance is temporary. When things get back to normal, things flow away. They begin to mistake the absence of failure for the presence of safety, become complacent. Eventually, resources drift away, and the drift toward failure accelerates when there are cost and time-cutting pressures. When organizations make a trade-off between safety, efficiency, productivity, so forth. And when the next crisis hits, cycle begins again and again, till finally maybe the light goes on, if then. We have to do something differently. Next, please. Let's talk a little bit about Boeing. You've already talked a lot about it. I can only go back. They were lulled, we were all lulled into believing that they, and we were involved, do a 5-year average of only 1 fatality for over 3 million flights worldwide. The US average was 1 airline fatality in more than 10 years. I can't see the bottom of the slide since the thing is blocking it out. Okay, so next one, please. So the guidance software that is designed for one specific set of conditions was modified without fully testing for others. The MCIS system is supposed to help pilots maneuver safely, instead cause pilots to swerve wildly out of control. So pilots were blamed for a faulty systems design. Next one. Constantly testing one's key assumptions is not a luxury. It's one of the key attributes of a crisis prepared organization, and therefore a socially responsible organization. Next one. Okay, let me talk about a model organization that stands in sharp contrast, an organization with which I've worked. The 1982 poisonings of Tylenol capsules with cyanide is generally acknowledged as the single event most responsible for the creation of the modern field of crisis management. Tylenol's parent company, Johnson & Johnson, acted immediately. It immediately withdrew all of the bottles of all of its bottles of all of the shelves nationwide until it could ensure the safety of its products. Next one. The reason is that in Johnson & Johnson's credo, the health, safety, and well-being of consumers came before profits. In short, crisis management is nothing less than thinking the unthinkable and doing everything one can to prevent it. Next, please. Okay. Auditing one's assumptions is critical. Outsiders are a must, obviously, since they're privy to some of the major assumptions, but outsiders are critical in order to push them. No organization can audit their assumption or their behavior entirely by themselves. They become blind to it. It requires asking the most uncomfortable questions up and down the hierarchy. The board of directors need to be continually apprised and updated periodically. In fact, the board of directors, along with regulators, are key in assisting that assumptions be audited, if not the crisis management preparations of an organization. Next one, please. For more, let me stop here. Rune and I have prepared a textbook, a workbook, Coping with Complexity, which goes over everything I've just said in more detail. Let me stop and please get your questions and comments. Be glad to respond as best I can. Anybody, please.
There's Carl. So at some point, Carl and I are going to do a transition, I think. So Carl, you let me know when you're ready for that transition.
Yeah, sure, thanks.
Until then, carry forth, my friend. You're doing a great job.
That's great, thanks. And thanks, Ian. That was fantastic, really interesting. Sort of the distillation of well, decades of expertise, obviously. But yeah, I guess maybe I'll open it to the group first. Just looking at the chat, there's we got a hand up. Oh, great, Carolyn, would you like to pose a question?
Yes, I would. There's so much I want to say, but having been in a situation, a crisis response that just you know, did exactly what you talked about, blows everyone assumptions right away in real time. So I'm thinking more almost like the political construct. What I find the hardest to work with the organizations that I, you know, coming from Coast Guard, for example, is dealing with the hubris. I always tell them hubris is your kryptonite. That is going to kill you, you know, you know, but at the same time, they have to have confidence because you know what it's like. You've been there. You got to be able. I mean, I signed off on. I don't have signing authority in the government, and I was signing off on $200,000 contracts, going, yeah, sure, no problem. But so as an organization that I worked with, as they got better at incident command, and I came to it through high reliability and incident command, you know, blah blah. In the beginning, you know, there was a lot of people who didn't make it. You know, they turned turtle in the environment, but then as they had more experience, they actually became harder to work with because they had the ICS 100, you know, ICS 400 from, you know, the back of the matchbook university. And therefore, hey, look at me, I'm entering the room with the bravado that every good captain has as they stroll on a ship, but it doesn't necessarily make for that ability to keep alert to what's going on. So do you have any ideas or thoughts about how to sort of work with those kind of type A important kind of folks, but got to bring them down without actually making them turtle?
See, I really wish I did, because I get asked this question again and again. And the sad answer is, unfortunately, it takes not just one crisis, but a repeated series of crises to break down the hubris or the idealization. And often that doesn't happen. Let me give you the best example, okay? Since I mentioned Tylenol. Years ago, I went out on the road and I went to Tylenol, went back again, and I asked them, what are you guys doing about product tampering? Because it was always present. And that got their attention because it was something that didn't go away. So the guy I was with, who agreed to talk with me, said, we have various internal assassin teams. I said, what? He said, yeah. One day we held up a bottle of one of our capsules, and we looked at the cap is the front door of a house and the walls is the side, and we asked, how could the burglar get in, do the most damage, and remain undetected? We soon found out there was no such thing as tamper-proof bottles, only tamper-evident. The point is, I've tried to use that exercise with other organizations to varying success. Because the major thing we're talking about here is culture, and we all know it. Changing a culture is not impossible, but it's very difficult. So what is it that again gets the attention? A major crisis? Yeah, a series of crises. And some organizations, unfortunately, don't learn unless maybe they're regulated out of existence. See, if it were up to me, I would make it mandatory that once a year that we review the crisis plans of an organization. First of all, that they have a crisis management plan and that it be tested. But that's the nature of the socially responsible organization. And unfortunately, we cannot will social responsibility into being. So I know what you're talking about, and I wish there were an easy answer. The trouble is, not only is it their downfall, but even worse, it brings us all down as well.
That's especially true when we're dealing with the folks who are going to attend to these catastrophic events, right? Like they're the ones that you're going to look to that are going to try to bring order to chaos. And
that's right. That's right. You need to train the trainers. The crisis managers are the ones that most in need of training. I agree.
Yeah, and a lot of folks get into it because, you know, they think it's going to make them look great, but they don't have the skills. And I was in an event where we were told we were not even allowed to do an internal after action discussion because of the political component.
Wow. And that cuts back on the learning. Let me
people turn turtle too. Like some people just they just shut down afterwards. They couldn't, you know, they had no way of processing, you know, 20 days of being in the boom. Anyways.
Now, let me put in something that is somewhat related. My latest book is an analysis and biting critique of all the arguments people have given for not getting vaccinated for COVID. Because when we've done simulations, which epidemiologists have done, no one simulated all the systems that would be affected by COVID, plus all the dumb reasons people would give for not getting vaccinated. Not perfect, but they work. So the point is that not all the simulations and not all the things they do are up to the task that need to be done. And all we have to do is just keep pushing ahead, not give up. Anybody else, please? It's been a really good discussion this morning from which I've learned, and I think a lot of us were talking about the same thing, just in slightly different language.
Yeah, great presentation. I enjoyed it.
See Howard there. Hi, Howard. What's your question? Howard Foster.
Yeah, there's Howard and John both coming in. I guess, yeah, Howard, are you were you on? And I think you were on mute actually when you were talking.
Yeah.
There we okay. I'm sorry.
Great,
I'm kind of a tourist in this field, but my interest has always been in my experience in the Forest Service and some really terrible decisions, which basically shut down the Willamette National Forest because they didn't pay attention to the spotted owl issue. But I saw groupthink at its worst, and simply, and they have all kinds of statements about it that enable themselves to kind of accommodate themselves to the fact that the big shot in the room made the decisions and they were simply there to sign off. And so I've always been wondering about procedural issues or methods by which all the or more of the knowledge of the organization can be brought to bear in the decision-making process. And so I always liked the idea of the Delphi method by which everybody basically had to write their opinions on whatever issue is at hand. A crisis is this in spades. In other words, you really have to mobilize all the information that's pretty much there in your staff and bring it to bear. And I have yet to see any kind of procedure by which you might go about and do this. And I'm just wondering, why am I still thinking about something that was developed in 1954 by the Rand Corporation? Have we moved on? Is there anything better? Is there?
Well, there is something called a policy Delphi, if I'm correct, which is a dialectic. So you just don't get one point of view, because in a Delphi, normally you exclude the tail ends of the distribution. In a policy, right, you amplify. But there's also something, very, very few, one organization with which I worked years ago had, believe it or not, an official organizational dissenter. It was a role that was taken seriously, that person, and it was rotated in and out, had the ability to challenge, not fallaciously, but to challenge whatever actions were taken or not taken, and to really challenge the assumptions. Now, it's obvious why most organizations they view it as a waste of time, cumbersome, and all the rest of that. Right. But can you imagine an organization that said, our decisions are so critical, they affect so many people, that, you know, one of the things that I've worked with is something called the type 3 error, solving the wrong problems precisely. And this organization didn't know that term, but they were afraid that through their organizations, they would do the wrong thing, make the wrong products, make the wrong decision, and they really wanted to check on their decisions before they went ahead. In fact, I believe it was Alfred P. Sloan, who was chairman of GM many years ago,
Right.
that when his subordinates agreed too readily with his decision, he said, "Gentlemen, fortunately there were no women there, I propose that we go away and come back and have some different alternatives." Because he didn't know about the type 3 error, but he didn't want to commit it, whether he knew the name or not. But that's rare. Who amongst us really wants to have our ideas challenged? That's why crisis management demands a different inquiry system, at least a dialectic, at least multiple perspectives of a problem. Because we're not dealing with bounded, well-structured exercises. We're dealing with complex, messy problems that are unbounded and unstructured. Anybody else?
Yeah, thank you.
Yeah.
John, I saw you put the comment in,
Yeah.
and
Well, I mean, aviation, we're dealing often with what's considered to be a super safe system. So probability of occurrence of a lot of undesirable events is a very, very small number. So if you go to the group director and say, hey, we should prepare for this, the answer that comes back is, well, that's a 1 in 1,000 years. I'm not going to bother. And yet we know there are events of huge severity which we're not preparing for. How do you get past that?
Well, that's why I earlier put up the Freudian defense mechanisms, how one gets by denial. And again, whether the organization says, how can the improbable become probable? 9/11 was highly improbable. We know what risk management does. It takes the probability event times the consequence. If the number ranks low, then it's discarded. Versus crisis management turns it around and says, how can that be made probable? I know, because that blinds us. He said, don't waste time. Whereas if you have a responsible crisis management team, they're looking constantly for signals that it's becoming more likely and probable, not to discount it. But I know it happens all the time. So it demands a different mindset. The mindset that is comfortable for doing business as usual is not the mindset for doing the kind of stuff we're all talking about.
The one I have in mind actually is to do with the sun, solar flares, in other words, coronal mass ejections, wiping out half of our satellites. Because in aviation, we're so dependent upon satellite navigation now, and this can happen. In the 1800s, there was a thing called the Carrington event, which if it occurred today, would wipe out half of our satellites. So preparing for something like that and convincing people that they need to prepare for something like that, it's...
Well, if I can add on, Ian, can I add on to that other point? So this is something Ian and I have been arguing about frequently. And it goes to this point about past frequency of incidents. And that subscribes to the model that yesterday is a perfect predictor for tomorrow. Yeah. And the challenge is that tomorrow's technology is not a mirror of yesterday's technology. Yeah. I don't know how many people on the call.
It's not a static system, it's a dynamic system.
Exactly, right. So, and for new systems, I don't know how many people are familiar with the bathtub failure curve. It's a swoopy thing, right? So when a new system comes online, the failure rates are much higher. You're working out the bugs, unanticipated conditions. And then once you kind of get a handle on it, that error rate kind of stabilizes. And then as the systems near their end of life, we have failure rates increasing again. So I think there's an opportunity for the technical community to restructure the conversations we have with people. These failure rates are not static. They are time dependent. Well, which phase of the entity are we talking about? And so I think that's one way where you can at least change the conversation you're having with these folks. What life cycle stage are you talking about? How well do we know this system versus that system? inject notions of uncertainty into the conversations, so we're not falling into this trap of oversimplification and, you know, kind of misrepresenting what it is that we're actually talking about. This is a huge problem. Solar flares was one, but with climate change, if we look at the historic record for the last 1,000 years, right? Is that a perfect predictor of the next 100 years or 500 years? And the answer, the responsible answer, is no. But so then what do you do? And I think here's where we have opportunities to leverage things like simulation, embrace uncertainty, say, well, I don't know what it's going to be, but my best guess is in this range. And then we have what could be considered leading indicators, right? So as the systems are in operational deployment, are we inside the anticipated bandwidth of uncertainty, or do we fall outside? And we can use those as these signals, right, to say, hey, we need to go check these fundamental assumptions, because what we thought, pilot reaction time of 4 seconds or whatever it is not reflective of the reality, and what impacts does that have on safety. That's a tangible thing that we can proactively do, as opposed to reactive things like, well, what happened in the last 10 years?
Well, let me give you another proactive thing. When I was at USC, when I taught there, I founded the USC Center for Crisis Management, which was the first academic center of its kind in the world. I taught courses in crisis management in the MBA program. We all need to put the pressure on MBA programs, business schools everywhere, to include crisis management as a key part of the curriculum. So therefore, we hope that when executives go out and become executives, they will get it into their organization, because we're dealing with a wide number of organizations, and we have got to put everything in place that we can to help ensure that the organizations of the future are not run like the organizations of the past. No way. And that means every university, particularly, I can't really think of any curriculum in any university, I don't care whether it's English literature or what, because we can study things from a historical literary point of view, that wouldn't benefit from what we're talking about today, because it involves everybody, impacts everybody. So we have to take a systemic approach. We have to be as systemic as that which we're proposing. Anything else? Anybody else?
Thank you. I think, Howard, maybe that's a legacy hand that you've still got up, and unless you want to come back in, which you're very welcome to, of course, if you'd like. But
and we can open it up to general discussion as well. We're waiting for Chris Hart to click in onto the meeting. I don't think he's quite here yet. I think his scheduled time was in about 15 minutes, so we can use this as an open discussion time until Chris clicks in.
I guess I'm interested, about the, there almost seems these two different modes of needing to be very attentive to early warnings and small disruptive signs of oncoming crisis, and then very active I guess confident responses once you're in a crisis mode. And I wonder, do you think it's possible to support those sort of cultural or leadership attributes within the same sort of team, as as a sort of flipping states, flipping modes almost, or do you think these are different functions within an organization?
Well, the organizations that I've seen that have taken the lead, that have been responsible, have had a crisis management team, and they've had all the major representatives of all the major departments on them. But in addition, they've had people from the very bottom of an organization sit on it, because when I've done crisis audits, interviews with the organization, often it's the people at the bottom who have a better realistic view of the crisis potential of an organization than those at the top. And if you have a good CEO and top leadership, one of the things I've heard them say, very few, tell me what I don't know and what I don't want to hear. I need to know it. I need to know it because it's going to come back to haunt us all. Therefore, I need to have on the crisis management team people from the top, the middle, and the bottom of the organization in order that we keep all of us honest. Because without it, we're only getting a slant of the information. So there are things we can do. Do all organizations do them or want to do? Of course not. That's why we hope that the organizations of the future, all we can do is lay out the model and illustrate. Look, one of the things we did research on, it was one of the most powerful, we were able to show that proactive crisis prepared organizations were significantly more profitable. So it was not only the right thing to do, but good for business because they got out in front and prevented crises before they happened. So as a result, they were more profitable, sued less often, every desire. But the thing is that's sad, even when you put out that data to people who come from a reactive organization, it doesn't get through because the blockers are so big. But you have to keep saying it and help the proactive ones become industry leaders.
I'm going to jump in here. So this reminds me of what Graham was talking about earlier in his interactions with the TUI airline. I don't know, Graham, if you're still on the call, but if you had to convince another organization out there to adopt some of these things, right? Like give me the bad news in advance so that we can react to it proactively. How would you structure a message like that?
That's a really challenging question because the ones that are most amenable to it are probably already having the conversation. And you remind me of an occasion not so long ago. We had a safety manager of an airline come along and do a safety management course, and when he introduced himself on day one, I thought the last thing you needed was to come and do a course like this. And what became apparent during the week was that he'd really come to recharge his kryptonite, to be surrounded by like-minded people. And at the end of it, he said, could you come along and basically say what you've said to my board? And I said, but you're perfectly positioned to do this. He said, yeah, but when I say it, they say to me, well, you would say that, you're the safety guy. And what I need sometimes is the reinforcement of an external voice that helps them realize that, you know, this isn't just about us, that the rest of the world is doing something that we're not doing. So I guess the conversation starts with an external voice, maybe with the help of a willing sponsor, that helps them realize they're perhaps missing out or not doing things that comparable organizations are doing.
Is that an opportunity that can we form such a group and be such a resource to the entities out there that are looking for this?
Absolutely. I think that's exactly right. I think Carl's a perfect example of that. You know, I remember Carl starting out as definitely an aviation guy, and that was a real bonus going into healthcare. And you've brought an amazing insight into healthcare, whereas now there's probably people in aviation just assume you're a healthcare guy. So actually, just shifting across modes like that can be incredibly powerful.
Yeah, hi, this is Svandiar. If I have a chance to chime in. First of all, great presentation and by everyone so far. Thanks a lot, Aaron. It was very good. And just to kind of reiterate what you said, there, you raised a couple of very good points in terms of, obviously it's all culture, right? And I've been in organizations that, you know, the risk management, first of all, I think everyone, even at the lowest level, kind of deal with risk management, whether they know it or not, right? Even on a personal level, we are every day, we are dealing with risk management, right? But when you bring it to a framework that is like repeatable, you know, traceable, defendable, many organizations lack that. And I had personal experience in that. And definitely on the top level, the organization, the leadership, if they are not on it, if they are not championing it, it's really hard to get anywhere. And the thing is, you mentioned about the everyone needs to be involved at the low level, mid level, high level. My experience has been like in especially big corporation, many of these mitigations and so-called projects are introduced at the top level. They, they get together, senior management, so, oh, we need to do this, we need to do that. So then they think they've got their job done, right? And they push it down without really engaging the lower level. And then they just, the lower level thinks, okay, I got my assignment. Let me go meet the deadline, present something, and there's no metrics, there is no, there is no accountability. So, and this just goes on and on. And as opposed to being part of the DNA of the organization. And this is when I say cultural, the folks that attended, with all due respect, MBA programs, past or even current, this is not taught as a part of the DNA of the organizations. It has to be part of the DNA. It shouldn't be risk management, shouldn't be afterthought.
Yeah.
Shouldn't be afterthought. It should be, so just want to add that. Yeah.
I agree. Thank you. I agree.
Great. Well, I see Chris Hart has joined the meeting. Any last remaining questions for Ian and crisis preparedness? All right. Well, thank you so much, Ian. And welcome, Chris. Thanks for taking time out of your schedule. So we've actually never met in person. I think we've interacted virtually for a number of years, but welcome and nice to see you. And thanks for joining our little workshop today here, looking at aviation safety and lessons to be learned from the Boeing 737 incident.
Absolutely, my pleasure. My warning is that once you get me started, you'll have trouble shutting me up.
All right, we accept your challenge, Chris.
All right.
Yeah, I'll go ahead and pass the ball over to you, and away we go.
Okay, so
let's see. There are some slides. Did you want to share your desktop, or do you want me to do the slide advancement?
If you want it done right, you better do it.
Oh boy.
Because my my IT advisor, aka my 19-year-old daughter, isn't here right now. So.
Perfect. Give me just a second here, and I'll get you up and going.
So, how many people total do we have that are involved in the meeting?
I think we're down to like 10 or something.
Oh, okay.
Yeah, it looks like we've got 12 on the call here. We've had some of the UK based participants have been tuning out, but it's delighted you could join us. Thank you.
Well, it's my pleasure to be here. I'm delighted to be invited.
I gotta push the right buttons.
Better you than me.
Yeah, I know, right? All right, here we go. The journey begins.
So my thought is that if the group is that small, if people want to ask questions as we go, I'll leave that to you. You're organizing it, but it wouldn't bother me if that's what they want to do. But either that or just wait till the end and then ask questions after that.
Okay, sounds great. Yeah, when I'm sharing the screen, it's hard for me to manage the chat box, all that stuff. So if the audience wants to unmute and ask questions, go to. You are empowered.
Okay. So go to the first slide, please. So this is about the MCAS, Maneuvering Characteristics Augmentation System, and they adapted it from another airplane, the 767, and put it on the 737 Max. But contrary to media reports, which was that they put it on the Max because the Max was otherwise deficient. It wasn't a matter of deficiency at all. What Boeing was trying to do was to make the Max feel just like its predecessor, the 737 NG, so that pilots wouldn't have to retrain in the Max if they already have 737 NG type rating. They wouldn't have to retrain and go through a lot of simulator time in the Max. So that was really the reason for it, was to make the airplanes behave the same and not so much to resolve a defect as the media would suggest. So the problem was that on the 767 use of it at high speeds, the MCAS relied on only one source for input, and in that situation, the MCAS was weak enough. It didn't have very much authority because it was operating at high speed where there's a lot of air going over the control, so it didn't need to move the controls very much. But then when they were trying to adopt it to low-speed environment, now it needed to move the controls much more in order to have enough air going over the control surfaces to have the desired effect. And so that's where they failed when they did that evolution. They failed to also do the evolution of the number of information sources that it would rely on. So the result was the 2 tragic crashes and 346 fatalities. So I'll go through what we discovered as part of the Joint Authorities Technical Review. So go to the next slide, please. So the joint, I give a master stroke to the FAA for creating the Joint Authorities Technical Review. Next slide. Again, because what they did was they invited experts from 9 other aviation authorities. Basically, every aviation authority that certifies airplane except Russia was invited to this meeting, and plus FAA and NASA. So there were 10 countries plus NASA with the cert experts to look at what the basic question for the FAA was, how did something this defective get through our approval process? And that's what they wanted never to happen again. So they wanted the Joint Authorities Technical Review to do a in-depth look at the processes of their certification and make recommendations as needed to make it more robust so that defects like this would never get through again. So I think the FAA recognized this, showed when they brought the worldwide certification experts in, that showed that they recognize this is not an FAA Boeing problem. This is a worldwide problem, and let's get the input from the worldwide certifier so that what we end up with will hopefully have some international harmonization. So I think they asked me to lead it in large, well, A, because I was former chairman of the NTSB, but B, because I didn't have any certification expertise, and I think what they were looking for was a fresh perspective so that they wouldn't be getting somebody who came to lead it and said, you know, we've been doing it this way, we've been doing certification this way for 50 years, we're going to keep doing it this way for the next 50 years. I think they were looking for a fresh perspective, and so kudos to FAA for creating that, and I was honored to be asked to lead it. And also kudos to Boeing, because they were very willing hosts of the Joint Authorities Technical Review. They gave us meeting space, they reconfigured sims for us, they did all kinds of stuff. They gave us body resources, professional technical resources. So kudos to them for participating so freely, and showed us a lot of their inside stuff, which they didn't let us take away with us, but they let us look at it so that we could have a better sense of exactly what happened. So I think both the FAA and Boeing really behaved quite positively in this regard, and the FAA, of course, needed to, because it had lost stature in the world in the world scene after being the last one to ground the airplane, and obviously Boeing needed all the help they could get. So kudos to them for starting this process and creating what I think was a very successful effort. Next slide, please. All of
Chris,
the media. Yes, go ahead.
I'm terribly sorry to interrupt, but you did say we could ask. So, sure. I mean, the last point that you made about sort of you've given credit to both FAA and Boeing, that they're actually openly, honestly sharing data, right. Which is great to hear, but which also contradicts with some of the sort of publicly available, and I don't know, maybe that they have a personal view on this, but particularly even politicians struggle to get data out of Boeing, and particularly Boeing. So is it a case of like technical experts perfectly happy sharing technical data with is a different thing than actually when the politicians get involved or requesting information, the organizations react differently?
Well, that's a very good question. I think what you're seeing is that the technical experts were happy to share with each other. I mean, Boeing wanted to share that information because they, most of all, never ever wanted to see this happen again. So they wanted our technical experts to be able to dig as deep as possible to make sure this happens. When you talk about legislators, that's another thing. First of all, the information won't be private once you give it to a legislator. But second of all, what they can do about it is much more questionable than what the FAA as a regulator could do about it. So there's a huge difference in their willingness to share that with anybody in the public versus sharing it with us. But like I said, even when they shared it with us, they didn't let us take it with us. They just showed it to us so that we could use it in our deliberations, but they didn't let us take it with us.
Okay. I think that's the litigation bit that sort of probably is a hindrance.
Probably plays a role in it. Yes.
Thank you. Thank you.
Sure. Thank you for the question. So the media also reported that the certification process was broken in a lot of lot of legislators try to get, you know, on their soapbox and say this shows that the process is broken. But to me, when we've got a history of almost 10 years of carrying 1 billion with a B passengers with only 1 fatality, the foundation of that success is a very well-designed airplanes, and the foundation of well-designed airplanes is a good certification process. So to me, the process isn't broken, but as with any other process that's created and operated by humans, it can always be improved. And the 2 MAX crashes really showed it's time for some improvement, and that improvement was basically, in essence, modernization, because airplanes have become more complex since those processes were started, and now the process needs to grow up with them and become more modernized with them, because as they become more complex and interconnected, the challenges become significantly greater. So no, it's not broken. Yes, it needs to be fixed. So that was kind of the high level of what we saw. Go to the next slide and I'll tell you some of the ways it needs to be fixed. So one is that when the systems are more connected than they used to be, then that means that necessitates looking at how those connections work with each other, and that which needs a more holistic approach, a more airplane level approach, and not just let's look at this, let's look at the MCAS and see what the MCAS does and doesn't do. What you need to do is you need to look at the MCAS as part of an airplane system and see what it does and doesn't do. And so when you increase the complexity, then you also increase the likelihood that a failure won't be an immediate failure, like, oh, the landing gear won't go down or something like that. It's going to be, it increases the likelihood it's going to be an insidious failure that is gradual. So that means the standard that the FAA has historically used, the 1 second, 3 second standard, that's all about when something goes wrong, the FAA regs require you to give the pilot a second to see that something went wrong and 3 seconds to fix what went wrong. So in order to pass the certification standards, what that means is the certification test pilots can't touch anything for 4 seconds, because the assumption is if it takes this long to fix it, then it better not become better not become unfixable within 4 seconds. So when they do the certification test flights, they have to not touch anything for 4 seconds after something goes wrong before they can try to fix the situation. So if it's an insidious failure rather than an instantaneous failure, that's a lot harder to see. So there's, when do you start that clock? When do you start that 1 second, 3 second clock? So that's just an example of how the standards are outdated. Another reason they're outdated is because when you increase the complexity of a system, you increase the combinations and permutations of things that can go wrong, and plus you increase the likelihood that there won't be a regulation that addresses this specific situation. And so if you run into situations that don't have a regulation, then what do you do? Because the certification process has historically been based entirely on compliance with regulations. So now you have a situation that needs to be addressed, but you don't have a regulation that addresses it. Then what do you do? That's where this is basically a potential foundational change for the certification process, is having to base certification decisions on safety rather than basing them on compliance. And that's a major change, because compliance is binary. Either you do or you don't. Safety is not binary. You never really reach safety. So now it's a judgment call, and that's going to be a much more challenging operation for the certification experts than back in the old days when compliance was enough. Another issue that was underlay this whole process was, with that level of safety that I talked about, of 10 years of carrying 1 billion passengers with only 1 fatality, then complacency rears its ugly head when things get that safe. And that's one of the challenges, is that complacency definitely reared its ugly head here. And I say complacency on both sides, both Boeing and the FAA, because Boeing had a history of producing exemplary products and the FAA had a history of approving only exemplary products. So they both were complacent. And then what does complacency do? It makes you miss weak signals. And when you miss weak signals, that's when you can get bit, is when you're not paying attention to the weak signals. So those are some of the issues that we saw in the certification process. Go to the next slide, please. So changing the system from a Boeing 767 to a Boeing 737 is a change in the scenario that requires vigilant re-examination of all of your underlying assumptions to make sure that the assumptions still fit the new scenario. Part of changing that scenario was, as I mentioned, they went from a high speed environment to a low speed environment, which meant in order for the control surfaces to do anything, they had to move more, and that meant you had to give the MCAS more authority than it had before. And again, if you're going to be changing the authority of your system significantly, then you need to reassess all of the underlying assumptions and make sure that they still fit. And if they don't fit, you better change the assumptions accordingly. So that's where the reliance on one sensor came about, because the FAA has standards about how many sensors you need. In some cases, they have 3 sensors for triple redundancy, and the triple redundancy, the protocol on that usually is if one of the 3 systems quits, then if the two remaining systems are reasonably close, they can rely on that. But if 2 of those 3 systems quit and they're only down to 1 system, then the system has to turn itself off completely, as opposed to relying on potentially incorrect information. And so that hierarchy of sensor numbers is something that they didn't follow because they didn't reassess all of the underlying assumptions. So based on what I saw, nobody wants an airplane to crash. So especially a manufacturer, because look at how horrible the results can be, and they didn't have to have these crashes to know that the results of the crash can be horrible. So I don't think, I think if anybody, there was a huge communication issue because of the complexity of the way the delegation process worked. And so, for example, if an engineer a Boeing engineer wanted to communicate to an FAA engineer or vice versa, they typically, because of the complexity of this delegation process, they typically had to have the engineer's comments go up the ladder to the person who's the liaison with the other side, and then back down the ladder. And you know how that process goes in the kindergarten game, where you whisper something in somebody's ear, and then they whisper it in somebody else and whisper it to somebody else. And by about the 3rd or 4th or 5th time, it bears no relationship to how it started. So there was that communication issue. I'm convinced that if the right people, either at Boeing or the FAA, knew that a system this powerful was relying on just one sensor, they would not have ever approved the airplane. And the ultimate paradox that this demonstrates is the more you put in automation to remove the pilot, the more challenging the human factors issues become. So that's kind of a paradox, because you're trying to get rid of the human, but the human factors issues are actually getting more challenging. So go to the next slide, please. So those are design aspects of things that went wrong in the design process, and there certainly were things that went wrong. But now let's look at some of the operational considerations. Namely, what happens once this airplane leaves the factory with the MCAS in it? Then at that point in time, whenever you create a new system, you got to make sure that all the people who are touching the system are aware of the new system and trained to handle the complexities of the new system. And that means not only the pilots who are going to be flying it, but it also means the maintenance people who are going to be maintaining it. They need to be on board with it. And because you heard in both of these crashes, there were some maintenance related issues, but yet they weren't adequately dealt with either. So it's not just the pilots, it's also maintenance. And that's the obligation of the manufacturer to make sure that when you put this thing out in service, you better make sure that everybody who is affected by or touches this equipment knows what to do in case something goes wrong. And then to the extent that doesn't get all of the quote error traps taken care of, then you need to have feedback from everyone who's using the system so that the system behaves in a way that it wasn't supposed to, or that it wasn't, or some other undesirable way. Then you need to get feedback through near miss reports to take that information and return it to the system to inform the redesign of the system, and to form the current training of the existing system. And again, that applies to both pilots and the maintenance people, because if the maintenance people are seeing things that make this particularly unreliable system, that needs to get back into the design and training, and maybe even to the point of saying we should stop using this until we can fix this. So those steps did not happen with respect to the MCAS. In fact, you heard a lot of the pilots say they didn't even know that MCAS was on the airplane. So that means they weren't trained about it, because they didn't even know the airplane had it. So those were defects in the process that actually are extensions of the certification process. Go to the next slide, please. Yes, please.
Chris, quick question before we go to the next slide.
Sure.
What regulatory oversight is there on the maintenance aspect of these planes?
Well, the maintenance the airplane on the whole has to be approved by the FAA, and that approval includes making sure that it's maintainable. Because if it's not adequately maintainable, and you can expect the engine to blow up and because it can't be well maintained, then that's not going to pass that shouldn't pass the certification process. Does that answer your question? Am I getting to your question?
Yeah, I'm just wondering how much attention the maintenance elements gets in relation to the functionality of the bits and pieces on the airplane. I mean, there's a lot of attention on the pilot training. Is there an equivalent degree of focus on maintenance training?
Well, I don't know if I'd call it equivalent because of the fact that the maintenance issues aren't likely to show up as quickly. It may take a while for the maintenance issues to show up, but once there are maintenance issues that are starting to rear their ugly head, then that's when the FAA issues airworthiness bulletins and issues and even to the ultimate extent of recalls in the case of bad enough maintenance issues. But oftentimes their maintenance issues aren't as easy to find in the manufacturing process as the piloting issues are, because when for the piloting issues, that's where you want to put the pilots in the simulator, in the engineering simulator, and you don't just rely on your human factors experts regarding the design of the system. You want to rely on them for starters, but you also want to put pilots of a wide variety of backgrounds in the simulator and have them actually fly it. You don't just ask pilots, what do you think of the system? You have them actually fly it, and you get a broad range of pilots as opposed to your crack chief test pilot. And so those kinds of issues are likely to reveal themselves much earlier in the design process because you put pilots in the simulator and do that. But in terms of maintenance issues, it's going to take longer for those to show. So those can result in service bulletins and airworthiness directives where maintenance issues are a problem.
Cool, thank you.
Chris,
sure.
Can I? Oh, no.
Yes, go ahead.
Oh, I'm sorry. I just a real quick thing. I know that in the development of the 777, Boeing brought in, even in the early stages, people who worked in maintenance shops in the airlines to look over the design, and they looked over prototypes to see if it was going to be difficult or not for them to actually do maintenance. So they did get some feedback early on in the process from maintenance people.
And actually, that's more typical than not. But what I'm saying is that that a lot of maintenance issues aren't discoverable until they've actually been in the real environment for a while. So, but yes, the manufacturers, I mean, when I was visiting an engine manufacturer, I was fascinated by something that they were showing off, how they look at resonance issues. So if the engine vibrations created resonance on a pipe, they showed us a segment of a pipe that was moving, back and forth half an inch in each direction because of resonance issues. So that's when that's an example of something that can be discovered before you actually send it out to fly. But the discoverability of maintenance issues is more challenging than the discoverability of flying issues. But they are on top of those two, and that's where service bulletins and airworthiness directives come in. Thank you for the question. So let me address a few other questions that arose, and that are still with us because we saw these in the look at the 737 Max. And so these three issues: accident trends, how do you treat hindsight, and challenge of profits versus safety. I'm gonna go over those briefly and then take the rest of the questions when I'm done. So next slide, please. So these accidents were very troubling in that they were the latest in a series of accidents where pilots encountered issues that they had never seen before, even in training, and they responded inappropriately. So examples of that, I don't know how much, I'll be glad to talk about these accidents because I don't know how much you guys know about the specific accidents, but Air France 447 was an example where an airplane from Rio to Paris was up at 37,000 feet over the Atlantic on a red-eye flight to Europe. And now they have 3 pitot tubes that are used to measure airspeed, and that's an example where they need that redundancy. So they have 3 pitot tubes, and I don't know exactly how many of them were blocked with ice, but if you block a pitot tube with ice, it can't do what it's supposed to do, which is to tell you how fast the airplane is going through the air. And the way it does that is because it has a hole in front of the pitot tube, and how hard the air enters that hole is what the system uses to determine the speed of the airplane. So if you block that with ice, then the airplane is not moving as far as, the data will show 0 on the velocity because there's no air entering that hole. So all of a sudden, these pilots are flying at 37,000 feet, and all of a sudden the autopilot turns itself off. And they had no clue why, and they had never experienced this before, loss of airspeed information in cruise altitude. And so they didn't know what went wrong, and they didn't know how to handle it. The way to handle it is, and it's probably trained now, it wasn't trained then, but the way to handle it is the airplane was fine the power setting that it was at and at the pitch attitude it was at. So just leave it there, and it'll still be fine until you fly out of the icing situation. But they didn't know that. So one of the pilots yanked the control back all the way and caused the plane to start climbing to the point where it stalled, and then ultimately it never recovered from that stall. So this was an example where this was a situation that these pilots have never seen before, even in training, and they had no clue what went wrong, and they had no clue what to do about it. So I can go over the others in greater detail if you want to, but I'm just giving you the notion that when pilots encounter situations they've never seen before, that can lead to a disaster. Now, at the bottom of the slide, I talk about pilots have sometimes responded appropriately, and that was Sully in the Hudson River. That was the Sioux City, where it's amazing that anybody lived through that. When people tried to fly that in the simulator afterward, most people didn't even get to an airport, let alone halfway land successfully. And then Gimli, Canada, and the Azores were two situations where they ran out of fuel for various reasons and glided to a successful landing. And so sometimes pilots have responded appropriately, but all too often they don't. And that's what I'm concerned about. Go to the next slide. Is that there's going to be more of that, because as aircraft systems, when they were simple and they had a relatively small number of potential failure modes, then they used to train for those failure modes in the simulator, so that if they ever saw them in real life, okay, been there, done that, I know exactly what to do because I've seen this exact failure in the simulator. But now, as the systems become increasingly complex and more interconnected, then there are too many failure modes to train. So that increases the likelihood that the pilots will encounter situations in real flight that they never saw in training. And I think that's going to be the crash of the future. Is more likely we're going to see more of that type of crash in the future, and we're going to see increasing likelihood of pilots encountering unanticipated situations and not responding correctly. So that concerns me from this crash. And Air France 447 goes back almost 10 years now, and so yeah, this has been happening. We've seen this trend developing for a long time, that airplanes are getting more complex, which means it's harder to train the pilots to everything that can go wrong, which means you increase the likelihood that the pilots won't respond appropriately, as they didn't respond appropriately in the MAX crashes. Now, you remember that in one of the MAX crashes, the day before that airplane crashed, they had that same problem, and one of the pilots who was sitting in the jump seat did respond correctly, and they managed to land. But here's where the maintenance issue comes in, because either they didn't report it adequately to maintenance, or maintenance in any case didn't adequately fix the problem, because then it had that problem when it took off the next day. So, but the point is that it is a fixable problem in flight if you know what you're supposed to do. And in one of those situations, the pilot did know what they were supposed to do and did it, but the next day the pilots didn't know what to do. So that's a trend that I'm troubled by, because I combine that with the loss of military trained pilots that we've been used to for airlines for a long time. We had a robust pipeline of military trained pilots from World War II and Korea and Vietnam and you name it. But now that pipeline is diminishing and will never return again. So the two particular skills that I'm thinking of that military is so good on is stick and rudder skills and judgment skills. And so that's what I'm seeing less of with civilian trained pilots. And it's not so much that military pilots are better necessarily than civilian trained pilots, but what it is there are two bell curves, and the bell curves are not coincident. The military trained bell curve is in a better place than the civilian trained bell curve. So we need to think of a way to move that civilian trained bell curve to where the military bell curve is, and I don't see that happening. So this is a problem that these two crashes are the latest example of. Go to the next slide, please. So hindsight is an issue, because in hindsight, of course, it was a dumb thing to do. But the question is not what does it look like in hindsight. The question is what information did the people have who made the decisions at the time that they made the decision? What did they know, or what should they have known that makes it not so obviously a bad decision? Because like I say, hindsight doesn't help you in hindsight to say, boy, that was stupid. But what you need to find out is what did they know at the time, and were they able to make a good decision based on what they knew at the time? So what we should talk about is, again, in the vein of what did they know or what should they have known, how can we make sure that they have the information they need to make an informed decision, and how can we make sure that they are able to use that information that they have to make a good decision based on the information they've got. So the information, look at the single information source, you have to ask, okay, in hindsight, that's an eye roller. That's obviously a dumb thing to do. But given what they knew at the time, and what they knew at the time was that the failure of this system resembled another failure that pilots were well trained for. But they didn't actually here's where they missed that part about bringing pilots in the engineering simulator and have them fly it. That's what they should have done, but they assumed without bringing pilots into the engineering simulator that, yeah, well, pilots are trained to what's called a runaway stabilizer, and so they know how to handle that. And that's all this is going to look like, is a runaway stabilizer, so we don't even need to tell them that's in the airplane. Well, okay, that in hindsight was a horrible decision, but was it a horrible decision given what they knew at the time? So we need to get better at that, because just based on hindsight, we're not going to prevent the next thing from happening. We need to be smarter than just to look at what we know now. We need to look at what they knew then when they were making the decision. Next slide, please. So profits versus safety always troubles me, because when something like this happens, that's the first thing you hear. Oh yeah, the manufacturers abandon safety for profits. Well, that doesn't happen in aviation very much, just because, like I say, nobody, especially a manufacturer, wants their airplane to crash. So what they don't often say is that if you introduce a safety improvement that hurts productivity, that hurts the bottom line, it's probably not sustainable. So you haven't really achieved a positive result if you created something that's not sustainable and that they're going to get rid of because it hurts the bottom line. So what happens is they try to make safety improvements as cost effective as possible, just like everything else they do. They try to do in a cost effective way. Safety is no different than anything else they do. So if they change the wing because they want a bigger wing to hold more fuel, they're going to want to do that in the most cost effective way possible. So that's what they do with safety. So the question is, what was the manufacturer putting profits ahead of safety, or were they simply trying to do it in safety in an efficient way? And the safety that I'm talking about is not having to have their pilots trained in the simulator for the MAX, because they already had certified in the 737 NG, and so they're just trying to seek the most efficient way to improve safety in order to improve the likelihood that it will be sustainable and will stay in the system and help make it safer. Next slide, please. So the process ain't broke, but because it's been working well. But as I said, with any process designed and built and operated by humans, it will never be perfect, and there will always be room for improvement. And the two tragic crashes really showed that, yep, it's time to modernize the certification process, because as airplanes are becoming more complex and more interconnected, the certification process needs to be improved. And I think these two crashes will help with that improvement. And it was, again, a pleasure on my part to play a role in that by being asked to lead the Joint Authorities technical review. And a lot of those recommendations from that review were incorporated into law, and others are being implemented by the FAA. But I'm convinced that the FAA is really taking this very seriously, because they don't ever want an airplane to crash either. So that's my elevator spiel on the 737 Max, and that's why when in the latest Netflix version of a 737 Max investigation, I had only like 3 or 4 seconds of time in there, because I was trying to show how this is not Boeing trying to hide stuff from the government, and as they were trying to say, they were trying to sensationalize it, and I'm not a sensationalist type person, and plus I didn't agree that sensationalism was appropriate in the circumstance. So that's why if you saw me at all, you only saw me for a few seconds, and because this is a much bigger problem than just what did Boeing do, because remember, Boeing can't do it by itself. It takes the FAA in there too. They have to approve it. So it was complacency. It was lots of factors entered into. It was a long history of successful operation of the MCAS on the 767, and so these weak signals that we need to revisit this, and because of their complacency, and of course that's hard to measure, but my view is because of their complacency, they didn't apply the vigilance to these issues that they needed to. So thank you again for inviting me to come and talk to you about it. I'm happy to take any questions you might have, and I know a lot of these points are judgment calls on which there is reasonable room to differ in that part of the process, but I'm happy to play that role, because I'm happy to give my opinion on it based on what I saw. Any questions from anyone?
Chris, if I may.
Thank you, Chris. So it's wonderful. And Cheng, over to you.
Sorry, thank you. Thank you so much. Thank you. Fantastic, great insight, because I think I'm always very, I have a great, huge time for investigative journalism, but also whatever I watch on TV, I always look at it with a good, healthy level of skepticism, and sometimes cynicism as well. So, good idea. But I guess you over your career that you actually took held positions in NTSB and also FAA, so right. You know both sides of the fence. Both institutions have got very important but sometimes very tough jobs to do. I guess when we look back to history, there are examples, maybe historic, but that almost by the time the FAA accepted and took action, that NTSB ended up issuing multiple recommendations based on at least a couple of fatal events. So the way that I look at it is both institutions have to play their role, but they look at the identified risk differently. Their perception of that is different. So I guess my ultimate question is that those are maybe historic examples, but going forward, do you think that the similar kind of reluctance that immediate taking action by FAA would be the case, or FAA would be more willing to accept recommendations and take action sooner?
Well, I'm not sure that there was a reluctance to take action, but what the FAA didn't do, in my view, was politicize the decision. What they were waiting to see, they wanted to see enough evidence to know that the two crashes were for the same cause, because that's a serious thing. If you grounded an airplane after one crash, you'd be grounding airplanes a lot, and they can't do that. So that, to me, for them to wait until they saw that the second crash had some of the trademarks of the first crash, to me that was only the right thing to do. And the countries that didn't wait for that were jumping the gun and could have been wrong. But I even wrote a op-ed piece for, I think, Wall Street Journal about, I think the FAA did the right thing by waiting until they saw whether the crashes had similar aspects to it. So in terms of the NTSB versus the FAA, the NTSB and the FAA have to have different perspectives, because Congress wants the NTSB to not look at safety in a cost-benefit way. They wanted the NTSB to provide the recommendations you would get in an ideal safety world, where safety was your only consideration, but it obviously isn't your only consideration. And that's why when people ask me, should the NTSB recommendation be mandatory? I say, no, I don't think they should, because the simple fact that the NTSB is supposed to look only at safety, whereas the FAA is supposed to look at the total picture, including cost benefit, including how to spend taxpayer money. You notice that nothing the NTSB does can require people to spend money. Whereas, and that's if you look at the political structure of that, that's in part because there's a 5-person commission that is not, the idea is they want to insulate those appointees from political influence by having 5 of them, and by having only 3 can be in the president's party and stuff like that, having them serve a term so that they can't be kicked off for going a way that some powerful political force doesn't like, for example. So that's all intentional, and to me that's important to make it so that the NTSB does its safety only thing. And that's why if people ask me, if I see people doing what the NTSB recommends 100% of the time, I figure something ain't right, because either the NTSB isn't safety only enough, or the people implementing them aren't looking at the totality of the circumstances. Conversely, if there were only 60% of the recommendations followed, then I think that's something broke in the other direction. Sure. 80%-ish is about the percentage of NTSB recommendations that are followed by the industry, and to me that reflects the healthy tension between a safety only group and a group that has to look at everything.
No, thank you very much. I appreciate that. Just for the record, I was referring to the MAX crashes. I was referring to, for example, the AF447 and the previous recommendations, if you like, because inevitably, for example, the icing certification standards were at the top of the agenda. It's at one point the FAA didn't introduce immediately, but I totally accept that sort of they have a different role to play. Thank you.
Well, in that case, the airplane was the Airbus, so the lead in that would be EASA, not the FAA, because it was not a U.S. built airplane. So that's one of the reasons that there is some difference between the regulatory authorities about who's in charge here, and so because the airplane is made in EASA's jurisdiction, then they're the first ones to go after what the Airbus would do. Sure. But I hear what you're saying.
Was it the? I think it was in your most wanted in that list. It was actually sitting in the past at the NTSB's most wanted list, the certification requirements at some point. But thank you. Thank you so much. It's really interesting.
Well, your example raises the point that I mentioned. There are 3 systems for redundancy, but all 3 systems are taken out by the same cause. That's not really redundancy. So none of the regulators around the world has prevented that from happening. They are assuming in their certification standards that the pilots will know what to do in the case of losing that redundancy, because that's not actually in theory being redundant when all 3 of the systems are taken out by the same cause. But thank you for the question.
Hi, Chris. If I may, it's Graham, and apologies for the light here, but it's quite late in the UK, and my dog decided she really needed a walk, so I've been listening to you as I walk, and really inspirational. So thank you so much.
Oh, thank you.
One of my roles is that I run the investigation training program at Cranfield University, and investigators. And I think a lot of what you have said today is really interesting for them as they face some of the emerging technologies that we'll see. And of course, we're going to go beyond conventional airplanes into things that are maybe propelled by, for electric vertical takeoff and motors or hydrogen or whatever. So from the perspectives that you had, is there anything that you would give us as advice to those investigators in terms of how they do their job in that changing world? What are the things that will help them to see the issues at the level where we are best able to influence fixing them in the future?
Well, thank you for that question. And by the way, how long have you been at Cranfield?
So 19 years now.
Really? So I don't know if I had the privilege of meeting Helen Muir when I came to Cranfield, and I really admired her for her evacuation work. So, but the biggest piece of advice that I have is something that all investigators have to be trained on, which is take the hindsight out of it in order to answer the real question, which is what did they know or what should they have known at the time they made these decisions? And that's crucial, because if you just look at through hindsight, you're never going to improve anything. You need to look back at whether this tells you that your information flow is inappropriate or the training to use that information is inappropriate. But just to go with hindsight is a huge mistake. So that's not always easy to do, because hindsight is just there. I mean, so trying to ignore it is not easy.
Fantastic, thank you. And look, if you find yourself in London at any point, then please come and visit and see what we're up to. You'd be an extremely welcome guest.
By all means, one of my favorite cities.
Thank you.
Thank you.
Thank you. Well, John Vincent.
Hi, Chris.
How you doing?
Very well, thanks. Very well.
Very good. Thank you for sending me your slides in advance.
No problem. I don't think we trod on each other's toes very much. One of the issues that comes to my mind, like the presentation, by the way, retaining corporate knowledge, because it occurred to me that, the NG, they had knowledge and expertise, and maybe some of that knowledge and expertise was lost, both in the FAA and in Boeing. Did you find that in your investigations, that it was that retention of expertise, retention of knowledge Is that a significant issue? And if it is a significant issue, how do you deal with it? How do you keep, how do you retain that necessary knowledge in the certification field and in the investigation field?
Well, it wasn't so much retention that I was concerned about. It was in the case of the FAA, they didn't have enough people to really do what they needed to do in order to properly oversee that delegation process. Because Boeing is such a big company and they put out so much that it really would take a lot more people on our behalf to adequately oversee all that they do. So it wasn't so much retention as much as it was having it in the first place, kind of thing. I'm not aware of, was there, why are you saying that, was there a mass exodus from either one of them shortly before that, or what are you referring to?
It's just with a distance of, from the 1990s to 2020, there's a lot of time. People retire, the knowledge is lost.
Yeah.
Corporate organizations are not necessarily good at retaining the expertise and knowledge that they need to sometimes. And I wondered if that was a factor.
Yeah, what we saw was more not having adequate numbers of people in the right place. And I mentioned it from the FAA, but we also saw it to some extent from Boeing side. But but in order for that process to work, we need to have roughly equivalent knowledge on both sides of the fence, if you see what I'm saying. Because if the knowledge is grossly different, then that's gonna create challenges, and that's one of the issues that government agencies always have, because whenever they're leading newly forming technologies, the technology leaders are almost certainly not at the government, because they're at an industry where they get paid more, and that's one of the reasons the delegation process is being biased by how.
Yeah. Is there any danger of regulatory capture, as the phrase is often used, isn't it? In terms of, say, ex-Boeing people working for the FAA, did they keep the lines reasonably, separate in terms of responsibilities?
It's not regulatory capture as such that I'm concerned about. I think I think the people are vigilant about that. But what I am concerned about is that there's more knowledge on the manufacturer side than there is on the government side, because they have the frontier forging leading experts in the new technologies, and that's what I'm concerned about. Is how are we and how's the FAA going to keep up with the
I think it's the same in every authority. So it's a universal problem.
Exactly. So that's my concern, is that it gets worse when the innovation gets more rapid. That gets worse because the disparity in knowledge between the regulator and the regulated increases.
Yeah, I agree. Yep. Okay.
I can see Carolyn you have your hand raised. Carolyn, would you like to come in?
Hi, thank you so much. That's really interesting, and I almost want to go through and watch it again. There was so many components I found.
Well, thank you.
Yeah, found fascinating. There's two comments. One, really to build on what's been raised, but that concept that you're talking about the regulator and those out in the field having different levels of knowledge that is like, so whether you're in the marine industry, that is a really true thing as well. And I've lived with a pilot, and he would tell me about how they don't get checkout flights, and when he does, the person checking him out is a waitress that got a job in the government, and he's like up in arms. So I think that's huge. But in relation to that, your comment about emerging technology, new equipment, new ways of doing things. Your point about the interface with design and human factors, and when I'm thinking about a bridge, but it's true when you're in a cockpit. Things change. You don't know if they work until you're operational. You just don't know until you're doing your trials, especially with things that do with engines and things like that. And then you add what the gap in the different kinds of people that are entering. They don't have, as you talked about, like the pipe from the historical folks who'd been in the forces, and all the mentoring that would have gone on even if they hadn't had that. But I was taught from Fred, who flew over England. That's not happening. The marine industry is the same. How do we address that? You know, we have folks who just don't. How do you get 20 years experience? You got to have 20 years experience, and preferably with somebody who had 40 years experience. So how do we address that? Like what do we do about those? Are really two complex issues that are happening at the same time that I personally think, and I work, you know, my experience in the marine industry and working with lots of folks in this industry, though, that's what keeps us up at night, right? That combination of younger people without that experience, that adaptability, the ability to go fast and to apply, and then you add new technology, and it just feels like a disaster. It feels like we're going back to the 80s before all the safety management systems were in place. I feel like we're in a bit of a paradigm shift right now. Anyways, thank you.
Sure. Well, these are definitely challenges in terms of both areas you mentioned in terms of the pilot expertise. I think we need to figure out a way, because that's very expensive. The training that pilots get in the military, if you got that commercially, that would be very expensive. So somebody's going to have to pay for that if we want that level of talent in the front of the airplane again. And so that's just going to be I don't think anybody's come up with a good answer for that yet. That's going to be a challenge in the future that we're going to have to figure out how to address. And the same thing about the level of expertise in the government versus the level in the manufacturer. That's a cost issue big time too. But even what we don't know is even if you got the salary in the government that you got working in manufacturer for your level of expertise, would you still want it? We don't even know the answer to that because we aren't even that far yet. So yeah, these are challenges that we're going to have to face, and I don't have any good answers at this point because I know it's going to cost, you know, dollar signs come to mind, and I know it's going to cost a lot of dollars to do what we're talking about. But if we want it done right, we're going to have to pay for it. And actually, in the long run, as with so many things like in this system that we're seeing, in the long run, even if we have to pay more to train people better, that's going to end up costing the system, not necessarily the FAA or a manufacturer, but it's going to cost the system less to have that, you know, in other words, ounce of prevention, pound of cure thing. So I wish I had the answers to your questions, because if I did, I'd be out there implementing them.
Yeah, thank you. But I do think that, you know, as someone, I've looked at a lot of sort of the history of major events that create regulatory changes that, you know, and how that flies, and like safety management system, in which, you know, out of the IMO, really, right, the 80s, big events. And I just feel like I'm watching all these things happen, and it feels like exactly I can go back to like 1984, and I feel like it's all kind of happening again. And much what you said, your fear, where your concerns are about where you think the incidences are going to take place, they're the same kind of dynamics that took place in the 80s, and I just feel like we're headed towards some big events.
Right? Well, we're already seeing it. I'd be willing to bet that if the pilots in Air France 447 had been military trained pilots, they would have had the stick and rudder skills to know, oops, I've lost my airspeed information, but all I do is maintain pitch and power and I'm good to go. But they didn't do that. In fact, they were totally over their heads because they were at night in the clouds and a lot of water out there, and that's what froze the pitot tube, turbulence. So the time and by the way, let me add to this to the footnote, they had never flown that airplane manually at cruise altitude before, even in the simulator. So this is not the first time to be flying this airplane manually when you're in turbulence, in clouds at night, and 300 people behind you. So, you know, that was just a perfect storm of things going wrong, that even something as simple as flying manually, because in the very thin air, they fly manually much differently than they do for takeoff and landing when they are typically flying them manually, but they had never flown it manually at cruise altitude before. So, and plus they'd never had training for recovery from unusual attitudes or for stall recognition and recovery. They'd never had that training for that at altitude either. So, yeah, I'm sure all those things are happening now, but they didn't happen then. And if those pilots, I'm convinced that if they had been military pilots with the stick and rudder skills, they would have, because other pilots, the reason we knew about that problem was because other pilots had gone through exactly this same problem. And that's when the industry had concluded, oh, well, I guess the heater on the pitot tubes isn't robust enough, so let's replace all the heaters on the pitot tubes. And this airplane was scheduled to get that replacement in the next few weeks, but it wasn't considered an emergency because previous pilots had gotten out of it okay, even though they lost all their airspeed information. They did pitch and power and came through. So yes, it needs to be changed. No, it's not an emergency. So this change was going to happen in a few weeks to this airplane. But meanwhile, this perfect storm of things went wrong that make exactly your point.
Yeah, it doesn't make me happy. That's all I can tell you. Like I think I think somebody could, and I'm sure there's somebody in this group could do a really nice analysis about these major technological advances that are taking place across a variety of high risk or critical safety organizations, and they're all kind of headed to the same kind of thing. Anyways, thank you very, very much.
Well, thank you for the question. Sorry, I didn't have a good answer for you.
Thank you. I mean, I've got a question. I'll be really interested around the JATR, your work and the recommendations that were put out as part of that. And what's your sense? I mean, something that we sort of started with was just an acknowledgement of just a huge number of inquiries and reviews that have been held, obviously, into FAA certification, but Boeing itself. And I mean, what's your sense? I know that a couple of the recommendations from the JATR strongly echoed things like the FAA Special Committee, around human factors analysis and SMS implementation and these sorts of issues. I guess I'd be interested in what's been the process to follow up the JATR recommendations, and second, do you see it as a sort of productive process, that there are all these different reviews with all these different recommendations, some of which are reinforce one another, others are slightly I guess out on a limb compared to the different reviews? I guess is there almost too much complexity in the number of reviews and inquiries that are going on? Does that add complication to how FAA and Boeing have to respond?
Well, certainly that's a good question. Certainly they're going to have to sort through the vast variety of recommendations that came from a lot of different sources. Some of our recommendations from the JATR ended up in law, so those are going to be implemented. The FAA is going after several of the others. I can't give you a detailed point-by-point breakdown of what's happening in each recommendation, but I can tell you that the FAA is taking this serious. I mean, you remember this whole process was very public. They didn't try to hide any of it. And so if they're going to go out in public and say we are going to get basically an international peer review of how our system works, and you do that in public and you show the results in public, then that means you better be serious about it. Because if you do all of that and then just let the report sit on the shelf and gather dust, you lost all credibility, and Lord knows they had enough of a credibility problem as it was, which is why I think it was good of them to start this process in the first place. So I am confident that the FAA is taking this serious, and either because they're in law or because they just think they're good ideas, and so I am confident they are taking these recommendations seriously, but I don't have a point-by-point breakdown for you.
No, of course. No, thank you. No, that's great. Yeah, and it does, as you say, it's almost a process of rebuilding regulatory trust as much as
around the world. Yeah, right.
Yeah, right. No, thank you. That's been fantastic. I can see there's a comment in the chat box as well from Rune. Did you want to come in on the around sort of regulatory capacity, I guess?
Yeah. So I'm just wondering, Chris, if you have any thoughts, given the fact that there's likely always going to be a resource disparity between the regulator and the manufacturer of these various products.
Right.
Are there different approaches or different things that we can have these regulators focus on so we kind of maximize the efficiency of their safety input to the process, knowing that they're not going to have all the resources that the manufacturers are. They're not going to have the time, the people, the access. Is there something else we can add to the mix, I guess is my question.
Well, one thing that comes to mind, that's a good question. One thing that comes to mind is programs of sharing people back and forth, having regulators go to the manufacturers and work for 6 months and vice versa, having that mutual exchange of information flow. I think that's an idea that occurs to me that might help resolve some of the disparity, but ultimately we're going to have to rely on the intelligence of the government people to recognize when they need to do something different, because what they're hearing from the manufacturer is over their head in terms of these people being more advanced in the technology than they are. So ultimately, I don't have a good answer for that one. And as I said, I'm not even sure that having equivalent salaries would solve that problem, but it's going to be a problem that we'll need to fix. And we're also running into it, by the way, with autonomous cars, because I've done a lot of conference speeches on autonomous cars where they're making a lot of mistakes in their automation efforts because they have ignored decades of automation development in aviation, and so now they're making the same mistakes over again. So there are a lot of ways that people can try to look at what's happening elsewhere to improve their state back home, but yeah, exactly how that's going to be done, given the resource disparity, that's a very good question, and I'm afraid I don't have a complete answer to that.
Yeah, one of the things we talked about earlier was perhaps this would be an area for artificial intelligence to kind of go through, and if we have known lessons to be learned, is there the possibility for AI type techniques to help out the people and kind of reviewing volumes and volumes of information to make sure we're not breaking our own rules?
I think that kind of idea is certainly worth looking at. I don't consider myself enough of an expertise in workflow to be able to give you a more specific answer, but that sounds like an idea worth looking at.
Great, that's it for me.
Thank you for the question.
That's great. Thank you very much. I can see there's a bit of back and forth in the chat box. Graham just noting the disruptive innovators in aviation, perhaps the echoing some of the challenges in AVs. I don't know, Graham, if you want to comment on that.
I really resonated with your point there about what's going on with some of the automotive manufacturers, and I guess from the outside in, looking at some of the exciting disruptors like Tesla and so on, fiercely protecting their IP and therefore clashing with NTSB and the like, in a way that's different to the major players in aviation who absolutely accept that part of our safety culture as a whole sector is based upon the fact that the lessons learned will be shared across the industry. And so I see that with EVs, and I see that also with some of the small UAS operators and that whole group of disruptors where you have early conversations and go, this is great, what do the FAA say, what does the ASA say, and they look at you as if to say, who is the FAA? And you think, like, no, that's a real worry,
Yeah, I agree.
Brilliant. Well, I'm just looking through the chat. There's no more hands up, and I think we've covered the comments in the chat box. Well, that was absolutely fantastic. Really fascinating, Chris. Really appreciate you taking the time out and joining the conversation, and it's added a lot of richness to the discussion. So thank you very much. And
well, thank you for your flexibility in bringing me in at the last minute. I appreciate that.
Thank you. No, our pleasure. That's wonderful. And
please say hi to
Carlene Roberts. Yeah, she was unable to make it today.
Yeah.
Well, I'm sorry to hear that. I hope she's okay health-wise.
She's hanging in there. She's a tough cookie, but every day is a different struggle.
Right, I hear you. Well, please tell her I said hello.
Will do. Thanks again for.
Arlene, I was just dealing with Kathleen White, so I'm thinking Kathleen Sutcliffe. I mean, so I'm thinking in a Kathleen term, but it's Carlene Roberts that I'm talking about.
Great. Well, thanks so much, Carl. Do you want to queue up our last speaker for the day?
Yeah, sure. Thank you. Well, no, I'm delighted. No, last but certainly not least, delighted that we've got Paul Schulman presenting for us, and we're this is a consideration around actually links to perhaps some of the issues we've just been picking up around the capacity in public administration, the sorts of challenges that can be faced in that field. And I know, in fact, Paul you've published a very nice paper on this recently as well. So I'm delighted to see you, and thank you very much for joining us, and look forward to your presentation. Do you want to present, or do we have? I'm not sure if Rune has your slides, Rune. Oh, and you're on mute, Paul. Sorry. Or your microphone's muted, Paul. I don't know if you can hear me. Okay.
There we go.
There
Is
we
it
go.
possible for me to share my screen slides, or I know that it uploaded.
Yep, go ahead, Paul. Do you see the share option?
I see open share tray. Is that the share option?
Yep, and then you want to pick the screen or window or whatever you want to share.
Okay, let me just put this on. Oops.
We'll see if you execute the appropriate or inappropriate action to get the screen sharing
activated. Be the inappropriate one, but let's just. All right, now here we go. Can you see anything? Can you see it?
Perfect. Yeah.
Oh, okay. Okay, great. Okay, well, this is going to be a presentation at a much higher level, a more general level than Chris's. I mean, he has so much knowledge of the particulars, I feel kind of ridiculous trying to talk about the same event from this 100,000 level, basically. But nonetheless, I think it's interesting. We've been working, some colleagues and I, on this question of organizational capacity for public organizations. And I thought it might be an interesting exercise for me to try and apply this to the MAX problem. First question to be raised, what is public organizational capacity? How's it lost? Building capacity is a common theme surrounding public organizations. They're always trying to build capacity, new organizations, for example, new missions, new authority, increases in budget and personnel are quite visible. And it's assumed that these enhance their capacities to achieve their goals and their responsibilities. But the loss of capacity of an existing public organization is less obvious. Sometimes it only manifests itself after a prominent accident or failure of the organization, or it's publicly revealed just when it is most needed in a crisis, and you find out, well, see, you don't have that capacity, it's not working well. What is a capacity? We tend to think of an organization's capacity as discrete inputs it can bring to its operations: money, people, skills, building, vehicles, other equipment. Loss of any of these may affect the ability of the organization to produce desired outputs. But this approach neglects the dynamic interaction of these discrete elements that enables larger and more general capacities to come into play. In effect, these more general capacities are ensembles of specific capabilities. Yet these more general capacities are often fundamental to the achievement of an organization's goals and mission, more even than the specific capacities. What are fundamental capacities? Well, there's four that we've been looking at, and these come really from Eric Hollnagel. Four general ensemble capacities: response, anticipation, monitoring, and learning organizations. While each of these are themselves ensembles, they may also be essential to the successful activation of other capabilities. Their loss may have non-linear multiplier effects on other organizational capacities. And the erosion of these capacities, I think, can be looked at as possibly important to some of the understanding of the role of the Federal Aviation Administration in the fatal crashes of the Boeing 7. That should not be 777. That's the Boeing 737 Max. Monitoring capacity first. It's the capacity, it's an ability of an organization to systematically and reliably collect information. But what information is depends on the frame of reference that determines relevance and importance to an agency's goals and mission. You can have a wide frame for Homeland Security, a narrow one for managing a single part. This frame of reference allows an organization to differentiate what constitutes a signal from a background of noise that can divert attention and clog channels for the transmission of information. For some agencies, such as those conducting military or disaster relief operations, effective real-time monitoring capacity is essential for the correction and adjustment processes necessary for effectiveness in these disaster relief operations, especially the timely effectiveness. A correlated capacity to monitoring is the analytic capacity of an organization to detect patterns of information inputs and support of the next capacity, which is anticipation. To act effectively, agencies must be able to anticipate future events, demands, and needs. The example is the IRS, for example, when officials of the IRS in this country are trying to write new tax provisions in response to new or altered tax laws, they have to anticipate that an army of tax lawyers will be looking for loopholes, ambiguities, and contradictions to exploit. So the IRS must be very good, anticipating as many counter strategies as they can, and to try to head them off in their drafting of new tax documents and funding and filing protocols. This issue of having to anticipate counter strategies is becoming a really important factor for many organizations in an era of cyber terrorism, hacking, and other counter strategies that are being devised against organizations. Anticipation capacities are characterized by their time frame, short or long term. The Office of Management and Budget in the U.S. and Council of Economic Advisors have to anticipate employment rates and economic growth very next fiscal year ahead in order to guide budget formulation processes. The Social Security Administration, on the other hand, has to make long-term generational demographic projections concerning retirees, working age populations, in order to determine and ultimately try to protect the future solvency of the Social Security Fund. Successful anticipation requires an agency of resources, time, and modeling capacity to develop both short and longer term anticipatory views, but this capacity for double anticipatory perspective may be perishable because long-term anticipation can easily be undermined by preoccupation with immediate or short-term demands, or the preoccupation can run in the other direction. Then response capacity. Response capacity is the ability of an agency to utilize its resources for action. Response capacity is founded on an upstream capacity of an organization to monitor relevant information, anticipatory information, and model this information and recognize its importance. And then the ability of it to mobilize decision processes to commit to action. The capacity to act may well be distributed to other public organizations, law enforcement, courts, emergency response organizations, as well as a variety of state and local organizations. So it can well be a distributed and sometimes diluted capacity from the standpoint of a single organization. An important aspect of response capacity is its speed relative to the dynamics of the problem or objective addressed. The problem has a very rapid growth rate, and speed in response can be really important. An agency's actual capacity to respond rapidly to a future problem is likely to depend on a complex set of situational factors, often easier to judge in hindsight than in advance. Getting the theme here that the loss of capacity is sometimes much more sharply understood in hindsight than it is in advance. We can't very well anticipate or look forward to the loss of capacity as well. Unfortunately, very often we are continuously rediscovering our lack of response capacity after the fact. And learning. Learning often requires the ability to harness information about and draw inferences from past actions and their effects. In this sense, learning capacities are often reflective, foundation of trial and error learning. But the true test of a learning capacity is the ability to improve performance in the future. Some organizations, trial and error learning is prohibited because the consequences of the error may be politically or socially unbearable. For these organizations, they can't learn by trial and error learning very effectively because the first error may well be the last trial. Here, simulation and forecasting may be predominant methods of learning. Learning is often considered a foundation for organizational adaptation and resilience. But learning is not necessarily an automatic or natural function for an entire organization. A variety of personnel at different levels must be capable of pulling together a number of tasks, monitor operations, diagnose problems, judge success or failure, adapt organizational routines, all in a timely way. The failure or blockage in any step in this loop can jeopardize a process of organizational learning. It may not do the organization much good when a few people have learned something, but they can't communicate or effectuate it in subsequent organizational behaviors. So with these four capacities, how can we apply them to the 737 MAX X8 case? The description of the four public organizational capacities I just went through could apply, of course, to private organizations as well. But for public agencies, the erosion or loss of these capacities can have widely ramifying consequences. While these capacities are fundamental ones for public agency performance, the erosion or loss is not necessarily widely signaled in advance of failure or accidents. The Boeing 737 Max 8 case appears to be a stunning example. What are the processes of erosion that have taken place possibly in the FAA? By the early 1990s, this is a story well known and told. The FAA and Boeing were widely seen as the gold standard of international aviation regulation and aircraft design and manufacturing. With mature systems of reliability and safety management, it took many decades to develop. Unfortunately, by 2019, post-accident investigations of two 737 MAX 8 crashes found that the FAA's capacity to oversee aircraft safety had met its limits in this case. Certifying aircraft safety is clearly an enormous, requiring the FAA to spread its limited resources to oversee an increasingly complex technology for now global manufacturing supply chain. This is a conclusion of the Inspector General of the Department of Transportation. To meet the detailed technical demands of aircraft certification, the FAA had delegated certain regulatory functions to manufacturers since at least 1956. However, Congress expanded delegation in 2003 in order to speed up the certification process. And in response, the FAA introduced its Organization Designation Authorization Program, the ODA, in 2005. As the FAA itself admitted, the FAA at the time of this ODA program, the FAA doesn't have the resources to do all the certification activities necessary to keep up with an expanding aviation industry. Using designees for routine certification tasks allows the FAA to focus its limited resources on safety critical certification issues as well as novel technologies. Given what we have heard from Chris, for example, and we might say that was a sensible thing to do in 2005, and it may have been a way for the FAA even to try to keep up with some of the changes in technology by having people designated there as FAA certifiers, but at the same time working on-site Boeing. Investigations indicate that insufficient capacity was dedicated to oversee the MCAS. Part of the problem arose because Boeing portrayed MCAS as a modification of an existing system, leading to insufficient FAA scrutiny of the self-certification process. FAA certification staff must have the necessary skills and training to effectively oversee manufacturers. This congressional research said that. That's what Chris and others have been saying now. There can't be an imbalance, a dramatic imbalance between the expertise of the regulatee and that of the would-be regulator. Unfortunately, the JATR, Chris's group, found that the FAA was understaffed with experienced engineers, and the U.S. Office of the Special Counsel found that FAA state inspectors lacked sufficient training. It was also, the JATR also found that the FAA certification process suffered from both fragmented information, and the House Committee on Transportation and Infrastructure pointed to poor, disjointed FAA communication. As a result, the FAA has a poor understanding of MCAS and lacked the capacity to assess the airplane's training requirements. The FAA begins to be a monitoring and potentially anticipation capacity lapse. The FAA's 737 MAX failure suggests that the FAA's overall capacity to ensure aircraft safety was limited by a complex interaction of multiple factors, enormous complexity of the related technology, and requisite skill levels evaluated, need to allocate FAA personnel across manifold regulatory responsibilities, the delegation of certification tasks which may have enhanced some capacities while constraining others, and an administrative system that not fully ensure coordination and communication of information and tasks. Well, let's think about the unraveling of ensemble capacities. You can interpret some aspects of the MAX 8 case through this lens of capacity loss, although I'm not going to claim it's doing a great job here, but nonetheless, first came loss of monitoring capability. The delegation of inspection certification responsibilities to designated organizations, the ODAs, gave the FAA little direct access to information on the plane's development process. The communication process between delegated officials and the agency degraded, so the FAA had disjointed information, lost the ability to assess the novelties involved fully in the MCAS application to the 737 and the implication they had for enhanced pilot training requirements. These monitoring lapses also contributed to the decay of the FAA's anticipation capacity. A combination of communication lapses and the assignment of insufficiently trained inspectors also contributed to the inability of the FAA to anticipate the safety issues raised by MCAS. The FAA obviously failed to anticipate that the ODA strategy would ultimately rob it of the information and direct contact needed to maintain its own expertise, and thus degrade its own ability to exercise the quality of oversight necessary to support its certification responsibilities. The erosion of the monitoring and anticipation capacities led ultimately to the erosion of the FAA's response capacities. And this is speculative. The FAA's lack of understanding of the new MCAS design features, in a sense, paralyzed its decision-making process and possibly led, I'm putting all these qualifiers in, to its delay in grounding the 737 MAX after the first crash of Lion Air Flight 610, even after many European air regulators had done so. The FAA claimed that it had to digest more information to establish a causal link between the crash and the MCAS system. But if it had had greater understanding of the system and its modification in the plane it had certified, is it possible that the FAA could have put together a plausible link much sooner? This other one is pure speculative, and I don't even want to mention it now. Lastly, the question of learning capacity arises. Prior to the 737 MAX 8 certification, there had been some internal reporting by the Inspector General of the Department of Transportation, Home Department for FAA, of lapses in oversight at the FAA. Also, Inspector General viewed complaints by FAA Transport Airplane Directorate engineers and inspection personnel and concluded that our investigation, this was before the MAX, substantiated employee allegations that the TAD and FAA headquarters managers have not always supported TAD employee efforts to hold Boeing accountable, and this has created a negative atmosphere within the TAD. They reported this to the FAA in 2012. Apparently, this did not prompt any learning or for even further investigation from higher managers at the FAA. The learning that did take place actually occurred outside the FAA in media and Congress post MAX 8 crashes. In December 2020, the Congress passed legislation to strengthen the FAA certification process. Another learning failure was the FAA failed to pick up on an outgoing collapse in Boeing's safety culture, beginning with its merger with McDonnell Douglas. This has been chronicled in a book about this that appeared earlier than the MAX period. This led to a shift in company priorities away from safety to a preoccupation with the new company's share value and the market share being claimed by its aircraft. This is in Peter Robeson's Flying Blind, 737 Tragedy Fall of Boeing. The upgrades of MAX were seen as a key to increasing market share against rival airlines. The 737 upgrades, including MCAS, were specifically designed to avoid falling under the FAA new product rule, which would have required brand new certifications of any substantially changed aircraft and also new pilot safety training. Boeing executives specifically wanted to avoid any new training requirements because they thought it would discourage sales of the 737. The FAA, had its monitoring processes been intact, should have seen this transformation at Boeing, the loss of its safety culture, and become alerted to the likelihood that they were now dealing with a very different and hostile company that would try to weaken FAA oversight processes with respect to them. I'm sure Chris would have a different view of this. What can we learn from a capacity view of this case? Major foundational regulatory capacities can degrade when an agency stands still and the world changes around it, as is in increasing technical complexity of aircraft and the globalization of supply chains in the manufacture. External political forces play a role in capacity law, as congressional pressure on the FAA to speed up its airline certification process did. Capacity to regulate to degrade when an organization it regulates undergoes a major collapse in their own safety culture and tries to manipulate their regulator and undermine its regulatory capacities. Capacity can degrade due to internal changes which shift priorities or overload attention in an agency. The question of how to restore lost capacities in a public organization then becomes its own major learning challenge. Anyway, I'd love to have your critiques, because this is obviously a rather speculative effort at application.
Thank you, Paul. That was really interesting. I think the
and here. Oh, go ahead.
Or I think maybe there's echo on your mic. If you might be able to mute while we're talking. That's there. Is that better? Hopefully. And then we can come off mute when we're talking. It seems to be a problem sometimes. Yeah, thank you. That's great. I can see there's already some discussion in the chat around the sorts of capacities and skills that regulators might need. I don't know, John or Graham, if you're interested in coming in and elaborating on those comments, that would be interesting. But likewise, I'm just looking for any hands up.
Thank you, Paul, for a fascinating presentation. I think you admitted yourself some of it is speculative. Is that correct? So it isn't necessarily definitive, but it's an opinion, and provocative too, which is always good, I think. I know she mentioned the change product rule, and I have wondered actually whether having such a rule in fact creates as many problems as it solves. Because the barriers to change forced Boeing perhaps down a particular pathway, whereas if the regulatory framework had been a bit more flexible in terms of the change product rule, then they wouldn't have necessarily been forced down that pathway. So there's a difficult balance of regulation there in terms of, I know I'm going off a little abstract because I noticed the mention of the change product rule. But sometimes regulation can have an unintended consequence. And I think this might be, in some areas, an example of that unintended consequence. I don't know if you agree with me.
No, I think that's a very interesting point. And one of the things that in my research I've sort of come up with is you have to understand there's a big difference between regulating for reliability and reliable regulation. And reliable regulation have the same kind of questioning and skepticism about unanticipated effects that you would see in other domains. So yeah, I think you're right.
So all the things that were said earlier about crisis management also ought to be applied to, personnel management in terms of, in terms of trying to anticipate, the future problems or future gaps that you may have in expertise that will leave you exposed to higher risk. I think that's almost evidently. So it's very, very difficult to make those forward projections, though, because the technology curve is moving faster and faster and faster. So even if you're running to catch up, a regulator is always behind the industry. And that gap used to be manageable. But I think now the gap is getting bigger and the regulator is not running fast enough to keep up with the speed of the industry.
Right. Let me run something by you, because I raised this earlier on when we had the collapse of the financial sector in so many countries. And people pointed out the development of new financial instruments was the most dynamic area, one of them, in the entire economy. People were advocating all kinds of new financial instruments. And the Federal Reserve was having trouble and figuring out what's going on. And I just wondered about the possibility of a regulator actually saying, if we don't understand it, you can't do it. What would happen if they tried that? Would the regulatee say,
oh, it happened. I assure you, it happened in my career.
To be able to do what we want to do. I mean, I don't know, would that actually stop this process? Which seems to be when everybody says, oh, things are changing so rapidly, they just assume there's no control over it. But I'm just wondering if a regulatory role might be to slow down the process when they see that it is creating this imbalance in knowledge and undermining regulation.
If you look at the kind of rhetoric that's coming from regulators at the moment, it's about being an enabler, about, particularly, as Graham mentioned, the eVTOL and the new urban mobility, the regulator sees themselves as an enabler of the new technology, which assumes, of course, they have the competence to be so. But that's how they are speaking. And they are speaking like that because their audience almost requires them to do so, because you cannot being a barrier to change is not what a regulator should be. But I agree with you. Sometimes the necessity to say no is there, and that the tool to say no should be used, but sparingly.
And I think you have to look more broadly at the fact that you see this in technologies, the organizations developing a new technology are using market calculations, which are about rationalizing and maximizing their own individual profits. They're not using social norms, and they're not necessarily in a position to do an objective appraisal of the likely impacts and negative effects of a new technology. The regulator is the only barrier between that innovation and the need to think more broadly.
I think they're not going to do that. I agree with you. Regulators need to rediscover their role as a public defender, a public protector, and I think that in some cases that ethos has been lost, because again, if you become too much of an enabler, you forget the role that you play on behalf of the traveling public. Just a thought.
I think it's important to think about it.
Yeah. Anybody else have any similar thoughts? Or anyway, thanking you very much.
No, thanks, John. It is, as you say, it's sort of very, very provocative and sort of thought-provoking. I guess something that that strikes me is well, a couple of things. One is I'm quite strongly attracted to the idea of a regulator as being almost a function that requires explanation and understanding, and perhaps I guess there's something interesting around to what extent regulatory processes generate capacity within providers or manufacturers, or those who are regulated to be able to understand and explain themselves. They're required to literally be able to account for what they're doing, and it's when that requires a regulator which is intelligent enough and has enough capacity itself to be able to not just ask the difficult questions, but then to understand what the answers mean and to ask further questions. And it is, I think, as you're describing that, it's that I wish I'd read your paper, or perhaps it'd been published. I think I have a paper that came out around the same time where I talk about epistemic capacity as one. I guess we're perhaps talking around a similar sort of idea. But this idea of but being able to the capacity to be able to understand and comprehend a system as one of the sort of key underpinning features of a regulatory process. So I don't know if does that resonate with your thinking, Paul, or
yeah, absolutely, yeah, absolutely, right. I mean, in high reliability organizations, particularly like nuclear power plants, if they find themselves in, quote, unstudied conditions, they shut down the plant. They're not allowed. It's a federal violation to run a nuclear power plant outside of analysis. Well, maybe it should be a violation to approve something outside of your ability to actually analyze, which would put the onus on the person who wants to do it to educate the regulators.
Yeah, it's interesting. I mean, linking back to John, your challenge around regulators as almost champions of the industry and in some sense, or facilitators, I suppose, of innovation. Something that I studied and I'm currently writing up at the moment is this new approach of regulatory sandboxing. This idea of you get manufacturers and innovators and service providers together with regulators in a safe space to actually explore during the development process how a new technology or new innovation can be understood and the regulatory implications of it and the sort of risks that it might pose. But you do that in a fairly constrained safe space, and it's something that it's often pitched politically as the regulator facilitating innovation, but actually certainly the work that I did, I worked with actually the Care Quality Commission looking at one of their regulatory sandboxes, but actually the work that goes on in the sandbox is as much about the regulator educating providers who perhaps have never actually encountered a regulator before because they're a small startup, and likewise the startup educating the regulator in this newfangled technology, which they're still in experimental stage. So I wonder if there are almost these sort of hidden spaces where you can develop capacity, but it almost provides a space to be legitimate to those two narratives around regulation as a supporting innovation and regulation as controlling and restraining innovation in that sense. I don't know, perhaps I'm on a slight flight of fancy there. It's getting very late in the UK. I don't know if any of that makes sense, but
well, in the US, unfortunately, particularly at the state level, we have a lot of adversarial regulation, and so it's very difficult. Chris Hart has a wonderful presentation on the collaboration necessary that occurred between the FAA and the airline industry in actually improving what already was a really good safety record, and the importance of that collaboration and bringing together regulators and the airline and others in that process.
Yeah. There's something quite important around that sort of the space that's created to allow those different actors to come together, and which was, as you say, which Chris's experience really illustrated nicely. And I'm just Cengiz, I see you had your hand up. Are you keen to come in on this?
I just wanted to share a couple of thoughts about this whole idea of the discussion about the role of the regulator, whether it's an enabler, facilitator, and of course in a modern society and economy, yes, that's the ideal role. But I think personal view that I think these things are cyclic pattern, because we go in that direction, a bit of deregulation and light touch oversight and those kind of things, and then up to the point that big hit, high profile accident happens, and then a complete swing to the other side of the spectrum and say, okay, and I think Max inevitably introduced regulations where in fact there's hardly any appetite on either side of the Atlantic, that when people talk about sort of regulation, like, are there any other options that we can do before we actually regulate? So but as soon as the big events happen, I think we almost kind of swing to the other end. So of course in the future things may change, but I think there's still also challenges around this paradigm shift from prescriptive regulation, compliance-based oversight towards performance-based regulation and risk-based oversight. It is happening in certain countries, but certainly not all across the world. And I think even those countries made implementations and advanced practices. And I think at times when events do happen, they sit back and question and reflect on their own role. Should there have been a bit more effective oversight? But those are just personal thoughts or observations, really.
There have been efforts to shift to performance-based regulation in this country, partly as an antidote to the adversarial nature of prescriptive regulation in many agencies.
I was just maybe specifically talking about aviation and maybe only a few countries' perspective, really. Thank you.
Thank you.
Thank you.
Thanks. Great. Well, I'm just looking to see if we don't have any more hands up or comments in the chat. I think we have a few, but we've covered those off perhaps.
Well,
John, yeah.
Sorry to keep talking, but I was going to ask Paul, all this costs money. Where should the money come from? And is the public willing to pay?
Well, that's an issue. One of the things my colleagues have found in looking at the high reliability that we've seen in nuclear power plants, and actually earlier we went to and talked to people at the FAA and some other organizations. Money, the concept of market thinking there's a lot of research in cognitive psychology about how people think differently in terms of market norms as opposed to social norms. So when market thinking comes into play, then people will think about rational calculation of individual interests, the opposite of what they're supposed to think about when they're dealing with social norms. And so this becomes an issue with spending and with money. Why will people pay for? A lot of people don't want to pay for even what would make them safer, because first off, accidents are individuated. They don't think it's going to affect them, and there are other reasons too. But anyway, the organizations we looked at that had very good safety management regimes were managing technologies about which there was public dread. Yeah. Somebody wrote a book called The Nuclear Fear. In this country, dread of nuclear accidents, probably very well appropriate for that. Air crashes, large planes, another thing, public dread. When there's public dread, the political support for regulation and spending for safety is very simple, it's very high. When there isn't public dread, then there's a constant uphill struggle. The regulatory agencies that regulate public utilities in this country are also supposed to regulate rates. And the public will be outraged if they allow an agency, a utility, to raise rates for safety investment. But if it's nuclear, different. And so that has been a real problem. I used to tell people, they used to invite me, believe it or not, to medical conferences. They said, we want to be as reliable as in medicine as they are in nuclear power. How can, and the first thing I used to, well, not the first thing, it was the last thing, was you want to get support for regulation and spending for safety like they do in other, like nuclear. You got to tell people that when they go to a medical facility, it's out to kill them. You got to scare them to death. Then maybe you will have the support. What you have without dread is basically people have a retrospective view of safety. That is, after there's a big accident, Well, how could they let that happen? That's disgusting. We need to spend more. That fades away after 3 or 4 years. People don't even notice. The nice thing about dread is it's prospective and it's stable. So you asked me about spending. Well, I would say, you got to scare people or do something to put a foundation of social norms under approval of those expenditures. And by the way, once I said that, I'd never been invited to a medical conference again.
That's great. Thanks, Paul. I mean, there is, there is quite a tension or a challenge there. I think we were discussing earlier on in the event around the importance of I suppose regulatory action as maintaining public confidence and security in the sense of a service in aviation or whatever it might be. But as you say, there is that sort of exists in tension with this collective sense that a system is highly hazardous and it's legitimate to spend serious amounts of money and on protection and reliability and these sorts of things, which, as you say, I think is not widely recognised certainly in healthcare. The example I often use, given the dire staffing levels that you often find, just routinely certainly in the English health system, is compare it to a nuclear plant where they have enough staff to have sort of one team in the simulator, one team off work, and one team running the plant at the same time. And in healthcare, you're barely covering a shift with you're lucky if you've got a full cohort to even cover a shift. So yeah, there is something there around the sort of the public dread and the political will that goes with that to support efforts for I guess capacity building and the rest.
Right. The thing that's interesting in this country, I don't know if it's the case in Europe, I suspect maybe not. Politicians and even regulators treat the public as if they are infants with respect to risk. All they want to offer is assurance. Oh, don't worry about it. We are making this safe. It's safer than it's ever been. They give that lesson to the public. They don't ever tell the public, this is risky. You are going to have to pay more if you want to have this to become significantly safer. It's going to require big investments and probably you have to spend more. Rather than give this and let the public choose, in the sense of knowledge of it, what they're willing to spend for, as opposed to constantly trying to reassure them that, things are safe, don't worry about it. And then there's an accident, and then the regulator comes back, oh yeah, that was bad, but now took care of that now. It's as safe as it's ever been. All of the effort to reassure makes people, it denies a rational, mature calculus about how much safety they're willing to spend for.
You've provoked me again, Paul.
Excellent.
Well, you may know that some regulators work on a cost recovery basis. In other words, they recover fees from the industry for the certificates that they grant. Do you think that has a distorting effect on the public ethos or not? It's more like the polluter pays principle, isn't it? Where you want a certification, you're the people who are going to benefit from the certification. You should pay for it, Airbus or Boeing. What do you think of that way of operating as opposed to it being funded from public resources?
Well, I think the negative side effect of that is that the regulator knows that don't make them mad, for God's sakes, because they're paying us in order to have this license. So maybe it could threaten the licensee, but it could also make the people in the agency think twice about it. There's another side of that, and that is we work in California. We have a public utility commission that regulates for safety through the medium of fines and punishment. It has just fined PG&E, utility of the gas electric, $3 billion for accidents that for line failures that have led to forest fires, other things. Fortunately, it doesn't get those monies. It goes to the state fund. But imagine if you had a regulator that actually fined and got the money for the fine. Then you have the opposite stream. So I don't know, this business of paying the regulator is a little bit confusing, especially if the regulator gets the money for the fees or the fines. So by the way, just one question. In Europe, would a regulator rescind the license of a utility if it violated your safety rules?
I think you have almost a different arrangement per industry. I wouldn't be really in a position to answer that question. In aviation, certainly you can withdraw a certificate. You can withdraw an approval. It's done. There are reasons to do that if an organization is bankrupt, or if there are criminal charges against that organization. We have the concept of unapproved parts as well, bogus parts. So, criminal, there are people who act with criminal intent in the aviation business, and the regulators do go after them.
Well, that makes sense.
No, I can see Cengiz is keen to come in. Cengiz.
I'm sorry, I've been provoked as well. John and I have regular discussions about these topics. So I typed in some comments earlier on, and I think I don't know much about the US system, but certainly even across Europe, there's so much sort of variety in terms of funding models of regulators. As John suggested, there are countries and even the EASA that the industry pays, and then there are other countries that the regulator, every single person is paid from the public purse. And of course, if you're talking about aviation specific, then the question is raised, if someone's just flying once a year or not at all, why should they pay? Those kind of questions arise. Well, not huge problem, I guess. But the other aspect of industry paying, and I think I've watched hours on end, a number of different public hearings. It was mainly maybe in the US, but certainly the moment that you introduce the fee arrangement and the moment that money exchanges, people then expect to be treated as customer. And certainly at that point, I think back in after 2007-8, airworthiness directives across the industry, big issues. There were lots of discussions around what's the role of FAA, but it's also whether the FAA should treat the industry as their customers or not. So I think inevitably there is that you're creating that expectation the moment that you're introducing the fee funding model. Because people say, okay, I paid this fee, when am I going to get my service? And I think that's rather challenging.
Yeah, thank you, Cengiz. Yeah, there's certainly those transactional issues of a sort of fee for service in
and the last point, if I may, that it's sort of, if you look at across the particular business aviation world, different regulatory authorities, not maybe so big countries, they actually pitch business. You look at their website and say, look, this is exactly our turnaround time, how many days you can set up an AOC, how many days we can assure you that we will issue a C of A. Of course, that's providing that they meet the real rules, but it's almost like a competition in different registries. That sometimes that happens as well from regulators.
Well, thank you. I mean, I think that was a really fascinating discussion, and I think quite a thought-provoking presentation to end on as well. So thank you, Paul. That was great, and I hope we can carry on those sorts of conversations as well.
I'd like to do that. And any of you, right? There's as much closure in this stuff as a piece of Swiss cheese at the moment. So I'm desperately in need of finding ways to develop this if it's worth it. But thanks for having me, for listening.
Brilliant. No, that's great. Thank you. Well, Rune, shall we perhaps it's time to sort of broadly bring the event to a close, and I suppose perhaps if I can just say thank you to everyone who's joined and participated, and been very active discussions going on in the chat and online. So it was fantastic to see. I'm really grateful to our presenters and speakers. It's been I think a fantastic sort of diverse set of presentations, and something that I think Rune and I really only started putting this together for fairly recently at short notice, really trying to think about how can we start this sort of conversation, particularly given this week is the 3-year anniversary of the Ethiopian crash and the grounding of the fleet. So it felt a timely moment to start these sorts of conversations, despite the fact obviously the regulatory ramifications and changes are still percolating through the system. So yeah, I think certainly I'm keen to continue these sorts of conversations. Really, I think that the intent was that this was hopefully the start of something rather than the end of something. There's a number of things we've been thinking about, whether it's perhaps hosting another session in future and an appropriate time. Perhaps there's a panel event that we could put together and bring together other perspectives, and perhaps there's even I'm interested certainly in exploring an idea of an edited volume or something that brings together a range of different perspectives, perhaps over a longer time frame, but thinking about what that might look like, from how we can really learn as much, sort of squeeze the juice out of the terrible tragedies of the Max events, and but this really extraordinary set of inquiries which have unfolded, and really I think it's quite a unique event for safety and risk and reliability. So yeah, I'm certainly keen for us to, as a small initial group, to think about how we might take this forward. So Rune, perhaps I could hand off to you as a sort of for final thoughts.
Yeah, no, and thank you, Carl, for being the master of ceremonies today and guiding us through the various presentations. A big thank you to all of our speakers and for the attendees today. We will post the PowerPoints and at some point the recording online, so you can go back and revisit it. But as Carl said, our intent here was for this to be the start of a more longer extended conversation. So we'll cycle back with everyone to look at scheduling some additional workshop, maybe some discussion sections. My personal intent here is to leverage this group of safety professionals to make a meaningful difference. So we're not hoping somebody else is going to enhance safety, but we're part of that implementation and making safety better. And if that's as little as just forming a support group so that people can get some reassurance that they're doing the right thing, then I think that would be success. So thanks again to everyone for participating today, and till we meet again.
Wonderful. Thank you, Ian, and thank you, everyone. Great to see you, and take care.
Thanks, everyone. Thanks, Rune.
Thanks.